Spring architecture. Here you can see an overview of the Spring framework. Here you can see the Spring framework runtime. So here you can see the modules of Spring architecture also. The Spring framework is an application framework and inversion of control container for the Java platform. The framework's core features can be used by any Java application, but there are extensions for building web applications on top of the Java EE Enterprise Edition platform. Although the framework does not impose any specific programming model, it has become popular in the Java community as an addition to the Enterprise Java Beans EJB model. The Spring framework is open source. Here you can see another Spring framework architectural diagram. The Spring framework is a layered architecture which consists of several modules. All modules are built on top of its core container. These modules provide things that a developer may need for use in the enterprise application development. This always free to choose what features he needs and eliminate the modules which are of no use. Its modular architecture enables integration with other frameworks without much hassle. The core modules provides the dependency injection feature, which is the basic concept of the Spring framework. This module contains the bean factory and implementation of factory pattern, which creates the bean as per configurations provided by the developer in an XML file. AOP module, the aspect oriented programming module, allows developers to define method interceptors and point cuts to keep the concerns apart. It is configured at runtime, so the compilation step is skipped. It aims at declarative transaction management, which is easier to maintain. DAO module, this provides an abstraction layer to the low-level task of creating a connection, releasing it, etc. It also maintains a hierarchy of meaningful exception rather than throwing a complicated error codes from specific database vendors. It uses AOP to manage transactions. Transaction can also be managed programmatically. ORM module, Spring doesn't provide its own ORM implementation but offers integration with popular object relational mapping tools like Hibernate, iBetis, SQL maps, Oracle top links, and JPA, etc. JEE module, it also provides support for JMX, JCA, EJB, and JMS, etc. In lots of cases, JCA, Java EE Connection API, is much like JDBC, except where JDBC is focused on database. JCA focus on connecting to legacy systems. Web module. Spring comes with MVC framework, which eases the task of developing web applications. It also integrates well with the most popular MVC frameworks, Struts, Tapestry, JSF, Wicked, etc. Here you can see AOP, and you can see aspects J inside it, and here you can see DAO and JDBC transaction management is there inside, and here you can see ORM, Hibernate, JPA, Toplink, JDO, OJB, IBET is inside it, and here you can see JE, JMX, JMS, JCA, remoting, EJBs, email inside it, and here you can see web, MVC, JSC, JSP, Jasper reports are there inside, and here you can see core. Here you can see IOC container, also known as DI container. Here you can see a usage scenario. Here the typical full-fledged Spring Web application. The building blocks make Spring a logical choice in many scenarios, from embedded applications that run on resource-constrained devices to full-fledged enterprise applications that use Spring's transaction management functionality and web framework integration. Here, the Spring's declarative transaction management features make the web application fully transactional, just as it would be if you used EJB container managed transactions. All your custom business logic can be implemented with the with simple POJOs and managed by Spring IOC container. Additional services include support for sending email and validation that is independent of the web layer, which lets you choose where to execute validation rule. Spring ORM support. Spring's ORM support is integrated with JPA and Hibernate. For example, when using Hibernate, you can continue to use your existing mapping files and standard Hibernate session factory configuration. Form controllers seamlessly integrate the web layer with the domain model, removing the need for action forms or other classes that transform HTTP parameters to values for your domain model. Here you can see a Tomcat Servlet container here, and here you can see Spring Framework runtime, and inside it you can see web Servlet core container, and inside it beans core context and expression language are there, and here you can see AOP instrumentation, transactions, and ORM. Then you can see here form controller, multi-part resolver, dynamic binding to domain model, integration with JSP, velocity, SLT, PDF, Excel. Here you can see web application context, and here you can see custom domain logic, and this is sending email, and here remote access, and here you can see declarative transactions for POJOs, ORM mappings, custom DAO repositories. Here you can see the Spring middle tier using a third-party web framework. Sometimes circumstances do not allow you to completely switch to a different framework. The Spring framework does not force you to use everything within it. It is not an all or nothing solution. Existing front end built with struts, tapestry, JSF or other UI frameworks can be integrated with a Spring based middle tier, which allows you to use Spring transaction features. You simply need to wire up your business logic using an application context or and use web application context to integrate your web layer. Here you can see a Tomcat Servlet container and Spring framework runtime. Here you can see a web front end using struts or tapestry. Here you can see a web application context, and here domain custom domain logic. Here declarative transactions for POJOs, and ORM mappings, custom DAO repositories. Here you can see a remoting usage scenario. When you need to access existing code through web services, you can use Spring Hessian RMI or HTTP invoker proxy factory bean classes, enabling remote access to existing applications is not difficult. Here you can see a Tomcat Servlet container, and here you can see a Spring framework runtime, and you can see here JX RPC client, Hessian client, Burlap client, RMI client, and here transparent remote access and custom domain logic. Here you can see EJB's wrapping existing POJOs. The Spring framework also provides an access and abstraction layer for enterprise Java beans, enabling you to reuse the existing POJOs and wrap them in stateless session beans for use in scalable, fail-safe web applications that might need declarative security. Here you can see application server, for example, WebSphere, WebLogic, JBoss, and here you can see Spring framework runtime, and here you can see EJB access layer using SLSB invokers, and here you can see Spring manage EJBs using abstract enterprise bean. Now we are focusing on data access integration. The data access integration layer consists of the JDBC ORM, OXM, JMS, and transaction modules. Now we are focusing on JDBC. The Spring JDBC module provides a JDBC abstraction layer that removes the need to do tedious JDBC coding and passing of database vendor specific error codes. Here you can see major components of Spring JDBC framework. The designers of Spring have done that have come out with an ultra thin, robust, and highly extensible JDBC framework. The fixed parts like retrieving connection, preparing the statement object, executing query, and releasing the database resources have been written once and correctly. So part of this framework helps to eliminate the shortcomings found in traditional JDBC based DAO. This figure shows the major building blocks of the Spring JDBC framework. The business service objects continue to use DAO implementation classes through appropriate interfaces. JDBC DAO support is the superclass for JDBC data access objects. It is associated with a particular data source. The Spring inversion of control IOC container, or the bean factory, is responsible for getting the appropriate data source configuration details and associating them with JDBC DAO support. The most important functionality of this class is to make the JDBC template object available to the subclasses. And here you can see data source. JDBC template is the most important class in the Spring JDBC framework. To quote the documentation, it simplifies the use of JDBC and helps to avoid common errors. It executes core JDBC workflow, leaving application code to provide SQL and extract results. This class helps separate the static parts of JDBC DAO code by performing this boilerplate task: retrieves connection from the data source, prepares appropriate statement objects, execute SQL CRUD operations, iterates over result sets, and populates the results in standard collection objects. Handles SQL exceptions and translate them to a more error-specific exceptions hierarchy. Here you can see the Spring framework is here, and outside the Spring framework, you can see JDBC driver and RDBMS here. Here for example, employee business service IMPL uses employee DAO IMPL here, for example, and for example, employee DAO IMPL extends JDBC template. Here RDBMS interacts with JDBC driver. JDBC driver uses JDBC template, and JDBC template uses JDBC driver. JDBC template uses data source. Spring config uses bin factory, and bin factory sets data source. Here employee business service IMPL, employee DA IMPL, JDBC template, data source, bin factory, and Spring config is inside Spring framework. Here you can see JDBC modules. From low level API to higher level API. You can see here JDBC, more boilerplate, manage DB connection lifecycle, prepare and execute SQL statements, process exceptions, handle transactions, SQL java.sql asterisk. JDBC interacts with Spring JDBC, less boilerplate. Reason in terms of database tables, JDBC template, simple JDBC insert, SQL exception, etc. JDBC Spring JDBC interacts with Spring Data JDBC, less abstraction, reason in terms of domain model, but may have to write some SQL, no JPA features, easier learning curve, SQL statements run when repository called, return objects fully loaded. Spring Data JDBC interacts with Spring Data JPA, more abstraction, caching, lazy loading, derived queries, pagination. Reason in terms of domain model, not database tables, similar to Hibernate, Eclipse link, top link. Here you can see Maven. Here you can see the artifact ID Spring-JDBC, Spring JDBC. Spring JDBC provides an abstraction layer that simplifies code to use JDBC and the passing of database vendor specific error codes. Here you can see version. As an example too, we can consider package org.springframework.jdbc. The classes in this package make JDBC easier to use and reduce the likelihood of common errors. In particular, they simply error handling, avoiding the need for try catch finally block in application code, present exceptions to application code in a generic hierarchy of unchecked exceptions, enabling application to catch data access exceptions without being dependent on JDBC, and to ignore fatal exceptions there is no value in catching. Allow the implementation of error handling to be modified to target different RDBMSs without introducing proprietary dependencies into application code. As an example 3, we can consider these we are considering basically choosing an approach for JDBC database access. Choosing an approach for JDBC database access. The class JDBC template. This is the central class in the JDBC core package. It simplifies the use of JDBC and helps to avoid common errors. It executes core JDBC workflow, leaving application code to provide SQL and extract results. This class execute SQL queries or updates, initiating iteration over result sets and catching JDBC exceptions and translating them to the generic, more informative exception hierarchy defined in the org.springframework.dao package. This is in org.springframework.jdbc.core package. The class named parameter JDBC template class with a basic set of JDBC operations, allowing the use of named parameters rather than traditional question mark placeholders. This is in a package org.springframework.jdbc.core.named param. Class simple JDBC insert. A simple JDBC insert is a multi-threaded reusable object providing easy insert capabilities for a table. It provides metadata processing to simplify the code needed to construct a basic insert statement. All you need to provide is the name of the table and a map containing the column names and column values. This is in the package org.springframework.jdbc.core.simple. The class simple JDBC call. A simple JDBC call is a multi-threaded reusable object representing a call to a stored procedure or a stored function. It provides a metadata processing to simplify the code needed to access basic stored procedures functions. All you need to provide is the name of the procedure function and a map containing the parameters when you execute the call. The names of the supplied parameters will be matched up with in and out parameters declared when the stored procedure was created. This is in the package org.springframework.jdbc.core.simple, and we can also consider RDBMS objects. You can choose among several approaches to form the basis for your JDBC database access. In addition to the three flavors of JDBC template, a new simple JDBC insert and simple JDBC call approach optimizes database metadata, and the RDBMS objects RDBMS object style takes a more object-oriented approach similar to that of JDO core redesign. Once you start using one of these approaches, you can still mix and match to include a feature from different approach. All approaches require a JDBC 2.0 compliant driver, and some advanced features require a JDBC 3.0 driver. JDBC template is the classic and most popular string JDBC approach. This lowest level approach and all other use of JDBC template under the covers. Named parameter JDBC template wraps a JDBC template to provide named parameter instead of traditional JDBC question mark placeholders. This approach provides better documentation and ease of use when you have multiple parameters for an SQL statement. Simple JDBC insert and simple JDBC call optimize database metadata to limit the amount of necessary configuration. This approach simplifies coding so that you need to provide only the name of the table or procedure and provide a map of parameters matching the column names. This works only if the database provides adequate metadata. If the database does not provide this metadata, you have to provide explicit configuration of the parameters. RDBMS objects, including mapping, SQL query, SQL update, and stored procedure, require you to create reusable and thread-safe object during initialization of your data access layer. This approach is modeled after JDO query, wherein you define your query string, declare parameters, and compile the query. Once you do that, execute method, update method, and find object methods can be called multiple times with various parameter values. As an example 4, we are considering package hierarchy. The Spring Framework's JDBC abstraction framework consists of 4 different packages. Package org.springframework.jdbc.co provides the core JDBC framework based on the JDBC template and its associated callback interfaces and helper method objects. Package org.springframework.jdbc.dataSource provides a utility class for easy data source access, a platform transaction manager for a single data source, and various simple data source implementations. Package org.springframework.jdbc.object. The classes in this package represent RDBMS queries, updates, and stored procedures as thread-safe reusable objects. Package org.springframework.jdbc.support support classes for the JDBC framework used by the classes in the JDBC.core and JDBC.object packages. The Spring Framework's JDBC abstraction framework consists of 4 different packages. Core, the org.springframework.jdbc.core package contains the JDBC template class and its various callback interfaces plus a variety of related classes. A subpackage named org.springframework.jdbc.core.simple contains the simple JDBC insert and simple JDBC call classes. Another subpackage named org.springframework.jdbc.core.named contain named parameter JDBC template class and the related support classes. Data source. The org.springframework.jdbc.datasource package contains a utility class for easy data source access and various simple data source implementation that you can use for testing and running unmodified JDBC code outside of a Java EE container. A subpackage named org.springframework.jdbc.datasource.embedded provides support for creating embedded databases using Java database engines such as HSQL and HSQL, H2 and Derby. Object. The org.springframework.jdbc.object package contains classes that represent RDBMS queries, updates, and stored procedures as thread-safe reusable objects. This approach is modeled by JDO, although objects returned by queries are naturally disconnected from the database. This high-level JDBC abstraction depends on the lower-level abstraction in the org.springframework.jdbc.core package. support, the org.spring framework jdbc.support package provide SQL exception, transaction functionality, and some utility classes. Exceptions thrown in JDBC processing are translated to exceptions defined in the org.springframework.dao package. This means that code using the Spring JDBC abstraction layer does not need to implement JDBC or RDBMS specific error handling. All translated exceptions are unchecked, which gives you the option of catching the exceptions from which you can recover while letting other exceptions to be propagated to the caller. As an example 5, we can consider using the JDBC core classes to control basic JDBC processing and error handling. Following query gets the number of rows in a relation. The class JDBC template here. This is the central class in the JDBC core package. It simplifies the use of JDBC and helps to avoid common errors. It executes core JDBC workflow, leaving application code to provide SQL and extract result. This class executes SQL queries or updates, initiating iteration over result sets and catching JDBC exceptions and translating them to a generic, more informative exception hierarchy defined in the org.springframework.dao package. This class is in package org.springframework.jdbc.core. JDBC template is the central class of the JDBC core package. It handles the creation and release of resources, which helps you to avoid common errors such as forgetting to close the connection. It performs the basic tasks of core JDBC workflow such as statement creation and execution, leaving application code to provide SQL and extract results. The JDBC template class runs SQL queries, perform iteration over result set instances and extraction of return parameter values, catches JDBC exceptions and translate them to a generic, more informative exception hierarchy defined in the org.spring.dao package. When you use the JDBC template for your code, you need to only implement callback interfaces, giving them a clearly defined contract. Given connection provided by the JDBC template class, the prepared statement create a callback interface creates the prepared statement providing SQL and necessary parameters. The same is true for the callable statement creator interface, which create the callable statements. The rollback handler interface extract values from each row of the result set. You can use JDBC template within DAO implementation through direct instantiation with the data source reference, or you can configure it in the Spring IOC container and give it to a DAO as a bean reference. All SQL issued by this class is logged at the debug level under category corresponding to the fully qualified class name of the template instance in typically JDBC template, but it may be different if you use custom subclass of the JDBC template class. Here the method at nullable public t query for object string SQL class t required type. This execute a query for a result object given static SQL. Here the first parameter is string SQL, the SQL query to execute. This is a class T required type, the type that the result object is expected to match, and this method returns the result object of the required type or null in the case of null. And there are other JDBC core classes to control basic JDBC processing and error handling. The one is using named parameter JDBC template. Another one using SQL exception translator and running likewise. As an example SIG, we are considering using data source in controlling database connections. This example shows how to configure a driver manager data source in Java. The class driver manager data source, a simple implementation of the standard JDBC data source interface, configuring the plain old JDBC driver manager via bean properties and returning a new connection from every get connection call. This is in package org.springframework.jdbc.data source. Spring obtains a connection to the database through a data source. Data source is part of the JDBC specification and is a generalized connection factory. It lets a container or a framework hide connection, pooling, and transaction management issues from the application code. As a developer, you need to know the details about how to connect to the database. That is the responsibility of the administrator who set up the data source. You the most likely fill the both roles as you develop and test code, but you do not necessarily have to know how the production data source is configured. When you use the Spring's JDBC layer, you can obtain a data source from GNDI, or you can configure your own with a connection pool implementation provided by the third party. Traditional choices are Apache Common DBCP and C3P0 with bean style data source classes. For a modern JDBC connection pool, consider Hikari CP with its build style API instead. You should use the driver manager data source and simple driver data source classes as included in Spring distribution only for testing purposes. Those variants do not provide pooling and perform poorly when multiple requests for a connections are made. This section uses Spring's the driver manager data source implementation. There are several other data source variants are there. To configure driver manager data source, step 1, obtain a connection with driver manager's the data source as you typically obtain a JDBC connection. Step 2, specify the fully qualified class name of the JDBC driver so that the driver manager can load the driver class. Step 3, provide the URL that varies between JDBC driver. And step 4, provide a username and password to connect to a database. And this example shows the corresponding XML configuration. And there are other ways to control database connection, like using data source utils, implementing smart data source, extending abstract data source, using single connection data source, using driver manager data source, using transaction aware data source proxy, and using data source transaction manager. Here, as an example, we are considering basic batch operations with JDBC template in JDBC batch operations. The following examples update t_actor table based on the entries based on entries in a list, and the entire list is used as a batch. The public int array batch update string SQL and batch prepare statement setter PSS issue multiple update statements on a single prepared statement using batch updates and batch prepared statement setter to set values. This is in the class org.springframework.jdbc.core.jdbc template. You accomplish JDBC template batch processing by implementing two methods of a special interface: batch prepared statement setter, and passing that implementation in as a second parameter in a batch update call. You can use get batch size method to provide the size of the current batch. You can use the set values method to set the values for the prepared for the parameters of the prepared statement. This method is called the number of this method is called the number of times that you specified in the get batch size call. This example updates the t underscore actor table based on the entries in a list. And the entire list is used as a batch. If you process a stream of updates or reading from a file, you might have a preferred batch size, but the last batch might not have that number of entries. In this case, you can use interrupted batch interruptible batch prepared statement setter interface, which lets you you interrupted batch once the input source is exhausted. The isBatch exhausted method let you signal the end of the batch. And here you can put additional methods. Most JDBC drivers provide improved performance if you batch multiple calls to the same prepared statements. By grouping updates into batches, you limit the number of round trips to the database. That's the advantage here with batch operations. As an example 8, we are considering simplifying JDBC operations with the simple JDBC classes. Here we are considering actually inserting data by using simple JDBC insert. This example uses only one configuration method. The class simple JDBC insert. A simple JDBC insert is a multi-threaded reusable object providing easy insert capabilities for a table. It provides metadata processing to simplify the code needed to construct a basic insert statement. All you need to provide is the name of the table and a map containing column names and the column values. This is in the package org.springframework.jdbc.core.simple. The simple JDBC insert and simple JDBC call classes provide a simplified configuration by taking advantage of database metadata that can be retrieved through the database driver. This means that you have less to configure upfront, although you can override or turn off the metadata processing if you prefer to provide all the details in your code. We start by here inserting data by using simple JDBC insert. We start by looking at the simple JDBC insert class with the minimal amount of configuration options. You should instantiate the simple JDBC insert in the data access layers initialization method. For this example, the initialization method is the set data source method. You do not need to subclass the simple JDBC class. Instead, you can create a new instance and set the table name by using with table name. With table name method. Configuration methods for this class follow fluid style that returns the instance of the simple JDBC insert, which let you to chain all configuration methods. This example uses only one configuration method. The execute method used here takes a plain java.util map as its only parameter. The important thing to note here is that the keys used for the map must match the column names of the table as defined in the database. This is because we read the metadata to construct the actual insert statement. We can put additional methods here. As an example 9, we are considering using mapping SQL query in modeling JDBC operations as Java objects. This example shows a custom query that maps the data from T actor T underscore actor relation to an instance of an actor class. the class mapping SQL query T, the reusable query which concrete subclasses must implement. The abstract map row result set int method to convert each row of the JDBC result set into an object. This class is in package org.springframework.jdbc.object. The org.springframework.jdbc.object package contains classes that let you access database in more object-oriented manner. As an example, you can run queries and get results back as a list that contain business object with the relational column data map to the properties of the business object. You can also run stored procedures and run update, delete, and insert statements. Many Spring developers believe that the various RDBMS operation classes described can be often be replaced with the straight JDBC template calls. Often it is simpler to write DAO method that calls a method on JDBC template directly as opposed to encapsulating a query as a full blown class. However, if you are getting measurable value from using the RDBMS operation classes, you should continue to use these classes. This is about modeling JDBC operations. Now we are focusing on using mapping SQL query. Mapping SQL query is a reusable query in which concrete subclass must implement the abstract map row method to convert each row of the supplied result set into an object of type specified. This example shows a custom query that maps data from t_actor into an instance of the actor class. The class extends mapping SQL query parameterized with the actor type. The constructor for this customer query takes the data source as only parameter. In this constructor, you can call the constructor on the superclass with the data source and the SQL that should be run to retrieve the rows for this query. The SQL is used to create prepared statements, so it may contain placeholders for any parameter to be passed during execution. You must declare each parameter by using declare parameter method, passing passing an SQL parameter. The SQL parameter takes a name and the JDBC type defined in java.sql.types. After you define all parameters, you can call a compile method so that the statement can be prepared and later run. this class is thread safe after it is compiled. So as long as these instances are created when DAO is initialized, they can be kept as instance variables and be reused. This example shows how to define such a class. The method in this example retrieves a customer with ID that is passed in as a only parameter. Since we want only one object to be returned, we call the find object convenience method with the ID as the parameter. If we had instead a query that returned a list of objects and took additional parameters, we would use one of the execute method that takes an array as a parameter values passed in as var args. This example shows such a method. As an example 10, we are considering common problems with parameter and data value handling. We are here considering handling blob and clob objects. This example shows how to create and insert a blob. The interface lob handler, an abstraction for handling large binary fields and large text fields in specific databases, no matter if represented as simple types or large blobs. This is in package org.springframework.jdbc.support lobby. You can store images, other binary data, and large chunks of text in the databases. These large objects are called blobs, binary large objects for binary data, and clobs, character large objects for character data. In Spring, you can handle these large objects by using the JDBC templates directly, and also when using the higher abstractions provided by RDBMS objects and the simple JDBC classes. All of these approaches use an implementation of LOB handler interface for the actual arrangement of LOB large object data. LOB handler provides access to a LOB creator class through get LOB creator. method that is used for creating new LOB objects to be inserted. LOB handler and LOB creator or lob creator provide this following support for LOB input. For blob, byte array, get blob as bytes and set blob as bytes. Input stream, get blob as binary stream and set blob as binary stream. In club string, get club as string and set club as string. Input stream, get club as ASCII stream and set club as ASCII stream. Reader, get club as character stream and set club as character stream. This example shows how to create an insert blob. Later we show how to read it back from the database. This example uses JDBC template and an implementation of abstract lob creating prepared statement callback. It implements the one method, set values. This method provides lob creator that we use to set values for the LOB columns in your SQL statement. This example shows how to create and insert blob. Here, pass the lob handler that in this example as a plain default lob handler. Here, using the method set glob as character stream to pass the contents of the glob, and here using the method set blob as binary to pass the contents of the blob. If you invoke set blob as binary stream or set glob as ASCII stream or set glob as character stream method on the lob creator, return from the default lob handler.get lob creator. You can optionally specify negative value for the content length argument. If you specified the content length is negative, the default lob handler uses JDBC 4.4 variant of the set stream methods without length parameter. Otherwise, it passes specified length onto the driver. Here the interface lob creator interface that abstracts potentially database specific creation of large binary fields and large text files does not work with java.sql.blob and java.sql.glob instances in the API, as some JDBC drivers do not support these type as such. Here the method set void set club as character stream, prepared statement ps, and this is int index int param index, and read a character stream, and the int content length. Set the given content as a stream, as a character stream on the given statement using the given parameter index. And here set blob as binary stream, prepared statement ps, and int param index, and input stream content stream. And int content length sets a given content as a binary stream on the given statement using the given parameter index. Now it's time to read the LOB data from the database. Again, you use the JDBC template with the same instance variable lob handler. And a reference to the default lob handler. This example shows how to do so. Here, using the method get club as string to retrieve the contents of the club, and here using the method get glob as string to retrieve the content of the blob. Here, if you want to expose an embedded database instance as an bean in a Spring application context, you can use embedded database tag in the Spring JDBC namespace. With embedded database support, the org.springframework.jdbc.datasource.embedded package provides support for embedded Java database engines. Support for HSQL, H2, and Derby is provided natively. You can also use an extensible API to plug in new embedded database types and data source implementation. An embedded database can be useful during the development phase of project because it's a lightweight nature. Benefits include ease of configuration, quick startup time, testability, and ability to rapidly evolve with your SQL during development. If you want to use here we are creating an embedded database by using Spring XML. If you want to expose an embedded database instance as a bean in a Spring application context, you can use embedded database tag in the Spring JDBC namespace. This configuration creates an embedded HSQL database that is populated with SQL from schema.sql and test-data.sql resources in the root of the class path. In addition, as a best practice, the embedded database is assigned to a uniquely generated name. Embedded database is made available to the Spring container as a bean type javax.sql.data source that can be injected into data access object as needed. Now we are considering creating an embedded database programmatically. You can use this when you need to create an embedded database in a standalone environment or in a standalone integration test, as in this example. The class embedded database builder, a builder that provides the convenient API for constructing an embedded database. This is in org.springframework.jdbc.datasource.embedded package. And here you can see the interface embedded database. Embedded database serves as a handle to an embedded database instance. This is in the package org.springframework.jdbc.datasource.embedded. Here perform actions against the DB embedded database extend javax.sql.datasource. Here generate unique name, specify whether a unique ID should be generated and used as the database name. Set the type of the embedded database, and set script encoding. Specify the character encoding using the all scripts is the difference from the platform encoding, and ignore failed drops. Specify that the failed SQL drop statement within an executed script can be ignored, and add the script add an SQL script to execute to initialize or populate the database, and add the scripts. Add multiple SQL scripts to execute to initialize or populate the database, and build the embedded database. As an example 13, we are considering initializing database by using Spring XML. We are considering about initializing a data source. If you want to initialize a database, and you can provide reference to a data source bean, you can use initialize -database tag in the Spring JDBC namespace. With initializing a data source, the org.springframework.jdbc.datasource.init package provides support for initializing an existing data source. The embedded database support provides one option for creating and initializing a data source for an application. However, you may sometimes need to initialize an instance that runs on a server somewhere. This example runs the two specified script against the database. The first script creates an schema, and the second populates the tables with a data set. The script locations can also be patterns with wildcards in the usual ant style used for resources in Spring. For example, class path asterisk colon forward slash asterisk SQL forward slash asterisk dash data dot SQL. If you use a pattern, the scripts are run in the lexical order of their URL or file name. The default behavior of the database initializer is to unconditionally run the provided scripts. This may not always be what you want. For instance, if you run the scripts against the database that already has test data in it, the likelihood of accidentally deleting is reduced by following the common pattern shown here of creating the tables first, then inserting the data. The first step fails if the database tables already exist. As an exception example, we can consider this using SQL exception translator. You can extend SQL error code, SQL exception translator as in this example. The class SQL error code SQL exception translator, the implementation of an exception translator based on the SQL translator that analyzes vendor specific error codes, more precise than the implementation based on SQL state but heavily vendor specific. This is in the package org.springframework.jdbc.support. The SQL exception translator is an interface to be implemented by classes that can translate between SQL exceptions and Spring's own org.springframework.dao.data access exception. This which is agnostic in regard to data access strategy. Implementation can be generic, for example using SQL state codes for JDBC, or proprietary, for example using Oracle error codes for greater precision. The SQL error code SQL exception translator is the implementation of SQL exception translator that is used by default. This implementation uses specific vendor codes. It is more precise than the SQL state implementation. The error code translations are based on codes held in a Java Bean type class called SQL error code. This class is created and populated by SQL error code factory, which is, as the name suggests, a factory for creating SQL error codes based on the content of the configuration file named sql-error-codes.xml. This file is populated with vendor codes and based on the database product name taken from database metadata. Codes for actual database you are using are used. The SQL error code exception translator applies matching rules in the following sequence. One, any custom translation implemented by a subclass, normally the provided concrete SQL error code SQL exception translator is used, so this run does not apply. It apply only if you have actually provided a subclass implementation. Any custom implementation of SQL exception translate interface that is provided as the custom SQL exception translate property of the error code SQL error code class. The list of instances of the custom error code translation class provided for the custom translation property of SQL error code class are searched for a match. 4 error code matching is applied. 5 use the fallback translator. SQL exception subclass translator is the default fallback translator. This translation is not available. The next fallback translator is the SQL state SQL exception translator. SQL error code factory is used by default for defined error codes and custom exception translations. They are looked up in a file name SQL-error-codes.xml from the class path, and matching SQL error code instances is located based on the database name from the database metadata of the database in used. You can extend SQL error code SQL exception translator as in this example. In this example, the specific error code -12345 is translated while other errors are left to be translated by the default translator implementation. To use this custom translator, you must pass it to the JDBC template through the method setExceptionTranslator. And you must use this JDBC template for all the data access processing where this translate is needed. This example shows how you can use this translator. The custom translator is passed the data source in order to look up the error codes in SQL-error-codes-.xml. Here create a database and create a JDBC template and set a data source. Here create a custom translator and set the data source for the default translation lookup. Here use the prepared JDBC template for this update. As an exception example 2, we can consider class bad SQL grammar exception. Exception thrown when SQL specified is invalid. Such exceptions always have a java.sql.SQL exception root cause. This is in the package org.springframework.jdbc. As an error example, we can consider this error message: output parameters have not yet been processed. Call get more results method. Now we are focusing on ORM. The Spring ORM module provides integration layers for popular object relational mapping APIs, including JPA and Hibernate. Using the Spring ORM module, you can use those OR mapping frameworks in combination with all the other features Spring offers, such as simple declarative transaction management feature mentioned previously. Here you can see a typical 3-layer Spring application architecture. In typical 3-layer Spring application architecture, we create 3 layers: controller, service, and DAO repository layer. If we use JPA Hibernate, then write a lot of coding while implementing DAO repository layer. provides the solution to reduce a lot of boilerplate code. We can use Spring Data JPA to reduce the amount of boilerplate code required to implement the data access object DAO layer. Spring Data JPA is not a JPA provider. It is a library framework that adds an extra layer of abstraction on top of our JPA provider like Hibernate. Here you can see controller layer interacts with service layer. Service layer interacts with DAO layer. Hibernate JPA is connected to DAO layer. DAO layer interacts with the database. The JPA methods called by the main methods of the repository interface of Spring Data JPA are shown here. The simple JPA repository class provides the default implementation of a repository interface. Simple JPA repository class internally uses JPA entity manager to map its method with the JPA entity manager interface methods. It is better to know which JPA entity manager method is being called by the methods of repository interface. Simple JPA repository class of Spring Data JPA. Here you can see save and flush method, extend t list is save and flush and s entity. Save an entity and flushes changes instantly. In void flush method flushes all pending changes to the database. This is save extend ts save s entity. This is a delete t entity. So this is void delete method, t entity method. This is delete t entity, and this is delete id, and this is find one. This is a exist method, exist id here, and this is count, and this is find all methods, and any query method here. The class simple JPA repository is a default implementation of the crude repository interface. This will offer you a more sophisticated interface than plain entity manager. The interface repository, central repository marker interface, capture the domain type of to manage, as well as the domain type types ID type. General purpose is to hold type information, as well as being able to discover interfaces that extend one during class path scanning for easy Spring Bean creation. Here we are basically considering a class simple JPA repository with these methods. And here this is simple. The class simple JPA repository is in org.springframework.data.jpa.repository.support. This is entity manager, the interface entity manager. This is in JavaX persistent package. This interface used to interact with persistent context. And here you can see flush method, void flush, synchronize the persistent context to the underlying database. Here you can see void persist with here it has object entity parameter and make an instance manage and persistent here, and you can see here merge t entity method merge the state of the given entity into the current persistent context. Here you can see a void remove object entity method, remove the entity instance. Here you can see the contain boolean contains object entity. Check if the instance is managed entity instance belongs to the current persistent context, and here you can see find methods, and here we are considering Java 7 EE API. This is a interface type query X. This is in Java x.persistence package in Java EE7. Here we are considering Java EE7. The interface used to control the execution of type queries. Here you can see get get single result, execute a select query that returns a single result, and here get list x get result list, execute a select query and return the query results as a typed list. Here you can see methods of JPA repository interface, and here you can see query methods in repository interface for entity that defined by the developer, and here save and flush is connected to flush and save. Here delete ID is connected to delete T and find one ID, and exist ID is connected to find one ID, and you can see count method, then find all and any query method, design repos, and here you can see under entity manager flush, persist, manage, remove, contains and find methods. Flush is connected to flush in entity manager, and here save is connected to persist method and merge method in entity manager. Delete here delete is connected to merge, remove and contains methods in entity manager, and find one ID is connected to find method in entity manager. And here you can see get single result and get result list in type query. Exist ID, count are connected to get single result in type query, and find all is connected to get find old, and any query method is connected to get result set here in type query. Here you can see the basic flow at the time of accessing database using Spring Data JPA. Here you can see service is connected to repository. This area is depending on the mechanism of Spring Data JPA here, and you can see entity parameters are flowing here to here and here to here and there, and below repository proxy is connected to custom repository IMPL and Spring Data simple JPA repository, and custom repository IMPL and Spring Data is, simple JPA repository is connected to JPA APIs, and you can see here entity parameters are there, and below that you can see it's connected to a Hibernate JPA reference implementation, and it's we have to consider there persistent.xml, configure persistent unit, and orm.xml, configure OR mapping, and Hibernate JPA reference implementation is connected to Hibernate core APIs, and Hibernate core APIs is connected to JDBC basic APIs, and SQL and bind values are passed from Hibernate core APIs to JDBC basic APIs, and it's connected to JDBC driver, and drive is connected to database, and SQL and bind values are passed from JDBC driver to database. We can consider this Maven example. Here you can see artifact spring-orm, Spring object relational mapping. Spring object relational mapping, which provides integration layers for popular object relational mapping APIs, including JPA, JDO, and Hibernate. As an example too, we can consider package org.springframework.orm, root package for Spring's OR mapping integration classes, contains generic data access exceptions related to OR mapping. This excerpt from an XML application context definition shows how to set up a JDBC data source and a Hibernate session factory on top of it. The class local session factory bean that creates a Hibernate session factory. This is the usual way to set up a shared Hibernate session factory in a Spring application context. The session factory can then be passed to data access objects via dependency injection, and this is in package org.springframework.orm.hibernate 5. This is about session factory setup in Spring container. To avoid tying application objects to hard-coded resource lookups, you can define resources such as JDBC data source or a Hibernate session factory as beans in the Spring container. Application objects that need to access resources receive references to such predefined instances through bean references, as shown in the DAO definition here. Actually, we can refer DAO definitions later. This expert from XML application context definition shows how to set up a JDBC data source and a Hibernate session factory on top of it. Switching from a local Jakarta Commons DBCP basic data source to a JNDI located data source usually managed by an application server is only a matter of configuration. As this example shows here. You can also access JNDI located session factory using Spring's JNDI object factory bean or /JEE JNDI lookup to retrieve and expose it. However, that is typically not common outside of an EJB context. Spring also provides a local session factory. Spring also provides a local session factory builder variant. Seamlessly integration with @bean style configuration and programmatic setup. No factory bean involved. Both the local session factory bean and local session factory builder support background bootstrapping with Hibernate initialization running in parallel to the application bootstrap thread on a given bootstrap execution, such as simple async task executor. On local session factory bean, this is available through bootstrapper executor property. On the programmatic local session factory builder, there is an overloaded build session factory method that can take the bootstrap executor argument. As of Spring Framework 5.1, such a native Hibernate setup can also expose a JPA entity manager factory for standard JPA interaction next to native Hibernate access. Here you can see implementing DAOs based on the plain Hibernate API. The corresponding DAO implementation resembled the following example based on the plain Hibernate API. The interface session factory. The main contract here is the creation of session instances. Usually an application has a single session factory instance, and threads serving client request obtain session instances from this factory. This is in org.hibernate package. Hibernate has a feature called contextual sessions, wherein Hibernate itself manages one current session per transaction. This is roughly equivalent to Spring's synchronization of one Hibernate session per transaction. A corresponding DAO implementation resembles the following examples based on the plain Hibernate API. This style is similar to that of Hibernate reference documentation and examples, except for holding session factory in an instance variable. We strongly recommend such an instance-based setup over an old school static Hibernate util class from Hibernate caveat emptor sample application. In general, we do not keep any resources in static variables unless absolutely necessary. This DAO example follows a dependency injection pattern. It fits nicely into Spring IOC container. As it would if coded against Spring's Hibernate template. You can set up such a DAO in plain Java, for example in unit test. To do so, instantiate it and call set session factory. method with the desired factory reference. As a Spring Bean definition, the DAO would resemble the following. The main advantage of DAO style is that it depends on Hibernate API only. So no import of any Spring class is required. This is appealing from non-invasiveness perspective and may feel more natural to Hibernate developers. However, DAO throws a plain Hibernate exception, which is unchecked, so it does not have to be declared to a court, which means that callers can treat exceptions only as being general fatal, unless they want to depend on Hibernate's own exception hierarchy. Catching specific causes such as optimizing locking failure is not possible without tying the caller to the implementation strategy. This trade-off might be acceptable to applications that are strongly Hibernate based and do not need any special exception treatment or both. Fortunately, Spring's local session factory bean supports Hibernate's session factory get current session method for any Spring transaction strategy, returning the current Spring managed transactional session. Even with the Hibernate transaction manager, the standard behavior of that method remains to return the current session associated with the ongoing JTA transaction, if any. This behavior applies regardless of whether you use Spring's JTA transaction manager, EJB container managed transaction, CMTs, or JTA. In summary, you can implement DAO based on the plain Hibernate API while still being able to participate in Spring managed transactions. Declarative transaction demarcation. You can annotate the service layer at transactional annotations and instruct the Spring container to find these annotations and provide transactional semantics for these annotated methods. The following example shows how to do so. The class Hibernate Transaction Manager. The platform transaction manager implementation for a single Hibernate session factory. Bind a Hibernate session from the specified factory to the thread, potentially allowing for one thread based bound session per factory. Session factory dot get current session is required for Hibernate access code that need to support this transaction handling mechanism, with the session factory being configured with Spring session context. We recommend that you use Spring's declarative transaction support, which lets you to replace explicit transaction demarcation API calls in your Java code with AOP transaction interceptor. You can configure this transaction interceptor in the Spring container using either Java annotations or XML. This declarative transaction ability lets you to keep business services free of repetitive transaction demarcation code and focus on adding business logic. This is which is the real value of your application. You can annotate the service layer with at transaction annotations and instruct the Spring container to find these annotations and provide transactional semantics for these annotated methods. Following examples show how to do so. In the container, you need to set up platform transaction manager implementation as a bean and tx colon annotation driven entry opting into a transactional processing at runtime. Following example shows how to do so. Session factory, data source, etc. omitted. In example 4, we are considering programmatic transaction demarcation. The following pair of snippets shows transaction manager and a build and a service, business service definition in Spring application context, and example for business method implementation. You can demarcate transaction in a higher level of applications on top of lower level data access span that any number of operations. No do restrictions exist in the implementation of surrounding business service. It needs only a Spring platform transaction manager. Again, the latter can come from anywhere, but preferably as a bean reference, though set transaction manager method. Also, product DAO should be set by set product DAO method. The following pair of snippets show a transaction manager and a business service definition in Spring application context, and an example for business method implementation. String transaction interceptor lets any checked application exception be thrown with the callback code. While transaction template is restricted to unchecked exception within the callback. Transaction template triggers a rollback in case of unchecked application exception or in case of unchecked application exception, or if the transaction is marked rollback only by application by setting transaction status. By default, transaction interceptor behaves the same way, but allows configurable callback policies per method. Do the price increase here? In example 5, we are considering using local entity manager factory bean in JPA setup in a Spring environment in JPA. The factory bean uses JPA persistent provider auto detection mechanism according to JPA's Java SE bootstrapping, and in most cases require you to specify the only persistent unit name. Following XML example configure such a bean. The class local entity manager factory bean that creates a JPA entity manager factory according to JPA standalone bootstrap contract. This is the simplest way to set up a shared JPA entity manager factory in Spring application context. The entity manager factory can then be passed to the JPA based DAO via dependency injection. Note that the switching to JNDI lookup or to a local container entity manager factory bean definition is just a matter of configuration. This is in the package org.springframework.orm.jpa. You can use this option only in simple deployment environments such as standalone application and integration test. The local entity manager factory bean creates an entity manager factory suitable for simple deployment environments where application uses only a JPA for data access. The factory bean uses the JPA persistent provider auto detection mechanism according to JPA's Java SE bootstrapping, and in most cases it requires you to specify the persistent unit name. The following XML example configures such a bean. The form of JPA deployment is simplest and the most limited. You cannot refer the existing JDBC data source bean definition, and no support for global transactions exist. Furthermore, weaving bytecode transformation of persistent classes is provided specific, often require a specific JVM agent to be specified on startup. This option is sufficient only for a standalone application and test environment for which the JPA specification is designed. As an example 6, we are considering implementing DAOs based on JPA. Following example shows a plain JPA DAO implementation that uses persistent unit annotation. The class persistence annotation bean post processor that processes persistence unit and persistence annotations for injection of corresponding JPA resources entity manager factory and entity manager. Any such annotated fields or method in any Spring managed object will automatically be injected. This is in the package org.springframework.orm.jpa.support. Although entity manager factory instances are thread safe, entity manager instances are not. Injected JPA entity manager behave like an entity manager fetched from the application server's GNDI environment as defined by JPA specification. It delegates all calls to current transactional entity manager, if any. Otherwise, it falls back to the newly created entity manager per operation, in effect making its usage thread safe. It is possible to write a code against the JPA without any Spring dependencies using an injected entity manager factory or entity manager. Spring can understand persistence at persistent unit and as persistence context annotation both at the field and method levels. If the persistence annotation being post processor is enabled, the following example shows a plain JPA DAO implementation that uses persistence at persistent unit annotation. This DAO has no dependency on Spring and still fits nicely into the Spring application context. Moreover, the DAO takes advantage of annotations require the injection of the default entity manager factory, as the following example being definitions show. Bean post processor for JPA annotations. Class JPA system exception. JPA specific subclass of uncategorized data access exception for JPA system errors that do not match any concrete org.springframework.dao exceptions. This is in the package org.springframework.orm.jpa. As an error example, we can consider this error occurred in the environment with STS Eclipse and MySQL database. Error created being with entity manager factory defined in class path resource org Spring Framework boot autoconfigure orm jpa hibernate jpa auto configuration class. Invocation of init method failed. Now we are focusing on OXM. The Spring OXM module provides an abstraction layer that supports object XML mapping implementations such as JAXB, Castor, JIBX, and Xstream. Here you can see the architecture of Spring Web Services. Spring Web Services, Spring WS, developed by the Spring community, focuses on the creation of document-driven web services. It facilitates the contract first SOAP service development. It can manipulate XML payloads in many ways. Spring Web Services aims to give loose coupling between WSDL contract and its Java-based implementation. Spring WS Core. This is the primary module. and it contains the central interfaces like web service message and SOAP message. The server-side framework power message dispatching capability and also support classes to implement the web service endpoints, and it also contains web service consumer clients as web service template. Spring WS support. This module contains supports for JMS, emails, etc. Spring WS security. This module contains a WS security implementation integrated with the core web service module. Also, we can add principal tokens, sign, encrypt, and decrypt SOAP messages. It allows using the existing Spring security implementation for authentication and authorization. Spring XML. It contains XML support classes for Spring Web Services. It is internally used by the Spring WS framework. Spring OXM. It contains support classes for XML versus object mapping. Features of Spring Web Services. XML mappings to object. Requests based on XML can be mapped to any object with the help of the information stored in the message payload, SOAP action header, or using an XPath expression. Multiple API support to pass XML. It supports from standard JAXP APIs, DOM, SAX, and STAX to pass the incoming XML request. It also supports other libraries like JDOM, DOM4J, XOM. Multiple API support to Marshall XML. Spring Web Services support cluster XML beans, GIBX, and Extreme libraries using its object XML mapping module. Spring-based configurations. Spring Web Services also uses Spring application context for its configurations that are having a similar architecture like that of the Spring Web MVC. Integrated WX security module. With the help of WS security module, you can sign, encrypt, decrypt, decrypt SOAP messages or authenticate them. Support for Zergi security. With the help of the WS security implementation of the Spring Web Services, accuracy configuration can also be used for your SOAP services. Here you can see Spring WS core and Spring WS support, and Spring WS security is connected to Spring WS core. Spring WS core is connected to Spring OXM and Spring XML. Here the OX mapping exception hierarchy is shown in the in this figure. A marshaller serializes an object to XML, and unmarshaller deserializes XML stream to an object. Spring converts exceptions from the underlying OX mapping tool to its own exception hierarchy with the XML mapping exception as the root exception. These runtime exceptions wrap the original exception so that no information will be lost. Additionally, marshalling failure exception and unmarshalling failure exception provide the distinction between marshalling and unmarshalling operations, even though the underlying OX mapping tool does not do so. Here the marshalling failure exception and unmarshalling failure exception are subclasses of marshalling exception. Marshalling exception and validation failure exception are subclasses of XML mapping exception. Here you can see a Maven example. Artifact here, artifact is spring-oxm, spring object XML marshalling, abstraction layer that supports object XML mapping implementations such as JAXB, Caster, XML Beans, GIBX, and Xstream. As an example too, we can consider package org.springframework.oxm, root package for Spring's OX mapping integration classes, contains generic marshaller and unmarshaller interfaces and XML mapping exceptions related to OX mapping. Here, interface marshaller defines a contract for object XML mapping marshallers. Implementations of this interface can serialize a given object to an XML stream. Interface unmarshaller defines a contract for object XML mapping unmarshallers. Implementation of this interface can deserialize a given XML stream to an object graph. This is in the these are in the package org.springframework.oxm. Here we are considering using marshaller and unmarshaller. You can use Spring's OXM for a wide variety of situations. In the following example, we use it to marshal the settings of Spring managed application as an XML file. In this example, we use simple Java bean to represent the settings. The application class uses this bean to store settings. Besides the main method, the class has two methods: saves settings, saves the settings to a bean file called settings.xml, and load settings. Load these settings again. The following main method construct a Spring application context and call these two methods. The application requires both the marshaller and unmarshaller property to be set. We can do so by using following application context XML, application context.xml. This application context uses Xstream, but we could have used any of the other marshaller instances. Note that by default Xstream does not require any further configuration, so the bean definitions is rather simple. Also note that the extreme marshaller implements both marshaller and unmarshaller. So we can refer to the extreme marshaller being in both marshaller and unmarshaller property of the application. The sample application produces the following settings.xml file here. As an example 4, we are considering XML configuration namespace. You can configure marshallers more concisely by using tags from the OXM namespace. To make these tags available, you must first reference the appropriate schema in the preamble of the XML configuration file. The following example shows how to do it. Here you can see reference the OXM schema. Here you can see specify the OXM schema location. The schema makes the following elements available: JAX B2 -marshaller, gibx-marshaller. As an example, though, the configuration of JAX-B2 marshaller might resemble the following here. As an example 5, we are focusing JAXB. Schema validation is performed by specifying one or more schema resources to the bean. As the following example shows, here the class JAX-B2 marshaller, implementation of the generic marshaller interface for JAXB 2.2. This is in the package org.springframework.oxm.jaxb. The JAXB binding compiler translates W3C XML schema into one or more Java classes. JAXB.properties file and possibly some resource files and JAXB also offers a way to generate a schema from annotated Java classes. Spring supports the JAXB 2.0 API as XML marshalling strategies. Following the marshaller and unmarshaller interfaces described in marshaller and unmarshaller, corresponding integration classes reside in the org.springframework.oxm.jaxb package. The JAXB2 marshaller class implement both Spring's marshaller and unmarshaller interfaces. It requires a context path to operate. You can set the context path by setting the context path property. The context path is a list of colon separated Java package names that contains schema derived classes. It also offers a class to be bound property, which allows you to set an array of classes to be supported by the marshaller. Schema validation is performed by specifying one or more schema resources to the bean, as the following example shows. The XML configuration namespace, the JAXB-marshaller element configures org.springframework.oxm.jaxb.jaxb2 marshaller, as this example shows here. Alternatively, you can provide a list of classes to be bound classes to bind to the marshaller by using class to be bound here, a child element. Here the ID attribute, this is the ID of the marshaller, and this is not a required attribute. and context path attribute, the JAXB context path, and this is not a required attribute. As an example 6, we are considering GIBX. In the following example, we bind the flight class class GIBX marshaller, implementation of the marshaller and unmarshaller interfaces for GIBX. It is deprecated as of Spring Framework 5.1.5 due to the lack of activity on the GIBX project. This is in the package org.springframework.oxm.gibx. GIBX, the GIBX framework offers a solution similar to that which Hibernate provides for ORM. A binding definition defines rules for how your Java objects are converted to and from XML. After preparing for the binding and compiling classes, the JIBX binding compiler enhances the class files and adds code to handle converting instances of the class from or to XML. The Spring integration classes reside in the org.springframework.oxm.gibx package. This is about using JIBX marshaller. The JIBX marshaller class implements both marshaller and unmarshaller interface. To operate, it requires the name of the class to marshal in, which you can set using target property. Using target class property. Optionally, you can set the binding name by setting the binding name property. In the following example, we bind the flight class. JIBX marshaller is configured for a single class. If you want to marshal multiple classes, you can have to configure multiple JIBX marshaller instances with different target classes property values. With XML configuration namespace, the JIBX-marshaller tag configures org.spring.framework.oxm.gibx.marshaller as the following example shows. Here the attribute ID, it's the ID of the marshaller. This is not a required attribute. Target class, the target class for this marshaller. This is a required attribute, and binding is not there. Binding name, the binding name used by this marshaller, and this is not that is not a required attribute. As an example 7, we are considering extreme. To further customize the XML here, you can set alias map, which consists string aliases map to classes, as for the following example shows. The class extreme marshaller, implementation of a marshaller interface for extreme. This is in the package org.springframework.oxm.extreme. Extreme is a simple library to serialize objects to XML and back again. It does not require any mapping and generates a clean XML. Spring integration classes reside in the springframework.oxm.extreme package. The extreme marshaller does not require any configuration and can be configured in an application context directly. To further customize the XML, you can set an alias map, which consists of string aliases mapped to classes, as this following example shows. By default, Extreme lets arbitrary classes be unmarshaled, which can lead to unsafe Java serialization effects. As such, we do not recommend using Extreme marshaller to unmarshal XML from external sources, that is the web, as this can result in security vulnerabilities. If you choose to use Extreme marshaller to unmarshal XML from an external source, set the supported class property on the Extreme marshaller. Doing so ensures that only the registered classes are eligible for unmarshalling. Additionally, you can register custom converters to make sure that only your supported classes can be unmarshaled. You might want to add a catch-all converter as the last converter converting the list, in addition to the converters that explicitly support the domain classes that should be supported. As a result, the default Extreme converters with lower priorities and possible security vulnerabilities do not get invoked. Note that the Extreme is an XML serialization library, not a data binding library. Therefore, it has limited namespace support. As a result, it is rather unsuitable for usage within web services. As an example 8, we can consider package org.springframework.oxm.config. Provides a namespace handler for the Spring Object XML namespace. Here you can see annotation based configuration file for JAX-B2 marshaller and pretty print. The JAX-B2 marshaller instance on Spring OXM is used to construct marshaller and unmarshaller instances. In JAX-B2 marshaller, we may configure settings for nice XML printing, encoding, and so on. To create a beautiful print, follow the instructions here. As an exception example, we can consider XML class XML mapping exception, root of the hierarchy of object XML mapping exceptions. As an error example, we can consider this one, failed to transform message and etc., and then caused by org.springframework.xm.unmarshalling failure exception, caster unmarshalling exception, nested exception is org.exolab.caster.xml.marshal exception. The class for the root element trait could not be found. File not available, line 1, column 41, and etc. This error occurred in the environment with Spring and Caster. Now we are focusing on JMS. The Spring JMS module Java messaging service contains features for producing and consuming messages. Since Spring Framework 4.1, it provides integration with the Spring messaging module. Here you can see JMS components along with sample providers. JMS is a part of Java Platform Enterprise Edition and is defined by a specification developed under Java Community Process as JSR 914. To use JMS, one must have a JMS provider that can manage the sessions and queues. There are lots of JMS implementations, both commercial and open source. Some of well-known commercial JMS providers are WebSphere MQ from IBM, Swift MQ, Sonic MQ from Progress Software. Some of the well-known open source JMS providers are OpenJMS from OpenJMS Group, Apache ActiveMQ, Joram from OW2 Consortium. This figure shows typical JMS components along with various providers in market. JMS providers shown in this figure are just for examples. Here you can see clients are connected. Clients interacts with Java Message Service JMS API. Messages are passed from and to client to Java Message Service JMS API and Java Message Service JMS API to client. Java Message Service JMS API is interacts with Java Message Service JMS API interacts with WebSphere MQ, Swift MQ, Sonic MQ, OpenJMS, ActiveMQ, Joram in this diagram, and these are MOM service providers there are, and the messaging service servers include here WebSphere MQ, Swift MQ, Sonic MQ, MOM service providers, Open JMS, ActiveMQ, Joram, and Java Messaging Service JMS API. Here you can see a JMS architecture. Having understood the various components in JMS, I think it's ideal time to look into architecture of JMS. A typical JMS application consists of following components. JMS provider, messaging system which implements the JMS specification. JMS client, producer and consumer. JMS Java applications which sends and receive messages. Message, objects used to communicate information between the Java client. Administrative objects, pre-configured objects maintained by a container which are kept to be used by the Java clients. This figure shows the JMS components and overall architecture on which JMS specification is based. Here you can see producer interacts with JMS provider. Send message is passed from producer to JMS provider, and JMS provider interact with consumer and receive messages from JMS provider to consumer, and JMS provider is connected to MOM. Here you can see Spring JMS architecture. The Spring framework provides a built-in support for JMS and provides a level of abstraction away from the developers which greatly simplifies the development of messaging-based applications. Spring supports building application based both synchronous and asynchronous messages. It supports synchronous message sending and receiving by providing Spring's conventional template platter for JMS called JMS template. For supporting asynchronous message sending and receiving, any POJO can be turned into a message listener. These POJO based message listeners are called message driven POJO, MDP. These are very much similar to EJB's message driven beans, MDBs, but doesn't need to have any knowledge of messaging API to make it a message listener. Spring JMS architecture here. Spring by itself, it's not a JMS provider, and for it to work with messaging, it needs an external JMS provider like Apache ActiveMQ, JBoss messaging, etc. The two important components in Spring framework to handle messaging requirements are JMS template and the message listener container. The former one, namely the JMS template, being used by synchronous messaging activities, and latter one, namely message listener container, being used for asynchronous message activities respectively. These important components in Spring abstract most of the nitty-gritties involved with the messaging away from developer and make it easy to handle a message-oriented application developed in simple easy and maintainable fashion. The Spring JMS architecture can be depicted as shown in this figure. It shows only the main components of entire architecture to make it simpler to understand. Here, JMS provider contains connection factory and destination. JMS provider interacts with Spring framework. Spring framework contains JMS template and message listener container. Spring framework interacts with client application. Here you can see JMS, the delivery model. Here you can see a point-to-point PTP model. What is JMS? JMS is a standard API for MOM, message-oriented middleware in Java. JMS architecture exchanges messages from client to client through JMS provider. Since JMS supports asynchronous messaging, a close coupling can be formed between the clients. Further, since the message can be stored in a queue by adopting a point-to-point model, messages can be received accordance with the client performance. On the other hand, since the time lag is likely to occur in the messaging between clients, it is not suitable for the processes which require real-time response. Asynchronous and synchronous messaging can be performed by using JMS. Note use of JMS 1.1 is assumed in this description here. While using the delivery method and methods to send and receive messages, this must be selected according to the requirement. The delivery model consists of two models: point-to-point PTP and publisher-subscriber PubSub. A major difference between two models is in whether the sender and recipient ratio is 1-to-1 or 1-to-many, and should be selected based on the use. Now we are focusing on a P2P model, point-to-point P2P model. P2P model consists of two clients, wherein one of the client's producer and sends a message, and the other client consumer along receives that message. Destination of the message in P2P model is called queue. Producer sends the message to the queue and the consumer fetches the message from the queue, and process is carried out. Message is fetched from the consumer or when the message reaches expiry period. When the message reaches expiry period, the message is deleted from the queue. Here you can see the client, the sender, and sender consists of producer here. Producer is connected to queue, and producer send messages to queue, and you can see here message server. Queue is inside the message server. and queue is connected to consumer. Consumer receives messages from the queue, and here consumer is inside the client, the receiver. Publisher subscriber pub/sub model. Pub/sub model consists of two clients, wherein one of the client's publisher publishes the message and delivers that message to the multiple other clients, subscribers. Destination of the message in pub/sub model is called the topic. Subscriber raises subscription request for the topic, and the publisher issues a message in the topic. The message is delivered to all subscribers who have raised a request for subscription. This explains how to implement PTP model how to implement a pub/sub model here in general, and here you can see the client, the sender, publisher is inside the sender here, and publisher publishes topic, and topic is inside the message server. And here client, the receiver, and subscriber is inside the client here, receiver. Subscriber subscribes to topic, and topics delivers to the subscribers, and topics interacts with subscribers. Here you can see the flow of the process to send messages synchronously. Following are provided as the libraries for sending and receiving messages in Spring framework. Spring JMS, it offers component for messaging which use JMS. By using the components included in this library, low-level JMS API calling becomes unnecessary, and the implementation becomes specified. Spring-messages can be used. Spring-messaging, it offers a component to abstract the infrastructure function which is required for creating application of messaging base. It consists of a set of annotations to associate with the messaging and the method for processing the same. By using components included in the library, implementation and style of messaging can be matched. Although implementation can be done only with Spring-JMS, implementation method can be combined by using Spring-messaging. This guidance recommends the use of Spring-messaging as well. Here, prior to explaining basic implementation method, it is explained how the messages are sent and received by the components for JMS linking offered by Spring Framework. At first, the components registered in the description are introduced. Spring Framework sends and receives messages through JMS API. using interfaces and classes here, shown here. JavaX .jms.connection factory, an interface for creating a connection with JMS provider. It offers a function to create a connection to JMS provider from the application. Destination, javax.jms.destination, the interface for indicating the address, queue or topic. javax.jms.message producer, an interface for sending messages. JavaX javax.jms.destination, interface for receiving messages. Sorry, the javax.jms.message consumer, the interface for receiving messages. javax.jms.message, an interface which shows the message that retains the header and body. Messages are sent and received by the implementation class of the interface. org.spring framework.messaging.message, an interface which abstracts the message handled by various messaging systems. It can also be used in JMS. As mentioned earlier, basically org.springframework.messaging.message offered by Spring Messaging is used to comply with implementation methods of messaging. However, javax.jms.message is used when it is preferable to use org.springframework.jms.core.jms template. org.springframework.jms.core.jms messaging template and org.springframework.jms.core.jms template, a class which creates templates for generation and releases resources for using JMS API. The implementation can be simplified by using a message transmission and message synchronous reception function. Basically, JMS messaging template which can handle org.springframework.messaging.message is used. Since JMS messaging template wraps JMS template, configuration can be done by using JMS template property. However, sometimes it is preferable to use JMS template as it is. Specific use cases are, there can be specific use cases. org.springframework.jms.listener default message listener, default message listener container received a message from queue and initiate message listener which process that the received messages. At org.springframework.jms.annotation.jms listener, a mark annotation which indicate that is a method to be handled as message listener of JMS. At JMS list annotation is assigned for a method which performs a process while receiving messages. org.springframework.jms.connection.jms transaction manager, an implementation class to manage transaction by calling API of JMS javax.jms.connection, javax.jms.session. Here, when messages are sent synchronously, the flow of the process to send messages synchronously is explained using this figure here. Here, step one, execute the process in service by passing destination name for sending and payload of messages to be sent for the JMS message template. JMS message template delegate the process to JMS template. Here the step 2, JMS template fetches javax.jms.connection from the connection factory fetched through JNDI. Here 3, JMS template passes destination and messages to message producer. Message producer is generated from javax.jms.session. Session is generated from connection fetch in 2. Further destination is fetched through JNDI based on destination name for sending passed in step 1 here. And here 4, message producer sends messages to destination for sending. Here you can see here application the sender. Service is connected to JMS messaging template. Spring JMS contains here JMS messaging template, and inside it JMS template, and here JMS template is connected to string in this step 2 string factory. Connection factory. And in this step 3 here JMS template is connected to message producer. Connection factory implements connection factory in JMS provider client, and message producer implements message producer connection factory implements connection factory in JMS provider client implements connection factory in JMS API, and message producer in JMS provider client implement message producer in JMS API. And here message producer is connected to queue and topics, and connection factory and message producer in JMS API, connection factory and message producer in here in JMS provider client, and queue and topics are in destination here, and this is in message server here. And service is here, service calls JMS messaging template, and JMS template calls connection factory, and JMS template call message producer. Here connection factory implements connection factory in JMS API here, and message producer implement message producer in JMS API, and message producer calls queue, and message producer calls topic. and service is implemented by developers. JMS message template and JMS template is provided by are provided by Spring. Connection factory and message producer here are provided by JMS API. Connection factory and message producer in JMS provider client, and queue and topic in destination are provided by JMS provider. Here the flow of the process to receive messages asynchronously is explained using this figure. Here is one fetch connection from the connection factory, fetch through JNDI. To default message listener container passes destination to message consumer. Message consumer is generated from session. Session is generated from connection fetched in step 1 here. For the destination is fetched through JNDI based on destination name receiving specified in at JMS listener annotation. Three message consumer receives messages from destination. For a method listener method configured by JMS listener at JMS listener annotation in message listener, is called using received message as an argument. Listener method is managed by default message listener container. Here the org.springframework.jms.listener.default message listener container. The default message listener container received messages from queue and initiate message listener which process and received messages. The annotation at org.springframework.jms.annotation.jms listener, a mark annotation which indicates that it is a method to be handled as message listener of JMS. At JMS listener annotation is assigned for a method which perform a process while receiving messages. Here the default message listener container is connected to calls connection factory, and then default message listener container calls message consumer, queue calls message consumer, topic calls message consumer, then default message listener container calls message listener, and default message listener container is inside Spring JMS, and connection factory and message consumer are inside JMS API, and here the connection factory and message consumer are inside JMS provider client, and queue and topics are inside destination, and destination is inside message server. Connection factory implements the connection factory in JMS API, and message consumer implement the message consumer in JMS API here. And message listener is implemented by developers. Default message listener container is provided by Spring. Connection factory and message consumer in JMS API are provided by the JMS API. Connection factory and message consumer in JMS provider client, and queue and topics in destination are provided by JMS provider. Here you can see the flow of the process to receive message synchronously is explained using this this figure here. Here one pass destination name for receiving in service for JMS messaging template. JMS messaging template delegates the process to JMS template. JMS template fetches connection from connection factory, fetch through JNDI. JMS template passes destination and messages in message consumer. Message consumer is generated from session. Session is generated from connection fetch in step 2. Further, destination is fetched through JNDI based on destination name for receiving passed in step 1. It's for message consumer receive the message from destination. Message is returned to the service through the JMS template or JMS messaging template. Here service calls JMS messaging template. JMS messaging template calls connection factory. JMS template call connection factory. JMS template call message consumer. Queue called message consumer and topic called consumer, and connection factory is connection factory implements connection factory in JMS API. Message consumer implement message consumer in JMS API. Service is implemented by developers. JMS messaging template and JMS template is are provided by Spring. Connection factory and message consumer in JMS API are provided by JMS API. Connection factory and message consumer in JMS provider client, and queue and topic in destination are provided by JMS provider. Destination is in messaging server here. Here the top configuration shows the integration, shows the interprocess integration using JMS. The bottom configuration shows inter-process configuration using Spring integration. Which type of configuration is appropriate depends on the architecture of the application. Here with we are considering Spring integration and Java messaging service. For many developers, first thing that comes to mind when they hear messaging is the Java message service, JMS. That's understandable considering it's the predominant Java-based API for messaging and sits among the standards of the Java Enterprise Edition JEE. The JMS specification was designed to provide general abstraction over message-oriented middleware (MOM). Most of the well-known vendor products for messaging can be accessed and used through JMS API. Number of open source JMS implementations are also available. One of which is ActiveMQ, a pure Java implementation of the JMS API. In a simple application with no external integration requirements, producer and consumer components may be decoupled by message channels so that they communicate only with messages rather than a direct invocation of methods with arguments. Messaging is really a paradigm. The message underlying principles apply whether messaging occurs between components running within the same process or between components running under different processes on disparate systems. Nevertheless, by supporting JMS, Spring integration provides a bridge between its simple, lightweight intra-process messaging and inter-process messaging that JMS enabled across many MOM providers. The relationship between Spring integration and JMS. The Spring integration provides a consistent model for intra-process and inter-process messaging. The primary role of channel adapters and messaging gateways is to connect a local channel to some external system without impacting the producer or consumer component code. Another benefit the adapter provides is the separation of the consumer messaging concerns from the underlying transport and protocols. They enable true document style messaging, whether the particular adapter implementation is sending request over HTTP, interacting with a file system, or mapping to another messaging API. The JMS-based channel adapters and messaging gateways fall into the last category and therefore excellent choices when external system integration is required. Given that the same general messaging paradigm is followed by the Spring integration and JMS, we conceptualize the intra-process and inter-process component as belong into two layers, but with the consistent model. Here the JMS provider is inside JVM1 and JMS provider is connected to JMS queue, and JMS queue is connected to JMS consumer. JMS consumer is in JVM2. Here the Spring integration producer, message channel and Spring integration consumer is in JVM, and Spring integration producer is connected to message channel, and message channel is connected to Spring integration consumer. Here you can see the design of the destination backed channel of Spring integration. It benefits from the guarantees supported by JMS implementation, but it hides the JMS API behind the channel abstraction. Even though we tend to focus on the external system integration when discussing the roles of JMS, there are also benefits of using JMS internally. Within an application, JMS may be useful between producer and consumer running in the same process, because JMS provider can support the persistence, transactions and load balancing and failover. For this reason, Spring integration provides a message channel implementation that delegates to JMS behind the scenes. That channel looks like any other channel as far as the message producing and message consuming components are concerned. so it can be used as an alternative at any point within a message flow, as shown in this figure. Even for messaging within a single process, the use of JMS backed channel provides several benefits. Consider a message channel backed by a simple in-memory queue, as occurs when using the queue subelement within a channel without referring any message store. By default, such a channel doesn't persist messages to a transactional resource. Instead, the messages are only stored in a volatile queue such that they can be lost in case of the system failure. They will even be lost if the process is shut down intentionally before these messages are drained from the queue by a consumer. The certain cases when dealing with the real-time event data that doesn't require persistence, the loss of those event messages upon process termination might not be a problem. It may be well worth the trade-off for asynchronous delivery that allows producer and consumer to operate within their own threads on their own schedules with these message channels backed by a JMS destination. Though it can have though you can have best of both worlds if persistence and transactions are important, but asynchronous delivery is also desired a feature, then these channels offer a good choice even if they are only being used by producers and consumers in the same process space. Here the Spring integration producer, JMS destination backup message channel, and Spring integration consumer are in JVM. Spring integration producer is connected to JMS destination backed message channel. JMS destination backed message channel interacts with JMS queue, which is in JMS provider. JMS destination backed message channel is connected to Spring integration consumer. Here you can see a pair of gateways, one outbound and the other inbound. Each is hosted by a separate Spring integration application. Those two applications share the access to a common JMS broker and pair of destinations. The two gateways can work well together when you have a Spring integration applications on both sides. This figure captures this the situation of reusing one of the previous diagrams. About regarding JMS. In the scenario depicted in this figure, it is obviously be necessary to map between Spring integration messages used in each application and the JMS messages that are being passed between the applications. We saw several examples of how the adapters use Spring JMS message converter strategy to convert to and from JMS messages. So far, the examples have mapped between the JMS message body and the Spring integration message payload. Likewise, the JMS properties have mapped to and from the Spring integration message headers. These are so far the most common message patterns for messaging message mapping with JMS, and they make minimal assumption that the system on the other hand of the message exchange. In a particular deployment environment, though it might be well known that Spring integration based application exist on both sides of the JMS destination, one Spring integration application would act as a producer, and the other act as a consumer. The interaction may be unidirectional using the channel adapters we saw, using the channel adapters, or the interaction might involve request reply exchanges wherein one of the applications contains an outbound gateways and the other contains an inbound gateway. Keep in mind that the gateway acts as a both producer and a consumer. If that's the nature of the deployment model, it may or may not be desirable to pass the entire Spring integration message instance as JMS message body. The default mapping behavior would obviously work in such an environment, but if you want to tunnel through JMS instead for some reason, then you can override the default configuration. Here you can see inbound gateway, the application is here, and here you can see the here you can see the outbound gateway, the application is here, and here you can see inbound gateway, the application B is here, and you can see the request destination and reply destination. As an example, we are considering this Maven segment. Here you can see artifact ID Spring-JMS support package, including helper classes to send, receive JMS messages. As an example 2, we can consider package org.springframework.jms. This package contains integration classes for JMS, allowing for Spring style JMS access. As an example 3, we are considering create a message receiver. You can define a message receiver. Here I am moving into Spring Boot example actually. Spring provides means to publish messages to any POJO plain old Java object. This example describes how to send a message over JMS broker. To start things off, create a simple POJO that embodies the details of an email message. Note that we are not sending an email message. We send the details from one place to another about what to send in the message. This POJO is quite simple, containing two fields, to and body, along with the presumed set of getters and setters. Here you can define the message receiver. Here the receiver, also known as message driven Pojo, as the code shows, there is no need to implement any particular interface or for the method to have any particular name. Besides the method may have a flexible signature. Note in particular that this class has no import of the JMS API. The JMS listener annotation defines the name of the destination that this method should listen to, and the reference to the JMS listener container factory to use to create the underlying message listener container. Strictly speaking, that the last attribute is not necessary unless you need to customize the way the container is built, as Spring Boot registers a default factory if necessary. So now we are considering send and receive JMS messages with Spring. Next, wire up the sender and receiver. Here at the Spring Boot application is a convenience annotation that adds all the following. At configuration tag tags the class as a source of the bean definitions for the application context. At enable auto configuration tells Spring Boot to start adding beans based on class path settings, other beans and various property settings. For example, if Spring WebMAC is on the class path, this annotation flags the application as a web application and activate key behaviors such as setting up a dispatch servlet. At component scan tells Spring to look for other component configurations and services in the hello package, letting it find the controllers. The main method uses Spring Boot's Spring application.run method to launch the application. Did you notice that there is not a single line of XML? There is no web.xml in Spring Boot. We are here considering Spring Boot here with this application. There is no and this web application 100% pure Java, and you did not have to deal with the configuring any fumbling or infrastructure with Spring Boot especially. At enable JMS triggers the discovery of the methods annotated with JMS listener, creating the message listener container under the covers. To clarify, we have also defined my factory bean that is referenced in the JMS listener annotation of the receiver, because we use default JMS listener container factory configurer infrastructure provided by Spring Boot, and that JMS message listener container is identical to the one that Boot creates by default. The default message converter can convert only the basic types such as string, map, and serializable, and our email is not serializable on purpose. We won't use junction and serialized content to JSON in text format, that is as text message. Spring Boot detects the presence of message converter and associate it to both default JMS template and any JMS message container factory created by default JMS listener container configurer factory configurer. JMS templates makes it simple to send messages to a JMS destination. In the main runner method, after starting things up, you can use JMS template to send an email pocho. Because our custom message converter has been automatically associated to it, the JSON document is generated in the text message only. Two beans that you do not see defined JMS template and connection factory. These are created automatically by Spring Boot. In this case, the ActiveMQ broker runs embedded. By default, Spring Boot creates JMS template configured to transmit queues by having pub subdomain set to false. The JMS message listener container is also configured the same way. To override, set spring.jms.is pub subdomain equal true through Boot's property settings, either inside application.properties. So by setting an environment variable, then make sure the receiving container has the same thing. Spring's JMS template can receive messages directly through its receive method, but that work only synchronously, meaning that it blocks. That's why we recommend that you use the listener container, such as default message listener container with the case-based connection factory, so you can consume messages asynchronously and with maximum connection efficiency. This provides the Spring Boot's default to this factory, including message converter. You could still override some of the Boot's default if necessary. Here, serialize message content to JSON using text message. Here, launch application. This is send a message with Podo to template reuse the message converter. Especially consider this example is with Spring Boot. So I want to show a sample application to send a very simple application to send a message and send and receive JMS message. As an example, we are considering class JMS template, helper class that simplifies synchronize JMS access code. This is in the package org.springframework.jms.core. The JMS template class is the central class in the JMS core package. It simplifies the use of JMS since it handles the creation and release of the resources when sending or synchronously receiving messages. Code that uses JMS template needs only to implement callback interfaces that give them clearly defined high-level contract. The message creator callback interface creates a message when given a session provided by the calling code in JMS template. To allow For more complex usage of JMS API, session callbacks provide JMS session, and producer callback exposes a session and message producer pair. The JMS API exposes two types of send methods. One that takes delivery mode priority and time to live as a quality of service QoS parameter, and one that takes no QoS parameter that uses default values. Since JMS template has many send methods, setting QoS parameter have been exposed as being properties to avoid duplication in the number of send methods. Similarly, the timeout value for synchronized receive calls is set by using set receive timeout property. Some JMS providers allow the setting of default QoS values administratively through the configuration of the connection factory. This has effect that a call to a message producer instances send method, send destination message uses different QoS default values than those specified in the JMS specification. In order to provide consistent management of QoS values, the JMS template must therefore be specially enabled to use its own QoS values by setting the Boolean property is explicit QoS enabled to true. For convenience, JMS template also exposes the basic request reply operation that allows us for sending a message and waiting for a reply on the temporary queue that is created as part of the operation. Instances of JMS template class are thread safe once configured. This is important because it means that you can configure a single instance of a JMS and then safely inject this shared reference into multiple collaborators. To be clear, JMS template is stateful in that it maintains reference to a connection factory, but this state is not conversational state. As of Spring Framework 4.1, JMS messaging template is built on top of JMS template and provide an integration with message abstraction, that is org.springframework.messaging.message. This lets you create the message to send a generic manner. Now we are considering sending message. Following example uses message creator. Message creator callback to create a text message from the supplied session object. Public void send destination message creator method send a message to the specified destination. The message creator callback creates the message given a session. This is in the class JMS template, and that is in the package org.springframework.jms.co. JMS template contains many convenience methods to send a message. Send methods specify the destination by using java x.jms.destination. Object and other specify destination by using a string in a JNDI lookup. The send method that takes no destination argument uses the default destination. This example uses message creator callback to create a text message from supplied session object. In this example, the JMS template is constructed by passing a reference to a connection factory. As an alternative, a zero argument constructor and the connection factory is provided can be used for constructing an instance in Java Bean style using Bean Factory or plain Java code. Alternatively, consider driving from Spring's JMS Gateway Support Convenience base class, which provides the pre-built bean properties for JMS configuration. The send string destination name message creator method lets you to send a message using string name of the destination. If these names are registered with JNDI, you should set the destination resolver property of the template to an instance of JNDI destination resolver. If you created the JMS template and specify the default destination, the send message creator send the message to the destination. And here notice this is string message creator method. Here as an we noted different version here for the importance of the description. Now we are considering message-driven POJOs in asynchronous reception in receiving a message. The following example shows a simple implementation of MDB. The class default message listener container. The message listener container variant that uses plain JMS client APIs, especially a loop of message consumer dot receive calls that also allow for transactional reception of messages, registering them with XA transactions, designed to work in a native JMS environment as well as in a Java EE environment with only minimal differences in configuration. This in the package org.springframework.jms.listener. Spring also support annotated String also support annotated listener endpoints through the use of the @JMS listener annotation, and provides an open infrastructure to register endpoints programmatically. This is by far the most convenient way to set up an asynchronous receiver. In a fashion similar to JMS, similar to a message-driven bean, MDB, in EGB world, the message-driven POJO, MDP, act as a receiver for JMS messages. The one restriction on MDP is that it must implement the javax.jms message listener interface. Note that if your POJO receives messages on multiple threads, it is important to ensure that your implementation is thread safe. This example shows a simple implementation of an MDP. Once you have implemented your message listener, it's time to create a message listener container. Here, this example shows how to define and configure one of the message listener containers that ships with Spring, in this case, default message listener container. See Spring Java doc for the various message listener containers, all of which implement message listener container for the full description of the features supported by each implementation. This is the message-driven Pocho MDP, and this is the message listener container. As an example 7, we can consider support for JCA message endpoints. It is typically possible to provide Spring generic JMS activation spec config as the following example shows. Class JMS message endpoint manager, extension of the generic JCA 1.5 generic message endpoint manager, adding JMS specific support for activation spec configuration. This is in the package org.springframework.jms.listener.endpoint. Beginning with the version 2.5, Spring also provides support for JCA based message listener. Container. The JMS message endpoint manager tries to automatically determine the activation spec. Class name from the providers, resource adapter, class name. Therefore, it is typically possible to provide Spring's generic JMS activation spec config as the following example shows here. As an example 8, we are considering enable listener endpoint annotations in annotation driven listener endpoints. To enable support for at JMS listener annotations, you can add at enable JMS to one of your at configuration classes, as the following example shows. Annotation type enable JMS. Enable JMS listener annotated endpoints that are created under the cover by a JMS listener container factory to be used on configuration classes as follows here. This is in the package org.springframework.jms.annotation. To enable support for JMS listener, support for at JMS listener annotations, you can add at enable JMS to one of your configuration class, one of your at configuration classes, as the following example shows. By default, the infrastructure look for a bean named JMS listener container factory as the source for this factory to use to create message listener containers. In this case, and ignoring the JMS infrastructure setup, you can invoke process order method with the core poll size of 3 threads and maximum poll size of 10 threads. You can customize the listener container factory to use for each annotation, or you can configure an explicit default by implementing JMS listener configure interface. The default is required only if at least one endpoint is registered without a specific container factory. See the Java doc of classes that implement JMS listener configurer for details and examples. If you prefer XML configuration, you can use JMS annotation driven element as the following example shows. Programmatic endpoint registration. The infrastructure lets you to programmatically configure endpoints in addition to the ones that are detected by the JMS listener annotation. The following example shows how to do so. Here the class simple JMS listener endpoint. The JMS listener endpoint simply providing the message listener to invoke to process an incoming messages for this endpoint. This is in the package org.springframework.jms.config. In this example, we used simple JMS listener endpoint, which provide the actual message listener to invoke. However, you could also build your own endpoint variant to describe custom invocation mechanism. Note that you could skip the use of @JMS listener altogether and programmatically register only your endpoints through JMS listener configurer. This is processing here. As an example 10, we are considering annotated endpoint method signature. In this example, we rewrite it to inject the order with custom header. Annotation type JMS listener. Annotation that marks a method to be the target of the JMS message listener on the specified destination. The container factory method identified the JMS listener container factory to use the JMS listener container. If not set, the default container factory is assumed to be available with the bean name of JMS listener container factory, unless an explicit default has been provided through configuration. This is in the package org.springframework.jms.annotation. So far, we have been injecting a simple string in our endpoint, but it can actually have a very flexible method signature. in this example, we rewrite it to inject the order with the custom header. The main elements you can inject in JMS listener. The raw javax.jms.message or any of its subclasses, provided that it matches the incoming message type. The javax.jms.session for optional access to the native JMS API, for example, for sending custom reply. The org.springframework.message.message that represent the incoming JMS message. Note that this message holds both the custom and standard headers as defined by JMS headers. At header annotation here, annotated method argument to extract a specific header value, including standard JMS headers. At headers, annotated argument that must also be assignable to java.util.map for getting the access to all headers. The non-annotated element that is not one of the supported type, message or session, is considered to be the payload. You can make an explicit by annotating the parameter with at payload. You can also turn on validation by adding an extra at valid. The JMS namespace support. To use the JMS namespace elements, you need to reference the JMS schema as the following example shows. Spring provides an XML namespace for simplifying JMS configuration. To use the JMS namespace element, you need to reference the JMS schema here and like this. Here you can see referencing the JMS schema. The namespace consists of 3 top-level elements. Here you can see the following example shows the basic configuration for 2 listeners. The namespace consists of the 3 top-level elements: annotation-driven listener container and JCA listener container. Annotation-driven enables the use of annotation-driven listener endpoints. Listener container and JCA listener container define the shared listener container configuration and can contain listener child elements. This example shows the basic configuration of 2 listeners. This example is equivalent to creating 2 distinct listener container, being definition, and 2 distinct message listener adapter being definition. In addition to the attributes shown in this example, the listener element can contain several optional ones. Here the destination is a required one and attribute. The destination name for this listener resolved through the destination resolver strategy. Ref, this is a required attribute, and the bean name of the handler object. Method attribute, the name of the handler method to invoke. If the ref attribute points to a method listener or Spring session aware listener, you can omit this attribute. As an exception example, we can consider class JMS exception. Base class for exception thrown by the framework whenever it counters a problem related to JMS. This is in the package org.springframework.jms. Um, um, we can, as an error example, we can consider this error occurred in the Spring 3.1 in JBoss 7.1.1. Failed to start the service JBoss deployment.unit jms receiver.var pass jboss org.jboss.msc.service.start exception in the service jboss.deployment.unit jms receiver.var pass failed to process pass deployment jms receive.var. And here you can see the file final standard temp.vfs.temp 22a1672720173201a833b9 jms receiver.var etc. and web-inf spring-jms.xml here. Now we are focusing on transactions. The Spring TX module supports programmatic and declarative transaction management for classes that implement special interfaces and for all your POJOs, plain old Java objects. Here you can see a conceptual view of calling a method on a transactional proxy. Here we are focusing on Spring Framework's declarative transaction implementation. It is not sufficient merely to tell you to annotate your classes with a transaction annotation, add enable transaction management to your configuration, and expect you to understand how it all works. To provide deeper understanding, I explain the inner workings of the Spring's framework's declarative transaction infrastructure in the context of transactional related issues. The most important concepts to grasp with regard to Spring Framework's declarative transaction support are that the support is enabled via AOP proxies, and that transactional advice is driven by metadata, currently XML or annotation based. The combination of AOP with transactional metadata yields an AOP proxy that uses transaction interceptor in conjunction with an appropriate transaction manager implementation to drive transactions around method invocations. Spring Framework's transaction interceptor provides transaction management for imperative and reactive programming models. The interceptor detects the desired flavor of transaction management by inspecting the method return type. Methods returning a reactive type such as publisher or Kotlin flow or a subtype of those qualify for reactive transaction management. All other return types, including void, use the code path for imperative transaction management. Transaction management flavors impact which transaction manager is required. Imperative transactions require a platform transaction manager, while reactive transaction use reactive transaction implementations. Add transactional commonly works with the thread-bound transactions managed by a platform transaction manager, exposing a transaction to all data access operations within the current execution thread. Note, this does not propagate to newly started threads within the method. A reactive transaction managed by a reactive transaction manager uses the reactor context instead of thread local attributes. As a consequence, all participating data access operations need to execute within the same reactor context in the same reactive pipeline. This image shows a conceptual view of calling a method on a transactional proxy. Here, caller invokes proxy, not the target. Here, transaction created on the way in committed or rollback on the way out. Here, the custom interceptors may run before or after transaction advisor, and here business logic invoked. Here, control flows back through interceptor chain to return result to the caller. Here, caller is connected to AOP proxy, and AOP proxy is connected to transaction advisor. Transaction advisor is connected to custom advisor. Custom advisor interact with method target method, and here the custom advisor is connected to transaction advisor, and transaction advisor is connected to AOP proxy. AOP proxy returns to caller. Here you can see the diagram about propagation underscore required. Propagation required enforces a physical transaction either locally for the current scope if no transaction existed, or participating an existing outer transaction defined for a large scope. This is fine default in common call stack arrangement within the same thread. For example, service facade can delegates to several repository methods where all the underlying resources have to participate in the service level transaction. By default, a participation transaction joins the characteristics of the outer scope, silently ignoring the local isolation level, timeout value, or read-only flag, if any. Consider switching validate existing transaction flag to true on your transaction manager if you want isolation level declarations to be rejected when participating in existing transaction with a different isolation level. In non-lenient mode, also reject read-only mismatches, that is an inner read-write transaction that tries to participate in a read-only outer scope. When a propagation settings is propagation required, a logical transaction scope is created for each method upon which the setting is applied. Each such logical transaction scope can determine rollback only status individually. Within an outer transaction scope being logically independent from inner transaction scope. In case of standard propagation required behavior, all these scopes are mapped to the same physical transaction. So a rollback only marker set in the inner transaction scope does not affect the outer transaction's chance to actually commit. However, in the case where an inner transaction scope sets the rollback only marker, the outer transaction has not yet decided on the rollback itself, so the rollback silently triggered by the inner transaction scope is unexpected. A corresponding unexpected rollback exception is thrown at that point. This is expected behavior so that the caller of the transaction can never be misled to assume that a commit was performed when it really was not. If an inner transaction of which the outer is not aware silently marks the transaction as rollback only, the outer caller still calls the commit. outer caller needs to receive an exception, unexpected rollback exception to indicate clearly that rollback was performed instead. Here you can see that here transaction is created, committed, or rollback as needed. Here the method 2 executes in the existing transaction. Here you can see the caller is connected to transactional method 1 and transactional method 1 is connected to transactional method 2. And here you can see the transaction. Here you can see propagation underscore requires underscore new. Propagation requires new, in contrast to propagation required, always uses an independent physical transaction for each affected transaction scope. Never participating in an existing transaction for out scope. In such an arrangement, the underlying resource transactions are different and hence can commit or rollback independently. With an outer transaction not affected by an inner transaction rollback status, with an inner transactions locks release immediately after its completion. Such an independent inner transaction can also declare its own isolation level timeout. Its own isolation level timeout and read-only settings, and not inherit an outer transaction's characteristics. Here you can see transaction created, committed, or rollback as needed, and here method 2 executes in a new transaction and the outer transaction is suspended. Here you can see caller is connected to transactional method 1, transaction method 1 is connected to transaction method 2, and here you can see transaction 1 is here and transaction 2 is here. Here you can see the Spring transaction routing. To route the read-write transaction to the primary node and read and read-only transaction to the replica node, we can define read-write data source that connects to the primary node, and read-only data source that connects to the replica node. The read-write and read-write and read-only transaction routing is done by the Spring abstract routing data source abstraction, which is implemented by transaction routing data source. Here the transaction routing data source is a customized class in subclass of abstract routing data source class. Abstract routing data source is an abstract data source implementation that routes getConnection method calls to one of the various target data sources based on a lookup key. The latter is used usually but not necessarily determined through some thread-bound transaction context. Here you can see web controller is connected to transactional routing data source. At service method call is passed from web controller to transactional routing data source. Transactional routing data source is connected to read-write data source. At transactional is passed from transactional routing data source to read-write data source here, and read-write data source is connected to DB primary here, and read-write is passed from read-write data source to DB primary. Transactional routing data source is connected to read-only data source here, and at transactional read-only equal true is passed from transactional routing data source to read-only data source. Read-only data source is connected to DB replica, and read-only is passed from read-only data source to DB replica. DB primary is connected to replication. DB primary is connected to DB replica, and replication is passed from DB primary to DB replica. As an example, we can consider Maven segment here. Here you can see artifact ID spring-tx spring transaction, support for programmatic and declarative transaction management for classes that implement special interfaces or any POJO. As an example too, we can consider package org.springframework.transaction. Spring's core transaction management APIs independent of any specific transaction management system, an exception hierarchy for Spring's transaction infrastructure, and transaction manager definition and status interfaces. The following example shows what the JTA and JNDI lookup version would look like here. The class JTA transaction manager, platform transaction manager implementation for JTA, delegating to a backend JTA provider. This is typically used to delegate to a Java EE server's transaction coordinator, but may also be configured with the local JTA provider, which is embedded within the application. org.springframework.transaction.jta package consists this JTA transaction manager class. If you use JTA in Java EE container, then you use a container data source obtained through JNDI in conjunction with Spring's JTA transaction manager. This example shows what the JTA and JNDI lookup version would look like. The JTA transaction manager does not need to know about the data source or any other specific resources because it uses the container's global transaction management infrastructure. This definition of the data source being uses JNDI uses the JNDI lookup tag from EE namespace. JEE namespace. If you use JTA, your transaction manager definition should look the same, regardless of what data access technology you use, be it JDBC, Hibernate JPA, or any other supported technology. This is due to the fact that JTA transactions are global transactions, which can enlist any transactional resource. In all Spring transaction setups, application code does not need to change. You can change how transactions are managed merely by changing configuration, even if that change means moving from local to global transactions or vice versa. Here you can see the different example here. The related to platform transaction manager bean definition then has a reference to data source definition. It should resemble the following example. So data source transaction manager here. Other bean definitions are here. Here as an example 4, we are considering example of declarative transaction implementation in declarative transaction management. Here the transaction manager attribute of the tx:advice tag is set to the name of the transaction manager bean that is going to drive the transaction, in this case the tx manager bean. Consider the following interface and its attendant implementation. This example uses foo and bar classes as placeholders so that you can concentrate on transaction usage without focusing on a particular domain model. For the purposes of this example, in fact, that the default foo service class throws unsupported operation exception instances in the body of each implemented method is good. That behavior lets you see the transaction being created and then roll back in response to the unsupported operations exception instance. Following listing shows the foo service interface. The following example, this example shows an implementation of this interface. Assume that the first two methods, foo service interface get foo string and get foo string must run in the context of a transaction with read-only semantics, and that the other methods insert foo and update foo must run in the context of a transaction with read-write semantics. Examine this configuration. It is assumed that you want to make service object the foo service bean transactional. The transaction semantics to apply are encapsulated in the tx::advice definition. The tx::advice definition reads as all methods starting from get are to run in context of a read-only transaction, and all other methods are to run with the default transaction semantics. The transaction manager attributes of tx::advice tag is set to the name of the transaction manager. Bean name of the transaction manager bean that is going to drive the transaction, in this case the tx manager bean. You can omit the transaction manager attributes in the transactional advice if the bean name of the transaction manager that you want to wire in has the name transaction manager. If the transaction manager bean that you want to wire in has any other name, you must use the transaction manager attribute explicitly as in this example. The AOP :config definition ensures that the transactional advice defined by the TX advice bean runs at the appropriate point in the program. First, you define a point cut that matches the execution of any operation defined in the foo service. Foo service interface, foo service operation. Then you associate the point cut with the TX advice by using an advisor. The result indicate that the execution of foo service operation, the advice defined by TX advice is run. The expression defined within the AOP :point cut element is an aspect J point cut expression. The configuration shown here is used to create transactional proxy around an object that is created from foo service. The proxy is configured with the transactional advice, so so that when the appropriate method is invoked on the proxy, transaction is started and suspended and marked as read only, and so on, depending on the transaction configuration associated with that method. Consider the following test drives the configuration shown here. The output from running this program should resemble the following log4j output, and the stack trace from unsupported exception thrown by insert foo, a method of the default foo service. Class has been truncated for clarity. This is the service object that we want to make transactional. the transactional advice, what happens, see the AOP advisor being built here. The transactional semantics, all methods starting with get are read only. Other methods use the default transaction settings, see below here. Ensure that the above transactional advice runs for any execution of an operation defined by the full service interface. And don't forget the data source. Similarly, don't forget the transactional transaction manager. Other bean definitions are here. As an example 5, we can consider the ease of use afforded by the use of a transactional annotation is best illustrated in this example, which is explained in the text that follows. Here, consider the following class definition. Annotation type transactional describe a transaction attribute on an individual method or on a class. This is in the package org.springframework.transaction.annotation. In addition to XML-based declarative approach to transaction configuration, you can use an annotation-based approach, declaring transaction semantics directly in the Java source code. Puts the declaration much closer to the affected code. There is not much danger of undue coupling, because code that is meant to be used transactionally is almost always deployed that way anyway. The ease of use afforded by the use of the transactional annotation is best illustrated with an example which is explained in this here. Consider the following class definition. Used at the class level as here, the annotation indicates a default for all methods of declaring class as well as its subclasses. Alternatively, each method can be annotated individually. Note that a class level annotation does not apply to ancestor classes up the class hierarchy. In such scenario, inherited methods need to be locally redeclared in order to participate in a class level annotation. When a Pojo class such as this one defined as a bean in a Spring context, you can make the bean instance transactional through an enable transaction management annotation in at configuration class. In XML configuration, the tx: annotation driven tag provides similar convenience. This is the line that makes the bean instance transactional. You can omit the transaction manager attribute in the tx: transaction driven tag if the bean name of the transaction manager manager that you want to write has the same name, transaction manager. If the transaction manager bean that you want to dependency inject has any other name, you have to use the transaction dash manager attribute as in this example. The service class that we want to make transactional. From the this is from the file context.xml. This is the service object that we want to make transactional. Enable the configuration of transactional behavior based on the annotation. The transaction manager is still required. This dependency is defined somewhere else. Other bean definitions here. Now, as an example, C6, we are considering programmatic transaction management. You can then pass an instance of your custom transaction callback to the execute method exposed on the transaction template. This example shows how to do it. The class transaction template class that simplifies programmatic transaction demarcation and transaction exception handling. This is in the package org.springframework.transaction.support. The transaction templates adopts the same approach as other Spring templates such as JDBC template. It uses a callback approach to free application code from having to do the boilerplate acquisition and release transactional resources, and result in code that is intention driven in that your code focuses solely on what you want to do. As this example shows, using the transaction template absolutely couples you to Spring transaction infrastructure and APIs. Whether or not programmatic transaction management is suitable for your development needs is a decision that you have to make yourself. Application code that must run in a transactional context and explicitly use transaction template resemble in this example. You as an application developer can write a transaction callback implementation, typically expressed as an anonymous inner class. That contains the code that you need to run in the context of transaction. You can then pass an instance of your custom transaction callback to the execute method exposed on the transaction template. This example shows how to do so. Single transaction template shared among all methods in this instance. Use the constructor injection to supply the platform transaction manager. The code in this method runs in a transactional context. The following example shows the programmatic customization of the transactional settings for a specific transaction template. The method public final void set isolation level int isolation level. Set the isolation level must be one of the isolation constants in the transaction definition interface. Default is isolation underscore default. You can specify transaction settings such as propagation mode, the isolation the isolation level or the timeout and so forth. By default, transaction templates instances have the default transactional settings. This example shows the programmatic customization of the transactional settings for a specific transaction template. This example defines the transactional template with some custom transactional settings. By using Spring XML configuration. You can then inject shared transaction template into as many services as are required. Finally, the instance of transaction template class are thread safe in that instances do not maintain any conversational state. Transaction template instances do, however, maintain configuration state. So while a number of classes may share a single instance of transaction template, if a class needs to use transaction template with the different settings, for example, a different isolation level, you need to create two distinct transaction template instances. Transaction settings can be set here explicitly if so desired. 30 seconds and so forth. As an example 8, we are considering transaction bound events. The following example set up such an event listener. The annotation type transactional event listener, an event listener that is invoked according to a transaction phase. This is an annotation based equivalent of transactional application listener. This is in the package org.springframework.transaction.event. As of Spring 4.2, the listener of an event can be bound to a pace of a transaction. Typical example is to handle an event that when a transaction has completed successfully. Doing so lets event be used with more flexible when outcome of the current transaction actually matters to the listener. You can register a regular event listener by using event listener annotation. If you need to bind it to a transaction, use at transaction event listener. When you do so, the listener is bound to the commit pace of the transaction by default. This example shows this concept. Assume that the component publishes an order created event and that we want to define a listener that should only handle that event once the transaction in which it has been published has committed successfully. This example sets up such an event listener. The at transactional event listener annotation exposes a phase attribute that lets you customize the phase of the transaction to which the listener should be bound. Valid phases are before commit, after commit, default, after rollback, as well as after completion, which aggregates the transaction completion, be it a commit or a rollback. If no transaction is running, the listener is not invoked at all, since we cannot honor the required semantics. You can, however, override the behavior by setting the fallback execution attribute of the annotation to true. At transactional event listener only works for the thread-bound transaction managed by platform transaction manager. A reactive transaction managed by reactive transaction manager uses reactor context instead of thread local attributes. So from the perspective of an event listener, there is no compatible active transaction that it can participate in. As an example 9, we are considering IBM WebSphere in application service specific integration. The class WebSphere UOW transaction manager. The WebSphere specific platform transaction manager implementation that delegates to a UOW manager instance obtained from WebSphere's JDBC environment. This allows Spring to leverage the full power of the WebSphere transaction coordinator, including transaction suspension, in a manner that is perfectly compliant with officially supported WebSphere API. This is in the package org.springframework.transaction.jta. On WebSphere 6.1.0.9 and above, the recommended Spring JTA transaction manager to use is WebSphere UOW transaction manager. This special adapter uses IBM's UOW manager API, which is available in WebSphere's application server 6.1.0.9 and later. With this adapter, spring-driven transaction suspend and resume as initiated by propagation required new is officially supported by IBM. Now, as an example 10, we are considering using the wrong transaction manager for a specific data source in solution to common problems. You use the global transaction. You must, if you use global transaction, you must use the org.spring framework.transaction.jta transaction manager class or an application service specific subclass of it for all your transactional operations. Class JTA transaction manager, the platform transaction manager implementation for JTA, delegating to a backend JTA provider. This is typically used to delegate to a Java EE server's transaction coordinator, but may also be configured with the local JTA provider, which is embedded within the application. This is in the package org.spring framework.transaction.jta. Use the correct platform transaction manager implementation based on your choice transactional technologies and requirement. Use properly. The Spring framework merely provide straightforward and portable abstraction. If you use global transaction, you must use org.spring framework.transaction.jta transaction manager class or an application service specific subclass of it for all your transaction operations. Otherwise, the transaction infrastructure try to perform local transactions or on resources as container data source instances. Such local transactions do not make sense, and a good application server treats them as errors. As an example 11, we are considering configure transactions. Spring 3.1 introduces the enable transaction management annotation that we can use in at configuration class to enable transactional support. Annotation type enable transaction management enables Spring's annotation driven transaction management capability, similar to the support found in TX:**XML namespace, to be used on configuration classes to configure traditional imperative transaction management or reactive transaction management. This is in the package org.spring framework.transaction.annotation. However, if you are using Spring Boot project and have a Spring data or Spring TX dependencies on the class path, then transaction management will be enabled by default. As an exception example, we can consider transaction exception, class transaction exception, superclass for all transaction exceptions. This is in the package org.spring framework.transaction. Now we are focusing on web. The web layer consists of the Spring Web, Spring Web MVC and Spring WebSocket modules. Here you can see the high-level architecture of classic Spring Web application look like as follows here. If you think about responsibilities of a web application, we notice that web application has the following concerns. It needs to process the user input and return the correct response back to the user. It needs exception handling mechanism that provide reasonable error messages to the user. It needs a transaction management strategy. It needs to handle both authentication and authorization. It needs implementation. It needs to implement the business logic of the application. It needs to communicate with the used data storage and other external resources. We can fulfill these concerns by using only 3 layers. These layers are a web layer. The web layer is the uppermost layer of the web application. It is responsible for processing user input and returning the correct response back to the user. The web layer must also handle the exceptions thrown by the other layers. Because the web layer is the entry point of our application, it must take care of authentication and act as a first line of defense against unauthorized users. The service layer resides below the web layer. It acts as a transaction boundary and contains both application and infrastructure services. The application services provide the public API of the service layer. They also act as a transaction boundary and are responsible for authorization. The infrastructure services contain the plumbing code that communicate with external resources such as file systems, databases, or email services. Often these methods are used by more than one application service. Repository layer is the lowest layer of the web application. It is responsible for communicating with the used data storage. Here you can see a web layer on top, controllers, exception handlers, filters, view templates, and so on. Below that you can see a service layer below the web layer, application services and infrastructure services. Below service layer you can see a repository layer, repository interfaces and their implementations. Here you can see the final architecture of a classic Spring Web application looks as follows. Next thing that we have to do is to design the interface of each layer, and this is the place where we run into terms like data transfer objects and domain model. A data transfer object is an object that is just a simple data container, and these objects are used to carry data between different processes and between the layers of our applications. Domain model consists of three different objects. The domain service is a stateless class that provide operations which are related to the domain concept but aren't a natural part of an entity or a value object. Entity is an object that is defined by its identity, which stays unchanged through its entire life cycle. A value object describes a property or a thing, and these objects don't have their own identity or life cycle. The life cycle of a value object is bound to the life cycle of an entity. Now that we know that these terms mean what these terms mean, we can move on and design the interface of each layer. Let's go through our layers one by one. The web layer should handle only the data transfer objects. Service layer takes data transfer objects and basic types as method parameters. It can handle domain model objects, but it can return only data transfer object back to the web layer. The repository layer takes entities and basic types as method parameters and return entities and basic types. This raises a very important question. Do we really need data transfer objects? why cannot we just return entities and value objects back to the web layer? First thing, the domain model specifies the internal model of our application. If we expose this model to the outside world, the clients would have to know how to use it. In other words, the client of our application would have to take care of things that don't belong to them. If we use DTOs, we can hide this model from the clients of our application and provide an easier and cleaner API. Step 2, if we expose our domain model to the outside world, we cannot change it without breaking the other stuff that depends from it. If we use DTOs, we can change our domain model as long as we don't make any changes to the DTOs. Here you can see the web layer, controller, exception handlers, filters, view, templates, and so on. Below that you can see, below the web layer you can see service layer, application services and infrastructure services. And below that you can see the repository layer, repository interfaces and their implementation. You can see above here public area, web layer, and some of the service layer, and this is private area, some of the service layer and repository layer. And in the public line you can see the DTOs here. In the private area you can see the domain model, domain service, entities, and value objects. Now we are focusing on WebSocket. The WebSocket protocol RFC 6455 provides a standardized way to establish a full duplex two-way communication channel between client and server over a single TCP connection. It is a different TCP protocol from HTTP, but is designed to work over HTTP using ports 80 and 443 and allowing reuse of existing firewall rules. Here you can see a WebSocket is a full duplex communication channel between two applications. In its simplest form, a WebSocket is just a communication channel between two applications. An application on one end of the WebSocket send a message, and the other end handle that message. Because it's full duplex, either end can send message and either end can handle messages. A WebSocket communication can be used between any kind of applications, but the most common use of WebSocket is to facilitate communication between server and a browser-based application. A JavaScript client in the browser opens a connection to the server, and the server sends updates to the browser on that connection. This is generally more efficient and more natural than historically common alternative of polling the server for updates. Here you can see application A interacts with application B, and messages are passed from application A to B, and messages are passed. Message is passed from application B to A. Here you can see this diagram shows the components used when a simple built-in message broker is enabled, with regarding flow of messages, once Stomp endpoint is exposed, the Spring application becomes a Stomp broker for connected clients. This section describes the flow of messages on server side. The Spring messaging module contains foundational support for messaging applications that originated in Spring integration and was later extracted and incorporated into a Spring framework for broader use across many Spring projects and application scenarios. The following list briefly describe a few of the available messaging abstractions. Message, a simple representation for a message including headers and payload. Message handler, contract for handling message. Message channel, contract for sending a message that enables loose coupling between producers and consumers. Subscribable channel, message channel with message handler subscribers. Executor subscribable channel that uses an executor for delivering messages. Both Java configuration, that is at enable WebSocket message broker, and the XML namespace configuration, that is WebSocket message broker, use the preceding components to assemble a message workflow. Preceding components means previously mentioned components. This diagram shows the components used when a simple built-in message broker is enabled. This diagram shows three message channels. Client inbound channel for passing messages received from WebSocket clients. Message outbound channel for sending server messages to WebSocket clients. Broker channel for sending messages to the message broker from within server side application code. Here you can see WebSocket client messages here, and WebSocket client messages are connected to request channel. Request channel is connected to simple annotation method message handler, and here simple broker message handler, and /app is passed from request channel to simple annotation method message handler. /topic is passed from here request channel to simple broker message handler. Simple annotation method message handler is connected to broker channel. Broker channel is connected to simple broker message handler. Topic /topic is passed from broker channel to simple broker message handler. Simple broker message handler is connected to response channel. Response channel is connected to WebSocket client messages. This diagram shows the components used when an external broker such as RabbitMQ is configured for managing subscriptions and broadcasting messages. The main difference between the two diagrams is the use of broker relay for passing messages up to the external Stomp broker over TCP, and for passing messages down from the broker to subscribe clients. When messages are received from the WebSocket connection, they are decoded to stomp frames, turned into the Spring message representation and sent to the client inbound channel for further processing. For example, stomp messages messages whose destination headers start with /app may be routed to message mapping methods in annotated controllers, while /topic and /queue messages may be routed directly to the message broker. The annotated controller that handles the stomp message from client may send the message to the message broker through broker channel, and broker broadcasts the messages to matching subscribers through the client outbound channel. Same controller can also do the same in the response to the HTTP requests. So the client can perform an HTTP post, and then at post mapping method can send the message to the message broker to broadcast subscribes channels. To broadcast subscribe clients. Here you can see WebSocket client messages are connected to request channel. Request channel is connected to simple annotation method message handler, simple annotation method message handler, and stomp broker relay message handler. /app is passing from request channel to simp annotation method message handler, and /topic is passing from request channel to stomp broker relay message handler. Simple annotation method message handler is connected to the broker channel, and broker channel is connected to the stomp broker relay message handler, and topic is /topic is passed from broker channel to stomp broker relay message handler. Stomp broker relay message handler interacts with message broker through stomp TCP, and stomp broker relay message handler is connected to response channel, and response channel is connected to the WebSocket client messages. We can trace the flow through a simple example. Consider the following example which sets up a server. Step 1, the client connects to http http://localhost:8080/portfolio, and once the WebSocket connection is established, stomp frames begin to flow on it. The client sends a subscribe frame with the destination header /topic/greeting. Once received and decoded, the message is sent to the client inbound channel and is then routed to the message broker, which stores the client subscription. Client send frames to /app/greeting. The /app prefix helps to route it to the annotated controllers. After the /app prefix tipped, the remaining /greeting part of the destinations is mapped to the @message mapping method in the greeting controller. Step 4, the value returned from greeting controller is returned to the Spring message with the payload based on the return value and the default destination header of /topic /greeting derived from the input destination with /up replaced by the /topic. The resulting message is then sent back to the broker channel and handled by the message broker. The message broker finds all matching subscribers and sends message frame to each one through the client outbound channel from where messages are encoded as stomp frames and sent to the WebSocket connection. As an example, we can consider this Maven segment. Here you can see the artifact ID Spring WebSocket, Spring WebSocket and SockJS infrastructure, including Stomp messaging support. As an example too, we can consider package org.springframework.web.socket, common abstractions and Spring configuration support for WebSocket applications. As an example 3, we can consider this. A WebSocket interaction begins with an HTTP request that uses the HTTP upgrade header to upgrade, or in this case to switch to the WebSocket protocol. This example shows such an interaction. The WebSocket protocol RFC 6455 provides an standardized way to establish a full duplex two-way communication channel between client and server over a single TCP connection. It is different TCP protocol from HTTP, but is designed to work over HTTP using ports 80 and 443 and allowing reuse of existing firewall rules. A WebSocket interaction begins with HTTP request that uses HTTP upgrade header to upgrade, or in this case to switch to the WebSocket protocol. This example shows such an interaction. Here you can see the upgrade header. Here you can see using the upgrade connection. Instead of usual 200 status code, a server with WebSocket support returns output similar to the following here. Here you can see a protocol switch. After a successful handshake, the TCP socket underlying HTTP upgrade request remains open for both the client and the server to continue and to send and receive messages. Note that if a WebSocket server is running behind a web server, for example nginx, you likely need to configure it to pass WebSocket upgrade request onto the WebSocket server. Likewise, if the application runs in a cloud environment, check the instruction of the cloud provider related to the WebSocket support. As an example 3, we are considering using WebSocket to build an interactive web application. This is basically based on Spring Boot, but we are considering here important code segments only. Now we are going to create a Stomp message service, and we are targeting to create a resource representation class. Begin the process by thinking about service interactions. The service will accept messages that contain a name with name in stomp message whose body is a JSON object. If the name is Fred, the message might resemble the following. To model the message that carries the name, you can create a plain old Java object with the name property and corresponding getName method as the following listing. This is from src/main/java/com/example/message stomp websocket/hello message.java. Upon receiving the message and extracting the name, service will process it by creating a greeting and publishing that greeting on a separate queue to which the client subscribed. The greeting will also be a JSON object, which as the following listing shows here. To model the greeting representation, add another plain old Java object with the content property and corresponding get content method as the following listing shows. Spring will use Jackson JSON library to automatically marshal instances of type greeting into JSON. Next, you will create a controller to receive hello message and send a greeting message. This is create a message handler controller. In a Spring approach to work with stomp messaging, stomp messages can be routed to @controller classes. For example, a greeting controller is mapped to handle messages to the /hello destination as the following listing shows. The simulated delay, and this controller is concise and simple, but plenty is going on. We break it down step by step. At message, the at message mapping annotation ensures that if a message is sent to the /hello destination, the greeting method is called. The payload of the message is bound to a hello message object which is passed to greeting. Internally, the implementation of the method simulates a processing delay by causing the thread to sleep for 1 second. This is to demonstrate that after the client sends a message, the server can take as long as it needs to asynchronously process the message. The client can continue with whatever work it needs to do without waiting for the response. After the 1 second delay, the greeting method creates a greeting object and returns it. The return value is broadcast to all subscribers of /topic/greetings as specified in the @send_to annotation. Note that the name from the input message is sanitized, since in this case it will be echoed back to the re-rendered in the browser DOM on the client side. Now we are focusing on configure Spring for stomp messaging. Now that the essential component of the service are created, you can configure Spring to enable WebSocket on and stomp messaging. Create a Java class name WebSocket config. that resembles the following listing here. WebSocket config is annotated with @configuration to indicate that it is a Spring configuration class. It is also annotated with @enabled WebSocket message broker. As its name suggests, @enable WebSocket message broker enables WebSocket message handling backed by a message broker. The configure message broker method implements the default method in WebSocket message broker configurer. To configure the message broker, it starts by calling enable simple broker. To enable the simple memory-based message broker to carry the greeting messages back to the client, on destination prefix with /topic. It also designates the /app prefix for messages are bound for the method annotated with @message mapping. This prefix will be used to define the message mappings. For example, app/app/hello is the endpoint of the greeting controller.greeting method is mapped to handle. The register stomp endpoints method registers the /GS guide WebSocket endpoint, enabling sock.js fallback options so that the alternate transport can be used if the WebSocket is not available. The sock.js client will attempt to connect to /GS guide WebSocket and use the best available transport WebSocket HR-streaming, HR-polling, and so on. Create a browser client. With the server-side pieces in place, you can turn your attention to the JavaScript client that will send messages to and receive messages from the server side. Create an index.html file similar to this listing. This HTML file imports sock.js and stomp JavaScript libraries that will be used to communicate with our server through stomp over WebSocket. We also import app.js, which contains the logic of our client application. The following list shows this following list. This shows that file. The main pieces of this JavaScript file to understand are the connect and send name functions. The connect function uses sock.js and stomp.js to open a connection to /GS guide WebSocket, which is where our sock.js server waits for connections. Upon successful connection, the client subscribes to the /topic/greetings destination, where the server will publish greeting messages. When a greeting is received on the destination, it will append a paragraph element to the DOM to display the greeting message. The send name function retrieve the name entered by the user and uses the stomp client to send it to the /app/hello destination, where the greeting controller.greeting will receive it. The main .css the main.css can be omitted if you like, or you can create an empty one just so the link can be resolved. Now make the application executable. Spring Boot creates an application class for you. In this case, it needs no further modification. You can use it to run this application. Following listing shows the application class. At Spring Boot application is a convenience annotation that adds all of the following. At configuration, tags the class as a source of the bean definitions for the application context. At enable auto configuration, tells Spring Boot to start adding beans based on class path settings, other beans, and various property settings. For example, if Spring-MVC is on the class path, this annotation flags the application as a web application and activates key behaviors such as setting up a dispatcher servlet. At component scan, tells Spring to look for other components configurations and services in the com/example package, letting it find the controllers. The main method uses Spring Boot application.run method to launch an application. Did you notice that there was a single line of there was not a single line of XML? There is no web.xml file either. This web application is 100% pure Java, and you did not have to deal with the configuration, any plumbing or infrastructure, because we are using here Spring Boot. So to show this example, I use Spring Boot here. As an example 4, we are focusing on WebSocket handler in WebSocket API. The following example uses text WebSocket handler. The class text WebSocket handler, a convenient base class for WebSocket handler implementations that process text messages only. This is in the package org.springframework.web.socket.handler. Creating a WebSocket server is as simple as implementing a WebSocket handler, or more likely extending either text WebSocket handler or binary WebSocket handler. Following example uses text WebSocket handler. There is dedicated WebSocket Java configuration and XML namespace support for mapping the preceding WebSocket handler to specific URL as following example shows. The interface WebSocket configurer defines callback methods to configure the WebSocket request handling via at enable WebSocket. The following example shows XML configuration equivalent of preceding this example. This example is for use in Spring MVC applications and should be included in the configuration of a dispatch servlet. However, Spring's WebSocket support does not depend on Spring MVC. It's relatively simple to integrate WebSocket handler into HTTP serving environment with the help of WebSocket HTTP request handler. When using WebSocket handler API directly versus indirectly, like for example through the stomp messaging, the application must synchronize the sending of messages since the underlying standard WebSocket session JSR 356 does not allow concurrent sending. One option is to wrap the WebSocket session with concurrent WebSocket session decorator. Now we are focusing on WebSocket handshake. The following example uses a built-in interceptor to pass HTTP session attributes to the WebSocket session. The class HTTP session handshake interceptor, an interceptor to copy information from HTTP session to the handshake attributes map to made available via WebSocket session.getAttributes method. This is in the package org.springframework.web.socket.server.support. The easiest way to customize the initial HTTP WebSocket handshake request is through handshake interceptor, which exposes methods before and after the handshake. You can use such an interceptor to preclude the handshake or to make any attributes available to the WebSocket session. The following example uses a built-in interceptor to pass HTTP session attributes to the WebSocket session. The following example shows XML configuration equivalent of the preceding example. More advanced option is to extend the default handshake handler that perform the steps of WebSocket handshake, including validating the client origin, negotiating a sub-protocol and other details. An application may also need to use this option if it needs to configure a custom request upgrade strategy in order to adapt to a WebSocket server engine and version that is not yet supported. Both Java configuration and XML configuration namespace make it possible to configure a custom handshake handler. Spring provides a WebSocket handler decorator base class that you can use to decorate a WebSocket handler with additional behavior. Logging and exception handling implementations are provided and added by default when using WebSocket Java configuration or XML namespace. The exception WebSocket handler decorator catches all uncaught exceptions that arise from any WebSocket handler method and closes the WebSocket session with status 1011, which indicates a server error. Now we are focusing on server configuration. For Tomcat, Wildfly and Glassfish, you can add the Servlet server container factory bean to your WebSocket Java config, as the following example shows. The class Servlet server container factory bean. A factory bean for configuring server container. Since there is usually only one server container instance accessible under well-known java x.servlet.servlet context attribute, simply declaring this factory bean and using the setters allows for configuring the server container through Spring configuration. This is in the package org.springframework.web.socket.server.standard. Each underlying WebSocket engine exposes configuration properties that control runtime characteristics such as size of the message buffer, as the size of message buffer sizes, idle timeouts, and others. For Tomcat, Wildfly, and Glassfish, you can add the Servlet server container factory bean to your WebSocket Java config, as the following example shows. Following example shows XML configuration equivalent of this example. For client-side WebSocket configuration, use WebSocket container factory bean in XML or container provider dot get WebSocket container method in Java configuration. Now we are focusing on sock.js fallback. All transport requests have the following URL structure. The goal of sock.js is to let application use a WebSocket API but fall back to non-WebSocket alternatives when necessary at runtime without the need to change application code. Sock.js consists of the sock.js protocol defined in the norm form of executable narrated test, the sock.js JavaScript client, the client library for use in browsers, sock.js server implementation including one in the Spring framework, Spring WebSocket module, the sock.js Java client in Spring WebSocket server module since version 4.1. Sock.js is designed for use in browsers. It uses a variety of techniques to support a wide range of browser versions. The full list of sock.js transport types and browsers you can see through sock.js client page in JIT Hub. Transport fall in three general categories: WebSocket, HTTP streaming, and HTTP long polling. Sock.js client begins by sending get /info to obtain basic information from the server. After that, it must decide what transport to use. If possible, Sock.js is used. If not, the most browsers there is at least one HTTP streaming option. If not, Then HTTP long polling is used. All transport requests have the following URL structure, where server ID is useful for routing request in the cluster but is not used otherwise. Session ID correlates HTTP request belonging to sock.js session. Transport indicates the transport type, for example WebSocket, XHR-streaming and others. The WebSocket transport needs only a single HTTP request to do the WebSocket handshake. All messages thereafter are exchanged on that socket. HTTP transports require more requests. AJAX XHR streaming, for example, relies on long-running requests for server-to-client messages, additional HTTP post requests for client-to-server messages. Long polling is similar, except that it ends the current request after each server-to-client send. Sock.js adds minimal message framing. For example, server sends letter O, open frame initially. Messages are sent as A, message 1, message 2, JSON encoded array, the letter H, heartbeat frame. If no messages flow for 25 seconds by default, the letter C close frame to close the session. The sock.js client allows fixing the list of transports, so it is possible to see each transport one at a time. The sock.js client also provides a debug flag, which enables helpful messages in the browser console. On the server side, you can enable trace logging for org.springframework.web.socket. You can enable sock.js through Java configuration, as following example shows. The method sock.js service registration with sock.js enable sock.js fallback options. This is in the interface WebSocket handler registration. Following example shows XML configuration equivalent of preceding example. This example is for use in Spring MVC application and should be included in the configuration of Dispatch Servlet. However, Spring's WebSocket and sock.js support does not depend on Spring MVC. It is relatively simple to integrate into other HTTP serving environment with the help of sock.js HTTP request handler. On the browser, applications can use sock.js-client version 1.0.x. It emulates the W3C WebSocket API and communicate with the server to select the best transport opinion depending on the browser in which it runs. The client also provides several configuration options, for example, to specify which transport to include. The following example shows how to create a sock.js client and connect to a sock.js endpoint. The class sock.js client, a sock.js implementation of a web client with the fallback alternatives that simulate the WebSocket interaction through plain HTTP streaming and long polling techniques. This is in the package org.springframework.web.socket.sockjs.client. This SockJS client, Spring provides the SockJS Java client to connect to a remote SockJS endpoint without using a browser. This can be especially useful when there is a need for bidirectional communication between two servers over public network, that is where network proxies can preclude the use of WebSocket protocol. A SockJS Java client is also very useful for testing purposes, for example, to simulate a large number of concurrent users. The SockJS Java client supports WebSocket, XHR streaming and XHR polling transports. Remaining ones only make sense for use in the browser. You can configure WebSocket transport with standard WebSocket client in JSR 356 runtime, Jetty WebSocket client by using Jetty 9 plus native WebSocket API, any implementation of Spring's WebSocket client, and XHR transport by definition supports both XHR streaming and XHR polling. Since from the client perspective there is no difference other than in the URL based on the connect to the server. At present there are two implementations. REST template XHR transport uses Spring's REST template for HTTP request. Jetty XHR transport uses Jetty's HTTP client for HTTP request. Following example shows how to create SockJS client and connect to a SockJS endpoint. SockJS uses JSON formatted arrays for messages. By default, Jackson 2 is used and needs to be on class path. Alternatively, you can configure a custom implementation of SockJS message codes and configure it on the SockJS client. As an example 11, we are moving into Stomp. The following example shows a client subscribing to receive stock quotes which the server may emit periodically. For example, via a scheduled task that sends the messages through a simple messaging template to the broker. Structure of the Stomp frame. Here you can see structure for Stomp frame. Command header 1 colon header value 1. Header 2 colon value 2 and body ampersand, body caret sign ampersand here. Stomp simple text-oriented messaging protocol was originally created for scripting languages such as Ruby, Python and Perl to connect to enterprise message brokers. It is designed to address a minimal subset of commonly used messaging patterns. Stomp can be used over any reliable two-way streaming network protocol such as TCP and WebSocket. Although Stomp is a text-oriented protocol, message payloads can be either text or binary. Stomp is a frame-based protocol whose frames are modeled on HTTP. The following this listing shows structure of a Stomp frame. Clients can use send or subscribe commands to send or subscribe for messages along with destination. Header that describes what the message is about and who should receive it. This enables a simple publish subscribe mechanism that you can use to send messages through the broker to other connected clients or to send messages to the server to request some work to be performed. When you use Spring Stomp support, the Spring WebSocket application acts as the Stomp broker to clients. Messages are routed to at controller message handling methods, or to simple in-memory broker that keep track of subscriptions and broadcast messages to subscribe users. You can also configure Spring to work with dedicated stomp brokers such as RabbitMQ, ActiveMQ, and others for actual broadcasting of messages. In that case, Spring maintains TCP connection to the broker, relays messages to it, and passes messages from it down to the connected WebSocket clients. Thus, Spring frameworks can rely on unified TCP-based security, common validation, and a familiar programming model for message handling. The following example shows a client subscribing to receive stock quotes, which the server may emit periodically, for example, via scheduled tasks that sends messages through simple messaging template to the broker. The following example shows the client that send trade requests, which server can handle through at message mapping method. After execution, the server can broadcast the trade confirmation message and details down to the client. The meaning of the destination is intentionally left opaque in the Stomp spec. It can be any string, and it is entirely up to Stomp servers to define the semantics and syntax of destinations that they support. It is very common, however, for the destination to be path-like strings where /topic / etc. implies publish, subscribe, one to many, and q /q / implies point to point, one to one messages, message exchanges. After this is as an example 12, we are considering enable Stomp. After configuring dependency, you can expose Stomp endpoints over WebSocket with sock.js fallback, as this example shows. Stomp over WebSocket support is available in the Spring-messaging and Spring-WebSocket modules. Once you have those dependencies, you can expose Stomp endpoint over WebSocket with sock.js fallback, as the following example shows here. Here the /portfolio is the HTTP URL for the endpoint to which the WebSocket or sock.js client need to connect for a WebSocket handshake. Here the Stomp message, those whose destination header begins with the /app are routed to @message mapping methods at controller classes. Use the built-in message broker for subscriptions and broadcasting, and route messages whose destination header begins with /topic and /q to the broker. This example shows the XML configuration equivalent of this example. For the built-in simple broker, that /topic and /q prefixes do not have any special meaning. They merely a convention to differentiate between pub/sub versus point-to-point messaging, that is many subscribers versus one customer. When you use external broker, check Stomp page of the broker to understand what kind of Stomp destination and prefixes support. For Jetty however, this is regarding WebSocket server. For Jetty, however, you need to set the handshake handler and WebSocket policy through Stomp endpoint registry. Interface Stomp endpoint registry, a contract for registering Stomp over the WebSocket endpoints. This is in the package org.springframework.web.socket.config.annotation. As an example 14, we are considering flow of messages. We can trace the flow through the simple example. Consider the following example with set up a server. This example supports the following flow. One, the client connects to the HTTP //localhost /8080/portfolio. And once WebSocket connection is established, the Stomp frame begin to flow on it. The client send a subscribe frame with the destination header /topic/greeting. Once received and decoded, the message is sent to the client inbound channel and then is then routed to the message broker, which stores the client subscription. Step 3, the client send the frame to /app/greeting. Then the /app prefix helps to route the annotated controllers. After the /app prefix stripped, the remaining /greeting part of the destination is mapped to the @message mapping method in greeting controller. The value returned from the greeting controller is turned into the Spring message with the payload based on the return value and the default destination header of /topic greeting derived from the input destination with /app replaced by topic. The resulting message is sent to the broker channel and handled by the message broker. The message broker finds all matching subscribers and sent a message frame to each one through client outbound channel from where messages are encoded as Stomp frames and sent on the WebSocket connection. As an example 15, we are considering a Stomp external broker. The following example configuration enables full features broker. Interface Stomp endpoint registry, a contract for registering Stomp over WebSocket endpoints. It is in the package org.springframework.web.socket.config.annotation. The simple broker is a great for getting started for, but supports only subset of Stomp command if it does not support X receipt and some other features. relies on simple message sending loop and it's not suitable for clustering. As an alternative, you can upgrade to application to use a full features message broker. You can enable the Stomp broker relay instead of simple broker in the Spring configuration. The following example configuration enables the full features broker. This following example shows the XML configuration equivalent of this example. The Stomp broker relay in the preceding configuration here is a Spring message handler that handles messages by forwarding them to an external message broker. To do so, and it established TCP connections to the broker, forwards all messages to it, and then forward all messages received from the broker to the client through their WebSocket session. Essentially, it acts as a relay that forwards messages in both directions. Add io.project reactor.netty reactor-netty and io.netty all dependencies to a project for TCP connection management. Furthermore, the application components such as TCP request handling methods, business services, and others can also send messages to the broker relay. In effect, a broker relay enables robust and scalable message broadcasting. For example, with the Java Stomp client, you could do the following to add a recipient. The class WebSocket Stomp client, a Stomp over WebSocket client that connects using an implementation of WebSocket client, including sockjs client. This is in the package org.springframework.web.socket.messaging. During initialization, when subscribing, subscriptions ready. As example 16, we are considering Stomp client. To begin, you can create and configure Stomp client WebSocket Stomp client, as the following example shows. The class WebSocket Stomp client, a Stomp over WebSocket client that connects. This is the WebSocket. One second. This is the WebSocket Stomp client here. The class WebSocket Stomp client, a Stomp over WebSocket client that you connect using implementation of WebSocket client, including sockjs client. This is in the package org.springframework.web.socket.message. Spring provide Stomp over WebSocket client and Stomp over TCP client. To begin, you can create and configure Stop WebSocket Stomp client, as the following example shows. In this example, actually you can replace standard WebSocket client with SockJS client, since that is also an implementation of WebSocket client. The SockJS client can use WebSocket or HTTP based transport as fallback. For heartbeats here. Now we are, as an example 17, now we are focusing on performance. The following example shows a possible configuration. There's no silver bullet when it comes to the performance. Many factors affect it, including size and volume of the messages, whether applications method perform work that require blocking, and external factors such as network speed and other issues. The goal of this example is to provide an overview of available configuration along with some thoughts on how reason about scaling with regarding this topic, performance. In messaging application, messages are passed through channels for asynchronous execution that are backed by thread pools. Configuring such an application requires a good knowledge of channels and the flow of messages. Obvious place to start to configure the thread pools that back the client inbound channel and client outbound channel. The default both are configured at twice the number of available processes. If the handling messages in annotated method is mainly CPU bound, and number of threads in the client inbound channel should remain close to the number of processes. If the work they do is more IO bound and requires blocking or waiting on database or other external system, the thread pool size probably need to be increased. The thread pool executor has three important properties: the core thread pool and max thread pool, and capacity for the queue to store tasks for which there are no available threads. A common point of confusion that configuration, the core pool size, for example 10, the max pool size, for example 20, result in a thread pool with 10 to 20 threads. In fact, if the capacity is left at its default value of integer max value, the thread pool never increases beyond the core pool size, since all additional tasks are queued. On the client outbound channel side, it is about sending messages to WebSocket client. If the clients are on fast network, the number of threads should remain close to the number of available processes. If they are slow or on low bound, they take longer to consume messages and to put a burden to the thread pool before increasing the thread pool size becomes necessary. While workload for client inbound channel is possible to predict, after all, it is based on what application does. How to configure the client outbound channel is harder, and it is based on the factors beyond the control of the application. For this reason, two additional properties related to sending messages: set time limit and set buffer size, send time limit and send buffer size limit. You can use those methods to configure how long a send is allowed to take and how much data can be buffered when sending messages to client. In general, the general idea is that any given time only a single thread can be sent to the client. In additional messages, meanwhile, get buffered, and you can use these properties to decide how long sending a message is allowed to take and how much data can be buffered in the meantime. Following example shows the possible configuration, and following example shows the XML configuration equivalent of this example here. You can also use WebSocket transport configuration to configure the maximum allowed size for incoming stomp messages. In theory, WebSocket can a WebSocket message can be almost unlimited in size. In practice, WebSocket servers impose limits, for example 8K on Tomcat and 64K on Jetty. For this reason, Stomp clients such as the JavaScript Stomp dash client, JavaScript Web Stomp dash client, and others split larger Stomp messages at 16K boundaries and send them as multiple WebSocket messages, which require the server to buffer and reassemble. As an exception example, we can consider exception WebSocket handler decorator class, exception WebSocket handler decorator, and exception handling WebSocket handler decorator traps all throwable instances that escape from the decorated handler and closes the session with close status server underscore error. This is in the package org.springframework.web.socket.handler. As an error example, we can consider unexpected response code 400. This is occurred in with environment with Spring and Sock.js, error during WebSocket handshake. Now we are focusing on Servlet. The Spring Web MVC module, also known as Web Servlet module, contains Spring's Model View Controller, MVC, and REST Web Services implementation for web applications. Spring's MVC framework provides a clean separation between domain model code and web forms, and integrates with all of the other features of the Spring framework. Here you can see the request processing workflow in workflow in Spring Web MVC Spring Web MVC, and this is high level. Spring's Web MVC framework like many other Web MVC frameworks, request driven, designed around a central servlet that dispatches requests to controllers and offers other functionality that facilitate the development of web applications. Spring's dispatch servlet, however, does more than just that. It is completely integrated with Spring IOC container, and as such allows you to use every other feature that Spring has. The request processing workflow of the Spring Web MVC dispatch servlet is illustrated in this the diagram. The pattern-savvy reader will recognize that the dispatch servlet is an expression of the front controller design pattern, and this is a pattern that Spring Web MVC shares with many other leading web frameworks. The dispatch servlet is an actual servlet. It inherits from the HTTP servlet base class, and as such is declared in your web application. You need to map requests that you want the dispatch servlet to handle by using URL mapping. Here you can see incoming request to front controller, and front controller model and view template is inside servlet engine, for example Tomcat, and front controller front controller returns return response. Front controller interact with controller, and delegate request is passed from front controller to controller, and delegates rendering response is passed from controller to front controller. Model is passed from controller to front controller. Controller handle request and create model, and front controller interacts with view template. Model is passed from front controller to view template, and render response is passed from front controller to view response, and return control is passed from view template to front controller, and front controller return response. Here you can see typical context hierarchy in Spring Web MVC. Dispatcher servlet expects a web application context, an extension of a plain application context for its configuration. Web application context has a link to the servlet context, and the servlet with it is associated. It is also bound to the servlet context. Such that application can use static method on request context utils to look up the web application context if they need access to it. For many applications, having a single web application context is simple and sufficient. It is also possible to have a context hierarchy where one root application context is shared across multiple dispatch servlets or other servlet instances, each with its own child web application context configuration. The root web application context typically contain infrastructure beans, such as the data repositories and business services that need to be shared across multiple servlet instances. Those beans are effectively inheritance and can be overridden, that is redeclared in the servlet specific child web application context, which typically contains beans local to given servlet. This image shows this relationship. Here you can see dispatcher servlet. Within it, here you can see servlet web application context containing controllers, view resolvers, and other web related beans. And here you can see controllers, view resolver, and handler mapping inside servlet web application context. Servlet web application context is connected to root web application context. Delegates if no bean found here. from Servlet web application context to root application context, and root web application context containing middle tier services, data resources, etc. Services and repositories are in root application context. Here you can see a single root context in Spring Web MVC. It is also possible to have just one root context for single dispatcher servlet scenarios. Here you can see dispatcher servlet with empty context configuration location, and here you can see the servlet web application context. Servlet web application context is connected to root web application context. Delegates is passed from servlet web application context to the root web application context. Root web application context containing all beans, controllers, handler mapping, view resolver, services, and repositories are inside root web application context. Here you can see the processing flow of Spring MVC from receiving the request till the response is returned is shown in this diagram. Here in step 1, dispatcher servlet receive the request. Step 2, the dispatcher servlet dispatches the task of selecting the appropriate controller to handler mapping. Handler mapping select the controller which is mapped to the incoming request. This is mapped to the incoming request URL and returns the selected handler and the controller to dispatcher servlet. Dispatchers, step 3, dispatcher servlet dispatches the task of executing of business logic of controller to handler adapter. Step 4, handler adapter calls the business logic process to controller. Step 5, controller executes the business logic, sets the processing result in model, and returns the logical name of view to handler adapter. Step 6, dispatcher servlet dispatches the task of resolving the view corresponding to the view name to view resolver. The view resolver returns the view mapped with the view name. Step 7, dispatcher servlet dispatches the rendering process to return view. Step 8, view renders model data and returns the response. Here you can see a request is connected to dispatcher servlet. Request is passed to dispatcher servlet. Dispatcher servlet is connected to handler mapping here, and handler mapping is connected to controller. Choose handler is passed from handler mapping to controller. Here dispatcher servlet is connected to handler adapter. Handler adapter is connected to controller. Controller is connected to view name. View name is connected to handler adapter. Here dispatcher servlet is connected to view resolver. View resolver is connected to view, and resolve view is passed from view resolver to view, and dispatcher servlet is connected to view, and response is a view returns the response. And here control is connected to model. Set processing result models are passed from controller to view model, and here view is connected to model. Reference processing and result reference processing result models pass from view to model. Here control is connected to service. Business logic, execute business logic contains service, repository, and database. Service business logic is interact with repository data access. Repository interact with database. Here view name, controller, view name, service, and repository are implemented by developers. And dispatch servlet, handler mapping, handler adapter, view resolver, model, and database are provided by Spring source. Here view is provided by Spring source, sometimes implemented by developers. Here you can see a servlet container and Spring framework. Concepts: web server. It supports HTTP protocol. It only supports static resource like image and HTML files. However, it cannot handle dynamic containers. Apache web server is the most popular web server, followed by Microsoft's IIS and NGINX, also a good one. Web container, servlet container supports JSP servlet API. Web container is responsible for managing life cycles of servlets, mapping a URL to a particular servlet and ensuring that URL request has the correct access rights. Web container creates a servlet instances, loads and unload servlets, creates and manages request and response objects, and perform other servlet management tasks. For example, Apache Tomcat, Jetty, Wildfly. It works in web server. For example, Tomcat lives in Apache. It generates some static contents and returns responses. Tomcat is both web server and web container, but it's not really meant to function as a high performance web server, nor does it include some features typical of a web server. Tomcat is the servlet runtime environment, that is a servlet container. And servlet filter, servlet listener, Spring container, IOC container, Spring security filters, delegating filter proxy, filter chain, security filter chain, Spring MVC dispatcher servlet. The dispatcher servlet is an actual servlet. It inherits from HTTP servlet base class. Interceptor and AOP. Here you can see user interacts with servlet filter. Request is passed from user to servlet filter, and request is passed from servlet filter to servlet, and here response is passed from servlet to servlet filter, and response is passed from servlet filter to user here, and servlet filter interacts with servlet. Servlet container consists load servlet initialization, servlet, and servlet filter. Here you can see shared config web.xml in servlet container and Spring container, and servlet container and Spring container are in web server. Here in init, service, do get, do post, and destroy are in servlet. Servlet interacts with dispatcher servlet in Spring web container in Spring container. Dispatcher servlet and controller is in Spring MVC container. Service here service is control is connected to the service. MVC Spring MVC container is inside Spring container. The following picture illustrates the logical architecture of a Spring MVC based application. And having said that, you can use Spring Boot to create web apps that are based on Spring MVC. Let's understand the key features. The key features of Spring MVC are dispatcher servlet, front controller, and model view controller MVC design patterns, handler mappings and annotated controllers, form handling and form validation, view resolution, view solvers for exception, local, theme, logging, integration with Spring Security, Servlet Sync API, view technologies, Daimleaf, FreeMarker, JSP, JSTL, PDF, Excel, etc. And Spring MVC is well known for having boilerplate code with lots of XML configurations. Here application code, Spring MVC, Spring Framework core, Java Servlet API are inside Servlet container. Here Apache Tomcat here. The following picture shows illustrates the logical architecture of Spring Boot application of a Spring Boot application. Where the key features of Spring Boot are the standalone applications with embedded server, no need for var deployment, starter dependencies that simplifies dependency management, automatic configuration of Spring and third-party libraries, production ready features, matrices, health check, externalized configuration. And the Spring Boot frees developers from boilerplate code and XML configuration, no code generation, no XML configs. Here you can see application code and Spring MVC and Spring's frameworks core, Servlet API. Here Spring Boot, starter dependencies, automatic configuration, and bottom standalone Java program with embedded server. Here you can see three-tier, three-layer architecture versus MVC pattern. The three-tier, three-layer architecture. Three-tier or three-layer architecture is widely accepted solution to organize code base. According to this architecture, code base is divided into 3 separate layers with distinctive responsibilities. Presentation layer, business logic layer, and data access layer. Presentation layer, this is the user interface of the application that present application's features and data to the user. Business logic or application layer. This layer contains business logic that drives the application's core functionalities, like making decisions, calculations, evaluations, and processing the data passing between other 2 layers. Data access layer or data layer. This layer is responsible for interacting with databases to save and restore application data. Here presentation layer is connected to business logic layer, and business logic layer is connected to data access layer. 3-layer architecture versus MVC pattern. Let's see how these 2 architectural patterns, both containing 3 connected components, relate to each other. MVC pattern is only concerned with organizing the logic in the user interface presentation layer. As name implies, MVC pattern has 3 layers. The model defines the business layer of the application. The controller manages the flow of application. And the view defines the presentation layer of the application. The model layer, this is the data layer which contains the business logic of the system and also represent the state of the application. It's independent of the presentation layer. The controller fetches the data from the model layer and send it to the view. The controller fetches data from the model layer and send it to the view layer. The controller layer acts as an interface between view and model. It receives the request from the view layer and processes them and including necessary validations. View layer. This layer represents output of the application, usually some form of UI. Presentation layer is used to display model data fetched by controller. 3-tier architecture is a broader concern. It's about organizing code in the whole application. The controller component of MVC is connection point between 2 layers. Here view is connected to the client and client is connected to the control. View interacts with presentation layer. Client interacts with presentation layer. You can see view, controller, and model are inside presentation layer. Presentation layer is connected to business logic layer, and business logic layer is connected to data access layer. Here you can see in Spring MVC web application, the 3 layers of the architecture will manifest as follows here. The controller classes as the presentation layer keeps this layer as thing as possible and limited to the mechanics of the MVC operations. For example, receiving and validating the input manipulating the model object, returning the appropriate model and view object, and so on. All the business related operations should be done in the service classes. Controller classes are usually put in the controller package. Service classes as business logic layer. Calculations, data transformations, data processes, and cross record validations. Business rules are usually done at this layer. They get called by the controller classes and might call repositories or other services. Service classes are usually put in the service package. Repository classes as data access layer. This layer's responsibility is limited to create, retrieve, update, and delete CRUD operations on a data source, which is usually a relational or non-relational database. Repository classes are usually put in a repository package. Here we are considering controller classes and service classes and repository classes here. And presentation layer is connected to business logic layer. Business logic layer is connected to data access layer here. Now we are focusing on applicability with regarding to Spring MVC or WebFlex. The following diagram shows how the two relate, what they have in common, and what each supports uniquely. We suggest that you consider the following specific points. If you have a Spring Web applications that works fine, there is no need to change. Imperative programming is the easiest way to write, understand and debug code. If you have maximum choice of libraries, since historically most are blocking. If you are already shopping for a non-blocking web stack, Spring WebFlex offers the same execution model benefits as others in this space and provides the choice of servers, Netty, Tomcat, Jetty, Undertow, and Servlet 3.1 plus containers. The choice of programming models, annotated controllers, and functional web endpoints, and choice of reactive libraries, Reactor, RxJava, or other. If you are interested in a lightweight functional web framework for use with Java 8 Lambdas or Kotlin, you can use the Spring WebFlux functional web endpoints. That can also be a good choice for small applications or microservices with less complex requirement that can benefit from greater transparency and control. In microservice architecture, you can have mixed applications with either Spring MVC or Spring WebFlux controllers or Spring WebFlux functional endpoints. Having support for the same annotation-based programming model in both frameworks makes it easier to reuse knowledge while also selecting the right tool for the right job. A simple way to evaluate an application is to check its dependencies. If you have a blocking persistence APIs, JPA, JDBC, or networking APIs to use, Spring MVC is the best choice for common architectures. At least it is technically feasible with both Reactor and RxJava to perform blocking calls on a separate thread, but you would not making the most of the non-blocking web stack. If you have a Spring MVC application with calls to remote services, try the reactive web client. You can return reactive types, Reactor, RxJava, or other directly from Spring MVC controller methods. the greater the latency per call or the interdependency among calls, the more dramatic the benefits. Spring MVC controllers can call other reactive components too. If you have a large team, keep in mind the steep learning curve in the shift to non-blocking, functional and declarative programming. A practical way to start with without a full switch is to use reactive web clients. Beyond that, start small and measure the benefits. We expect that for a wide range of application, the shift is unnecessary. If you are unsure what benefit to look for, start by learning how non-blocking I/O works. For example, concurrency on a single-threaded node.js and its effects. Here you can see Spring MVC. Here you can see imperative logic, simple to write and debug. JDBC, JPA blocking depths. Here you can see Spring WebFlex, functional endpoints, event loop, concurrency model, and netty under that. In both Spring MVC and Spring WebFlux, you can see at controller, reactive clients, and Tomcat, Jetty, and Undertow is there. And you can see netties in Spring WebFlux. We are focusing on as an example, we can consider Maven segment here, and here you can see the artifact Spring -MVC, Web MVC. Spring Web MVC contains Spring's model view controller MVC and REST web services implementation for web applications. It provides a clean separation between domain model code and web forms and integrates with all of the other features of Spring framework. As an example too, we can consider package org.springframework.web.servlet. Provides servlets that integrate with the application context infrastructure and the core interfaces and classes for the Spring Web MVC framework. As an example 3, we are considering a dispatcher servlet. Following example of the Java configuration registers and initializes the dispatcher servlet, which is auto detected by the servlet container. Class dispatcher servlet, the central dispatcher for HTTP request handlers and controllers. For example, for a web UI controller or HTTP based remote service exporters, dispatchers to register handlers for processing a web request, providing convenient mapping and exception handling facilities. This is in the package org.springframework.web.servlet. Spring MVC, as many other web frameworks, designed around the front controller pattern, where a central servlet, the dispatcher servlet, provides a shared algorithm for request processing, while actual work is performed by configurable delegate components. This model is flexible and provides and supports diverse workflows. The dispatcher servlet, as any servlet, needs to be declared and mapped according to the servlet specification by using Java configuration or in web.xml. In turn, the dispatcher servlet uses Spring configuration to discover the delegate components it needs for request mapping, view resolution, and exception handling, and more. The following example of Java configuration registers and initializes the dispatcher servlet, which is auto detected by the servlet container. In addition to using Servlet Context API directly, you can also extend abstract annotation, config dispatcher, servlet initializer, and override specific methods. For programmatic use cases, a generic web application context can be used as an alternative to annotation config web application context. The following example of web.xml configuration registers and initializes the dispatcher servlet. Spring Boot follows a different initialization sequence. Rather than hooking into the lifecycle of servlet container, the Spring Boot uses Spring configuration to bootstrap itself an embedded servlet container. Filter and servlet decorations are detected in Spring configuration and registered with the servlet container. Load Spring web application configuration. Create and register the dispatcher servlet. As an example, we are considering form data in filters. The Spring Web module provides form content filter to intercept HTTP put, patch, and delete request with the content type of application /x-www-form- URL encoded. Read the form data from the body of the request and wrap the servlet request to make the form data available through the servlet request.getParameter method family of methods. Class form content filter filters filter that passes form data for HTTP put, patch, and delete request and exposes it as a servlet request parameters. By default, the servlet spec only requires this for HTTP post. This is in the package org.springframework.web.filter. Browsers can submit form data only through HTTP GET or HTTP POST, but non-browser client can also use HTTP put, patch, and delete. The Servlet API requires HTTP servlet request.getParameter methods to support field access only for HTTP POST. Here you can see an annotation type controller indicates that an annotated class is a controller, for example, web controller. This is in the package org.springframework.stereotype. Spring MVC provides an annotation-based programming model where at controller and at REST controller components use annotations to express request mappings, request inputs and exception handling and more. Annotated controllers have flexible method signatures and do not have to extend base class nor implement specific interfaces. Following example shows a controller defined by annotations. In this example, the method accepts a model and returns a view name as string, but many other options exist and exist. Here, as a part of WebMVC, I'm explaining these parts, not really in the related, not really in the servlet. As an example 6, with regarding to explicit registration, we are this following example registers a handler method. Here the class method request mapping info. The request mapping information encapsulates the following request mapping conditions: patterns, request condition, request methods, request condition, param request condition, headers request condition, consumes request condition, produces request condition, optional custom request condition. This is in the package org.springframework.web.servlet.mvc.method. You can programmatically register handler methods, which you can use for dynamic registration for advanced cases such as different instances of the same handler and different URLs. The following example registers a handler method. Here inject the target handler and the handler mapping controllers. Here prepare the request mapping data. And here get handler method. And here add registration. As an example 7, we are considering functional endpoints. Router functions root method provides a router builder that facilitates the creation of routers, as following example shows. The interface router function T extend server response. This is a functional interface and therefore be used as a assignment target for lambda expression or method references. This is in the package org.springframework.web.servlet.function. In webmvc.fn, an HTTP request is handled with a handler function, a function that takes a server request and returns a server response. Both the request and the response object have immutable contract that offer JDK 8 friendly access to the HTTP request and response. Handler function is the equivalent of the body of at request mapping method in the annotation based programming model. Incoming requests are routed to a handler function with the router function, a function that takes server request and returns an optional handler function. That is optional handler function. When the router function matches, a handler function is returned, otherwise empty, an empty optional. Router function is an equivalent of at request mapping annotation, but with the major difference that router functions provide not just data but also behavior. Router functions route method provides a route builder that facilitates creation of routers, as following example shows. You can register the router function as a bean, for instance, by exposing it in at register at configuration class. It will be auto detected by the servlet. Router functions.route provides a router builder that facilitates the creation of routers, as following example shows. The interface router function t-extender server response. This is a functional interface and can therefore be used as a assignment target for lambda expression or method reference. This is in the package org.springframework.web.servlet function. With regarding handler classes, we can write handler function as lambda. That is convenient, but an application we need here is the multiple functions, and multiple inline lambdas can get messy. Therefore, it is useful to group related handler functions together into a handler class, which is similar role as at controller in an annotation based application. For example, the following class exposes a reactive person repository. Here you can see list people. List people is a handler function that returns all person objects found in the repository as JSON. Create person is a handler function that stores a new person contained in the request body. The get person is the handler function that returns a single person identified by the ID path variable. We retrieve that person from the repository and create a JSON response. If not found, we return the 404 not found response. Router functions are evaluated in order. The first root does not match. The second is evaluated. Therefore, it makes sense to declare more specific roots before general ones. This is also important when registering router functions as string beans. And note that this behavior is different from annotation-based programming model where the more specific controller method is picked automatically. Using router function builder, all defined roots are composed into one router function that is returned from the build method. There are also other ways to compose multiple router functions together. Add router function on the router functions dot root builder, router function dot and router function dot and root request predicate handler function, shortcut for router function dot and with nested router function dot root. Following example shows the composition of 4 roots. Get /person/id with an accept header that matches JSON is routed to person handler dot get person. Here the get /person with an accept header that matches JSON is routed to person handler dot list people. Here the post /person with no additional predicates is mapped to person handler dot create person and other root is a router function that is created elsewhere and added to the root build. The following example shows the WebFlux Java configuration. Interface web MVC configurer defines callback method to customize this Java-based configuration for Spring MVC enabled web MVC. This is in the package org.springframework.web.servlet.config.annotation. Running a server here, you typically run router functions in a dispatch handler based setup through MVC config, which uses Spring configuration to declare components required to process requests. With MVC, Java configuration declares the following infrastructure components to support functional endpoints. Router function mapping detects one or more router function beans in a Spring configuration, order them, combines them through router functions dot and another, and routes requests to the resulting composed router function. Handler function adapter, simple adapter that lets dispatcher handler invoke a handler function that was mapped to a request. The preceding components let functional endpoints fit within dispatcher servlet request processing lifecycle and also potentially run side by side with annotated controllers if any are declared. It is also how functional endpoints are enabled by the Spring Boot web starter. The following example shows WebFlux configuration. Configure message conversion, and here config cause. Here configure view resolution for HTML rendering. As an example 9, we are considering relative servlet request in URI links. You can use servlet URI components builder to create URIs relative to the current request, as following example shows. The class URI servlet URI component builder, URI component builder with additional static factory method to create links based on the current HTTP servlet request. This is in the package org.springframework.web.servlet.support. Reuses scheme, host, port, path, and query string here. As an example 10, we are considering streaming objects in HTTP streaming in asynchronous request. You can use a response body emitter return value to produce stream of objects where each object is serialized with the HTTP message converter and written to the response as the following example shows. The class response body emitter, a controller method return value type for asynchronous request processing, where one or more objects are written to the response. This is in the package org.springframework.web.servlet.mvc.method.annotation. You can also use a response body emitter as the body in the response entity, letting you to customize the status and headers of the response. Where an emitter throws an IO exception. For example, if the remote client went away, applications are not responsible for cleaning up the connection and should not invoke emitter.complete or emitter.complete with an error. Instead, the servlet container automatically initiates an async listener error notification in which the Spring MVC makes a complete with error call. This call in turn performs one final async dispatch to the application, during which Spring MVC invokes the configured exception resolvers and completes the request. Save emitter somewhere in some other thread, and again later on, and done at some point. Here we are considering configuration in asynchronous request. With the servlet container, filter and servlet declaration have an async supported flag that needs to be set true to enable asynchronous request processing. In addition, filter mapping should be declared to handle async. javax.servlet.dispatch type. In Java configuration, when you use abstract annotation config dispatcher servlet initializer to initialize servlet container, this is done automatically. In web.xml configuration, you can add async-supported through /async supported to the dispatch servlet and to filter declarations and add dispatcher async /dispatcher to filter mappings. In Spring MVC, the MVC configuration exposes the following options related to asynchronous request processing. Java configuration to use the configure async support callback on web MVC configurer. In XML namespace, use async-support element for MVC colon annotation driven. You can configure the following: default timeout value for async request, which is not depends on the underlying servlet container. Async task executor to use for blocking writes when streaming with reactive types and for executing callable instances returned from controller methods. We highly recommend configuring this property if you stream with reactive types or have controller method that return callable, since by default it is a simple async task executor. Deferred result processing interceptor implementations and callable processing interceptor implementations. Note that you can also set the default timeout value on a deferred result, response body emitter and SSC emitter. For callable, you can use web async task to provide the timeout value. Here you can see the the default void configure async support configure asynchronous request handling options. This is in the interface web MVC configurer and in the package org.springframework.web.servlet.config.annotation. Now we are focused in this example 12. We are considering global configuration in CORS. To enable CORS in the MVC Java config, you can use CORS registry callback, as the following example shows. The class CORS registry assists with the registration of global URL patterns based course configuration mappings. This is in the package org.springframework.web.servlet.config.annotation. To enable course in XML namespace, you can use MUC:course element as the following example shows. And add more mappings. As an example 13, we are considering free marker in Vue technologies. The following example shows how to configure free mark as a Vue technology. The class free marker configurer Java bean to configure free marker for a web usage via config location and or free marker settings and or template loader path properties. The simplest way to use this class is to specify just a template loader path. You do not need any further configuration then. This is in the package org.springframework.web.servlet.vue.freemarker. Following example shows how to configure the same in XML. Configure free marker. Configure free marker. Here you can see we are considering simple binding. In your HTML forms based on free marker templates, that acts as a form view for a specific for a Spring MVC controller, you can use code similar to this example to bind field values and display error messages for each input field, similar fashion to the JSP equivalent. The following example shows a person form view. At spring.bind requires a path argument which consists of the name of your command object. It is command unless you change it to your controller configuration, followed by the period, and the name of the field on the command object to which you wish to bind. You can also use nested fields such as command.address.street. The bind macro assumes the default HTML escaping behavior specified by the servlet context parameter default HTML escape in web.xml. An alternative form of macro called spring.bind escapes takes a second argument that explicitly specifies whether HTML escaping should be used in the status error messages or values. You can set it to true or false as required. Additional form handling macros simplify the use of HTML escaping, and you should use these macros wherever possible. They are explained wherever possible. FreeMaker macros have to be imported into namespace. We strongly recommend sticking to Spring. In Java configuration, you can use the enable web MVC annotation to enable MVC configuration, as the following example shows. The annotation enable web MVC. Adding this annotation to @configuration class imports the Spring MVC configuration from web web MVC configuration support. This is in the package org.springframework.web.servlet.config. In XML, you can check attributes and some elements of MVC annotation -driven. You can view XML Spring MVC schema or use code completion feature in your IDE to discover what attributes and sub-elements are available. Now we are moving to type conversion. The default formatters and various number and date types are installed along with support for customization via @number format and @date format on fields. To register custom formatters and converters in Java config, use following. To do the same in XML config, use following. By default, Spring MVC considers the request local when passing formatting and date values. In example 15, we are considering default servlet. The following example shows how to enable the feature by using default setup. The class default servlet handler configurer configures a request handler for serving static resources by following the request to the servlet container default servlet. It is indeed to be used. It is intended to be used when the servlet, when the Spring MVC dispatcher servlet is mapped to /, thus overriding the servlet container's default handling of static resources. This is in the package org.springframework.web.servlet.config.annotation. Spring MVC allows for mapping the dispatcher servlets to /, thus overriding the mapping of the container's default servlet, while still allowing static resource requests to be handled by the container's default servlet. It configures a default servlet HTTP request handler with the URL mapping of / **** and the lowest priority relative to the other URL mappings. This handler forwards all requests to the default servlet. Therefore, it must remain the last in order of the other URL handling handler mappings. That is the case if you use MEC : annotation -driven. Alternatively, if you set up your own customized handler mapping instance, be sure to set its order property to a value lower than that of default servlet HTTP request handler, which is integer.max value. Following example shows how to enable the feature by using default setup. The following example shows how to achieve the same configuration in XML. The caveat to override / servlet mapping is that the request dispatcher for the default servlet must be retrieved by the name rather than the path. The default servlet HTTP request handler tries to auto-detect the default servlet for the container at startup using the list of known names for the most of the major servlet containers, including Tomcat, Jetty, Glassfish, JBoss, Racing, WebLogic, and WebSphere. If the default servlet has been custom configured with a different name, or if the different servlet container is being used where the default servlet name is unknown, then you must explicitly provide the default servlet name. As an exception example, we are considering class simple mapping exception resolver. Handle exception resolver implementation that allows for mapping exception class names to views names either for a set of given handlers or for all handlers in the dispatcher servlet. This in the package org.springframework.web.servlet.handler. As an example, exception example 2, we are considering container error page, and this is then processed by the dispatcher servlet, possibly mapping it to a controller, which could be implemented in return to error view name with model, or to render JSON response, as the following example shows. If an exception remains unresolved by the handler exception resolver and is therefore left to propagate, or if the response status is set to an error status, that is 4xx or 5xx, servlet containers can render a default error page in HTML. This customized default error page of the container, you can declare an error page mapping in web.xml. The following example shows how to do so. Given the preceding example, when an exception bubbles up or response has an error status, the servlet container makes an error dispatch within the container to configure URL, for example /error. This is then processed by the dispatcher servlet, possibly mapping it to a controller, which could be implemented to return an error view name, or with a model, or to render JSON response, as the following example shows. The Servlet API does not provide a way to create error page mappings in Java. You can, however, use both a web application initializer and the minimal web.xml. As an error example, we can consider this error occurred in the environment with the Spring MEC and Tomcat. Here we can see Apache doc.apache catalina.co.standard context load on startup, CVS servlet, Crunchify, and in the web application Crunchify Spring MEC tutorial through load exception, java.land.class not found exception, org.springframework.web.servlet.dispatcher servlet at and etc. Now we are focusing on web. The Spring Web module provides basic web-oriented integration features such as multi-part file upload functionality and the initialization of the IOC containers using servlet listeners and a web-oriented application context. It also contains an HTTP client and web-related parts of Spring's remoting support. As an example, we can consider this Maven segment. Here you can see artifact Spring-Web. Spring Web provides integration features such as multi-part file upload functionality and the initialization of IOC container using servlet listeners and a web-oriented application context. It also contains an HTTP client and web-related parts of Spring remote support. As an example too, we can consider package org.springframework.http contains a basic abstraction over client-server side HTTP. This package contains the HTTP input message and HTTP output message interfaces. As an example 3, we can consider package org.springframework.remoting exception hierarchy for Spring's remoting infrastructure, independent of any specific remote method invocation system. As an example 4, we can consider package org.springframework.web, common generic interfaces that define minimal boundary points between Spring's web infrastructure and other framework modules. As an example 5, you can see a segment of web.xml here. Here you can see the class context loader listener. Bootstrap listener to start up and shut down the Spring's root web application context simply delegates to context loader as well as to context cleanup listener. This is in the package org.springframework.web.context. As an example 6, we are considering interface multi-part resolver, a strategy interface for multi-part file upload resolution in accordance with RFC 1867. Implementations are typically usable both within an application context and standalone. This is in the package org.springframework.web.multipart. Multipart resolver from the org.springframework.web.multipart package is a strategy and for passing multipart requests including file uploads. There is one implementation based on common file upload and another based on Servlet 3.0 multipart request passing. To enable multipart handling, you need to declare multipart resolver being in your dispatcher servlet Spring configuration with the name of multipart resolver. The dispatcher servlet detects it and applies it to the incoming request. When a post with the content type of multipart /form-data is received, the resolver passes the content, wraps the current HTTP servlet request as a multipart HTTP servlet request to provide access to resolved file in addition to exposing parts as request parameters. As an example 7, we are considering form data now. The Spring Web module provides form content filter to intercept HTTP put, patch and delete request with the content type of application /x -www form URL encoded. Read the form data from the body of the request and wrap the servlet request to make the form data available through the servlet request.get parameter method family of methods. Class form data content filter that passes form data for HTTP put, patch and delete request and exposes it as a servlet request parameters. By default, the servlet spec only requires this for HTTP post. This is in the package org.springframework.web.filter. Browsers can submit form data through HTTP GET or HTTP POST, but non-browser client can also use HTTP PUT, patch, and delete. A Servlet API requires servlet request.get parameter strict methods to support form field access only for HTTP POST. As an example 8, we are considering annotated controllers in request mapping in annotated controllers. Following example has a type and method level mappings. Annotated type request mapping. Annotation for mapping web request into methods in request handling classes with flexible method signatures. org.springframework.web.bind.annotation package contains this annotation type. You can use request mapping annotation to map request to controller methods. It has various attributes to match by URL, HTTP method, request parameters, headers, and media types. You can use it at class level to express shared mappings, or at the method level to narrow down the specific endpoint mapping. There are also HTTP method specific shortcut variants of at request mapping, at get mapping, at post mapping, at put mapping, at delete mapping, at patch mapping. The shortcuts are custom annotations that are provided because arguably most controller methods should be mapped to a specific HTTP method versus using request mapping, which by default matches to all HTTP methods. At request mapping is still needed at the class level to express shared mapping. Following example has type and method level mappings. As an example 9, we are considering basically model in annotated controllers. Here you can see the following example shows at model attribute method. Annotation type model attribute. Annotation that binds a method parameter or a method return value to a named model attribute exposed to a web view, supported for controller class with at request mapping methods. This is in the package org.springframework.web.bind.annotation. You can use model attribute annotation, a method argument in request mapping methods, to create or access an object from the model and to bind it to a request through web data binder. A method level annotation at controller or at controller advice classes that help to initialize the method prior to at request mapping. A method invocation on a at request mapping method to mark its return value is a model attribute. This here we discussed at model attribute methods. A controller can have any number of at model attribute methods All such methods are invoked before @request mapping methods in the same controller. @model attribute method can also be shared across controllers through @controller advice. @model attribute methods have flexible method signatures. They support many of the same argument as @request mapping methods, except for @model attribute itself or anything related to the request body. The following example shows @model attribute method. And add more. As an example 10, we are focusing on URI components in URI links. Here the URI components builder helps to build URIs from the URI templates with variables, as following example shows. Here the class URI components represent an immutable collection of URI components, mapping component type to string values, contains convenience getters for all components, effectively similar to URI but with more powerful encoding options and support for URI template variables. This is in the package org.springframework.web.util. Here you can see the static factory method with URI template. Here add or replace URI components. Request to have URI template and URI variables encoded. Here build a URI component. Here expand and obtain URI. As an example 11, we are considering a deferred result in asynchronous requests. Once asynchronous request processing feature is enabled in the servlet container, controller methods can wrap any supported return value with deferred result, as following example shows. The class deferred result T. Deferred result provide an alternative to using a callable asynchronous request processing. While a callable is executed concurrently on behalf of the application, with the deferred result, application can produce a result from the thread of its choice. This is in the class org.springframework.web.context.request.async. Controller can produce a return value asynchronously from a different thread. For example, a response from an external event, JMS message, a scheduled task, or other event. Save deferred result somewhere from some other thread. As an example 12, we are considering at cross origin in course. At cross origin, the at cross origin annotation enables cross origin request on annotated controller methods, as following example shows. Annotation type cross-origin. Annotation for permitting cross-origin request on a specific handler class or or handler method. Methods possessed if an appropriate handler mapping is configured. This is in the package org.springframework.web.bind.annotation. By default, at cross-origin allows all origins, all headers, all HTTP method to which the controller method is mapped. Now in example 14 we are focusing on cache control in HTTP caching. While RFC 7234 describes all possible directives for the cache control response header, the cache control type takes a use case oriented approach that focuses on the common scenarios. The class cache control, a builder for creating cache control HTTP response headers. This is in the package org.springframework.http. Cache control provides support for configuring settings related to cache control, to the cache control header, and is accepted as an argument in number of places: web content interceptor, web content generator, controllers, static resources. While RFC 7234 describes all possible directives for the cache control response header, the cache control type takes a use case oriented approach that focuses on common scenarios. Web content generator also accept cache period property defined in second that work as follows. A -1 value does not generate cache control response header. A 0 value prevent caching by using the cache control :no store directive, and n greater than 0 value caches the given response for n second by using the cache control :max-h equal n directive. Cache for an hour, cache control max-h equal 3600. Prevent caching, cache control :no store. Cache for 10 days in public and private caches. Public caches should not transform the response. Cache control :max-h 864000 and public and no transform. Now we focus in example 15. We are considering controllers. A controller can add e-tag header and cache control settings to a response entity, as following example shows. The class response entity T extension of HTTP entity that adds an HTTP status code HTTP status code used in REST template as well as in at controller methods. This is in the package org.springframework.http. Controllers can add explicit support for HTTP caching. We recommend doing so since the last modified e-tag value for a resource needs to be calculated before it can be compared against conditional request headers. A controller can add an e-tag header and cache control settings to a response entity. As following example shows. In this example sends a 304 not underscore modified response with an empty body if the comparison to the conditional request headers indicates that content has not changed. Otherwise, e-tag and cache control headers are added to the response. Here B e-tag string e-tag set an entity tag of the body as specified by the e-tag header. E-tag is the new entity tag, the parameter. Last modified is also available. In example 16, we are considering message converters. The following example adds XML and Jackson converters with customized object mapper instead of default ones. Class mapping Jackson to HTTP message converter. Implementation of HTTP message converter that can read and write JSON using Jackson 2.xs object mapper. This is in the package org.springframework.http.converter.json, and class mapping Jackson to XML HTTP message converter. Implementation of HTTP message converter that can read and write XML using Jackson 2.x extension component for reading and writing XML encoded data. This is in the package org.springframework.http.converter.xml. You can customize HTTP message converter in Java configuration by overriding configure message converters method to replace the default converters created by Spring MVC, or by overriding extend message converters method to customize the default converters or add additional converters to the default ones. Following example adds XML and Jackson JSON converters with a customized object mapper instead of default ones. In this example, Jackson to object mapper builder is used to create common configuration for both mapping Jackson to HTTP message converter and mapping Jackson to XML HTTP message converter with indentation enabled, a customized date format, and registration of Jackson module parameter names, which adds support for accessing parameter names, a feature added in Java 8. This builder customizes Jackson's default properties as follows. Deserialization feature dot fail on unknown properties is disabled. Mapper feature dot default view inclusion is disabled. It also automatically registers the following well-known modules if they are detected on the class path. Jackson data type Joda, support for Joda types. Jackson data type JSR 310, support for Java 8 date and time API types. Jackson data type JDK 8, support for other Java 8 types such as optional. Jackson module Kotlin, support for Kotlin classes and data classes. Enabling indentation in indentation with Jackson XML supports required Woodstock core ASL dependency in addition to Jackson date format XML1. Other interesting Jackson modules are available. Jackson data type money, support for javax.money types, unofficial module. Jackson data type hibernate, support for hibernate specific type and properties including lazy loading aspects. Following example shows how to achieve the same configuration in XML. In example 17, we are considering initialization in REST templates in REST endpoints. For example, to switch to Apache HTTP components, you can use following. The class REST template synchronous client to perform HTTP requests, exposing a simple template method API over underlying HTTP client libraries such as the JDK, HTTP URL connection, Apache HTTP components, and others. This is in the package org.springframework.web.client. The default constructor uses java.net.http URL connection to perform request. You can switch to a different HTTP library with the implementation of client HTTP request factory. There is a built-in support for following: Apache HTTP components, Netty, and OKHTTP. For example, to switch to Apache HTTP components, you can use the following here. Each HTTP request factory, HTTP client request factory, exposes configuration options specific to the underlying HTTP client library. For example, for credentials, connection, pooling, and other details. Note that the java.net implementation for HTTP requests can raise an exception when accessing the status of a response that represent an error such as 401. If this is an issue, switch to another HTTP client library. In example 18, we are considering multipart in REST template in REST endpoint. Once multipart value, once a multi-value map is ready, you can pass it to REST template as shown below. To send the multipart data, you need to provide multi-value map string object whose values may be an object, object for part content, resource for a file part, or an HTTP entity, for part content with headers. In most cases, you do not have to specify the content type for each part. The content type is determined automatically based on the HTTP message converter chosen to serialize it or in the case of resource based file extension. If necessary, you can explicitly provide the media type with an HTTP entity wrapper. Once the multi-value map is ready, you can pass it to the REST template as shown here. If the multi-value map contains at least one non-string value, the content type is set to multipart/form-data by the form HTTP message converter. If the multipart map has a string values, the content type is defaulted to basically if the multi-value map contain at least one non-string value, The content type is set to multipart form data by form HTTP message converter. If the multipart multi-value map has string values, the content type is defaulted to application /x www form URL encoded. If necessary, the content type may also be set explicitly. Now we are considering using async REST template in REST endpoints. Deprecated this class async REST template deprecated. Spring central class for asynchronous client-side HTTP access exposes similar methods as REST template, but returns listenable feature wrappers as opposed to concrete results. This in the package org.springframework.web.client. The async REST template is deprecated for all use cases where you might consider using async REST template. Use web client instead. In example 20, we are considering common configuration. In other web frameworks, consider the following listener configuration. The class context load listener, the bootstrap listener to start up and shut down the Spring's boot web application context, simply delegates to context loader as well as context cleanup listener. This is in the package org.springframework.web.context. Before diving into integration specifics of each supported web framework, let us first take a look at common Spring configuration that is not specific to any one web framework. This one of the concept for want of a better word espoused by Spring's lightweight application model is that of a layered architecture. Remember that a classic layered architecture, the web layer is but one of many layers. It serves as one of the entry points into a server-side application, and it delegates a service to service object facade that are defined in a service layer to satisfy business specific and presentation technology agnostic use cases. In Spring, these service objects, any other business specific objects or data access objects and other exist in a distinct business context, which contains no web or presentation layer objects. Presentation objects such as Spring MVC controllers are typically configured in a distinct presentation context. Moving on to the specifics, all you need to do is declare context loader listener. In the standard Java EE Servlet web.xml file of your web application and add context configuration. Context param section in the same file, and that defines which set of Spring XML configuration to load. Consider the following listener configuration. Further consider the following context param. If you do not specify context configuration, context parameter, the context loader listener looks for the file called /web inf /application context.xml to load. Once the context files are loaded, Spring creates a web application context object based on the bean definitions and stores it in a servlet context of the web application. All Java web frameworks are built on top of a Servlet API, so you can use the following WebSocket Servlet API. See, this is a context config location. The following example shows how to get a web application context. The class web application context utils convenience method for retrieving the root web application context for a given servlet context. This is useful for programmatically accessing the Spring application context from within the custom web views or MVC actions. This is in the package org.springframework.web.context.support. All Java web frameworks are built on top of the Servlet API, so you can use the following this code snippet to get access to the business context, application context created by context loader listener. The following example shows how to get the web application context. The web application utils class is for convenience, so you need not to remember name of the servlet context attribute. It's get web application context. Method returns null if an object does not exist under web application context root web application context attribute key. Rather than risk getting null pointer exceptions in your application, it is better to use get required web application context method. This method throws an exception when application context is missing. Once you have reference to the web application context, you can retrieve beans by their name or type. Most developers retrieve beans by name and then cast them to one of their implemented interfaces. As an example 22, we are considering a Spring Bean resolver in JSF. Configuration wise, you can define a Spring Bean faces EL resolver in your JSF faces context.xml file, as the following example shows. Class Spring Bean faces EL resolver, JSF EL resolver that delegates to the Spring root web application context, resolving name references to Spring defined beans. This is in the package org.springframework.web.jsf.el. Spring Bean faces EL resolver is a JSF compliant EL resolver implementation integrating with the standard unified EL as used by JSF and JSP. It delegates to Spring's business context web application context first and then to the default resolver of the underlying JSF implementation. As an example 23, we are considering using faces context utils in JSF. Following example shows how to use faces context utils. The class faces context utils convenience method to retrieve Spring's root web application context for a given JSF faces context. This is useful for accessing the Spring application context from custom JSF based code. A custom EL resolver works well when mapping your properties to beans in faces config.xml, but at times you may need to explicitly grab an bean. The faces context utils class make this easy. It is similar to web application context utils, except that it makes faces context parameter rather than servlet context parameter. The following example shows how to use faces context utils. And the faces context utils is in the package org.springframework.web.jsf. As an example 24, we are considering accessing web services by using JAX-WS. Class JAX-WS port proxy factory bean. Factory bean for a specific part of a JAX-WS service exposes a proxy for a port to be used for bean references, inherits configuration properties for JAX-WS port client inspector. This in the package org.springframework.remoting.jax-ws. Spring provides two factory beans to create JAX-WS web service proxies, namely local JAX-WS service factory bean and JAX-WS port proxy factory bean. Former can return only a JAX-WS service class for us to work with. The latter is a fully fledged version that can return a proxy that implements our business service interface. In the following example, we use JAX-WS proxy factory bean to create proxy for the account service endpoint. This is where service interface is our business interface that client use. WSDL document URL is the URL for the WSDL file. Spring needs this startup time to Spring need this at startup time to create the JAX-WS service. Namespace URI corresponds to the target namespace. In the .wsdl file, service name correspond to the service name in the .wsdl file. Port name correspond to the port name in the .wsdl file. Accessing the web service is easy, and as we have a bean factory for it that exposes it as an interface called account service. Following example shows how we can wire this up in string. In example 25, we are considering exporting the service by using RMI service exporter. In RMI is deprecated. We have to expose our service by using RMI service exporter. The following example shows how to do so. the class RMI service exporter. RMI exporter that exposes the specified service as RMI object with the specified name. Such services can be accessed via plain RMI or via RMI proxy factory bean. Also supports exposing any non-RMI service via RMI invokers to be accessed via RMI client interceptor, RMI proxy factory bean, automatic detection of such invokers. This is in the package org.springframework.remoting.rmi. Using RMI service exporter, we can expose the interface of our accounting service object as RMI object. The interface can be accessed by using RMI proxy factory bean or via plain RMI in case of traditional RMI service. The RMI service exporter explicitly supports the exposing of any non-RMI services via RMI invokers. We first have to set our service in Spring container. The following example shows how to do so. Next, we have to expose our service by using RMI service exporter. The following example shows how to do so. In this example, we override the port for our RMI registry. Often your application server also maintain an RMI registry, and it is wise not to interfere with that one. Furthermore, the service name is used to bind the service. So in this example, the service is bound at RMI://host:1199/accounting service. Here you can see again, I can say again, it's RMI://host:1199/accounting service. We use this URL later to link in the service at the client side. The server port property has been omitted. It default to 0. This means that an anonymous port is used to communicate with the service. Does not necessarily have to be the same name as the bean to be exported. Default to 1099. Any additional properties may be a DAO. Here we are considering linking the service at the client to link the service on the link in the service at the client in RMI deprecated. To link the service on the client, we create separate Spring container. To contain the following simple object and the service linking configuration bits. In the class RMI proxy factory bean, the factory bean for RMI proxies supporting both conventional RMI services and RMI invokers exposes the proxied service for use as a bean reference using the specified service interface. Proxies will throw Spring unchecked remote access exception in the remote invocation failure instead of RMI remote exception. This is in the package org.springframework.remote.rmi. Our client is simple object, uses that account service to manage account as the following example shows. To link the service on the client, to create separate Spring container to contain the following simple object and service linking configuration bits. This is all we need to support the remote account service on the client. Spring transparently create an invoker and remotely enable the account service through RMI service exporter. At the client, we link it in by using the RMI proxy factory bean. Additional methods using account interface. As an example 26, we are considering exposing your beans by using Hessian service exporter in using Hessian to remotely call services through HTTP is deprecated. In newly created application context called remoting-servlet.xml, we create Hessian service exporter to export our services as the following example here shows. The class Hessian service exporter servlet API based HTTP request handler that export the specified service bean as the service endpoint accessible via a Hessian proxy. This is in the package org.springframework.remoting.coucho. Now we are ready to link the service at the client. No explicit handler mapping is specified to map the request URL into service, so we use being name URL handler mapping used. Hence the service is exported at the URL indicated through its bean name within the containing dispatch servlet instance mapping as defined. The http:///host//8080/remoting/account service. Any additional properties, maybe a DAO. Now we are considering linking in the service on the client. We create separate bean factory or application context and mention the following beans where the simple object is by using the account service to manage accounts as the following example shows. The class Hessian proxy factory bean. The factory bean for Hessian proxies exposes the proxied service for use as a bean reference using the specified service interface. This is in the package org.springframework.remoting.coucho. By using Hessian proxy factory bean, we link the service at the client. The same principles apply as with the RMI example. We create a separate bean factory or application context and mention the following beans via the simple object. Is by using account service. To manage accounts, as the following example shows. As an example 27, we are considering exporting a service object in Spring HTTP invoker deprecated. To expose this account service mentioned earlier within Spring Web MVC dispatcher servlet, the following configuration need to be placed. In the dispatcher application context, as the following example shows. Class HTTP invoker service exporter, the servlet API based HTTP request handler that exports the specified service bean as HTTP invoker service endpoint accessible via an HTTP invoker proxy. This is in the class org.springframework.remoting.http invoker. Setting up HTTP invoker infrastructure for a service object closely resemble the way you would do the same by Hessian. As Hessian supports provides Hessian service exporter, the Spring's HTTP invoker support provides org.springframework.remoting.http invoker.http service exporter. The class HTTP invoker service exporter, here the service API based HTTP request handler. To export the account service with the Spring Web MVC dispatch servlet, the following configuration need to be placed in the dispatcher's application context, as the following example shows. Such an exporter definition is exposed through the dispatch servlet instance standard mapping facilities. Now we are here linking in the service at the client. The class HTTP invoker proxy factory bean for HTTP invoker proxies exposes the proxied service for use as a bean reference using the specified service interface. This is in the package org.springframework.remoting.http invoker. Again, linking in the service from the client much resemble the way you would do it in use Hessian. By using a proxy, Spring can translate your calls to HTTP post request to the URL that point to the exposed service. Following example shows how to configure this arrangement. As mentioned earlier, you can choose what HTTP client you want to use. By default, the HTTP invoker proxy uses JDK's HTTP functionality, but you can also use Apache HTTP components client by setting the HTTP invoker request executor property. As an exception example, we can consider this and exceptions at controller and at controller advice classes can have exception. At controller and at controller advice classes can have at exception handler methods to handle exception from controller methods, as following example shows. The annotation type exception handler, annotation for handling exception in specified handler classes, so handler methods. This is in the package org.springframework.web.bind.annotation. The exception may match against the top level exception being propagated, for example direct IO exception. or against a nested course with wrapper exception, for example, an IO exception wrap inside illegal state exception. As of 5.3, this can match at library course levels, whereas previously only an immediate course was considered. For matching exception type, preferably declare the target exception as the method argument. And when multiple exceptions, as shown here, and when multiple exception methods match, the root exception match is generally preferred to cause exception match. More specifically, the exception depth comparator is used to sort exception based on their depth from thrown exception type. As an exception example 2, we can consider HTTP media type exception. The class HTTP media type exception abstracts base for exceptions related to media types. Add a list of supported media types. This is in the package org.springframework.web. Now we are focusing on Portlet. The web Portlet module provides the MVC implementation to be used in the Portlet environment and mirrors the functionality of web Servlet module. Here you can see a Spring Portlet MVC. A Portlet is nothing but a servlet-like component designed to handle requests and give back responses. Spring 3 supports Portlet version 2.0 covered under the JSR 286 specification. The central component in Portlet is the dispatcher Portlet, which is the primary component that caters to all requests coming in and then selects an appropriate handler to handle them. The basic block diagram of dispatcher Portlet and its role in MVC architecture catering to request and generating responses is shown here. Here you can see a request are passed to dispatcher servlet and responses are coming from dispatcher Portlet here. Dispatcher Portlet interact with handler mapping. Requests are passed from dispatcher Portlet to handler mapping, and controller is passed from handler mapping to dispatcher Portlet. Dispatcher Portlet interacts with controller. Render and action request is passed from render, and render action request is passed from dispatcher Portlet to controller. Model and view void are passed from controller to dispatcher Portlet. Dispatcher Portlet interact with view resolver. View name is passed from dispatcher Portlet to view resolver, and view is passed from view resolver to dispatcher Portlet. Dispatcher Portlet interact with view. Model is passed from dispatcher Portlet to view, and response is passed from view to dispatcher Portlet. Here you can see request processing in Spring Portlet MVC. The dispatcher Portlet acts as an front controller for each portlet and find the handler map to the request using handler mapping. The result of executing handler, model view model and view is used to resolve actual view to be rendered. and the request is dispatched to view renderer servlet for rendering. Here we are considering how Spring Portlet MVC works. The dispatcher Portlet acts as the Portlet class for Spring Portlet MVC portlets. So what does dispatcher portlets do? If you have prior experience working with the Struts framework, you can closely relate the dispatcher portlet here to the request processor class in the Struts framework. The dispatcher portlet is at the heart of the Spring Portlet MVC framework, and like the request processor of Struts framework, it is responsible for coordinating all the request handling activities on receipt of a portlet request. It works with the other Spring Portlet MVC classes and interfaces. When a portlet request is received by the dispatcher portlet, which is the portlet class, it first attempts to find the appropriate handler for the request. And Spring Portlet MVC handler mapping type bean help with this. Depending upon how you want to select handler based on the portlet request, you will select an appropriate built-in handler mapping bean implementation. For example, here the hello world portlet uses the portlet handler mapping bean, portlet mod handler mapping bean, which implements handler mapping and which select appropriate handler based on the current portlet mod. Here this is an example class. In the hello world portlet here, as an example, the portlet mod handler mapping maps the view portlet mod to the hello world controller. So the hello world controller is the handler for the renderer request received by dispatcher portlet. Once the handler is selected for the request processing, the dispatcher portlet invokes the appropriate handler method to do the actual request processing. The handler's handle renderer request method is responsible for handling the renderer requests. And the handle action request method handle the action request. The request received at the request received at here is the renderer request. So the request is handled by the hello world controllers handle renderer request method. That method returns the model view object as an example here. The dispatcher portlet uses the view information in the model view object to obtain a reference to actual view, which is in case of a hello world portlet is a JSP page, for example. The Spring Portlet's MVC built-in view resolver type bean with resolving a view, it finds the actual view corresponding to the logical view name. For example, hello world portlet makes use of internal resource view resolver bean, which implement a view resolver to resolve a view name in the actual JSP page, for example. We are not showing that program here, but we can visualize the example. once the actual view is resolved, the dispatcher Portlet dispatches the request to the built-in view renderer servlet and send the reference to the actual view along with the model data for rendering the view. The Spring Portlet MVC provide many built-in view resolvers that you can use depending on the view technology you are using. The built-in view resolvers include XML view resolver, velocity view resolver, free marker view resolver, and resource bundle view resolver. Similarly, and you can also create view resolver chain to resolve views. Note the dispatcher Portlet auto detects view resolvers based on the type of being defined in the Portlet's web application context or in the root web application context and applies them during view resolution. For example, if a bean that's defined in the Portlet web application context implements the view resolver interface, the dispatcher Portlets makes the use of that bean for resolving views for the Portlet. Here step 1, render request, and here you can see dispatcher Portlet. It invokes handler resolving view and dispatching request to view renderer servlet for rendering view. Here step 2, get handler provides mapping between request and handler. The Portlet mode handler mapping implementation of handler mapping interface provides mapping between the current Portlet mode, view, edit, and help, and the corresponding request handler. This mapping returns the hello world controller handler to the dispatcher Portlet. And step 3, invoke handler. Here as an example, hello world controller handles the renderer request and returns the model and view object to the dispatcher Portlet. Here step 4, resolve view name. The view resolver here resolves the actual view based on the view name, hello world in our example, passed by the dispatcher Portlet. Step 5, render view. Here you can see the view render servlet renders the actual view based on the view and model information passed by the Portlet. Here you can see request is connected to render request is connected to dispatcher Portlet, and dispatcher Portlet is connected to handler mapping. Get handle is passed on dispatcher Portlet to handler mapping, and dispatcher Portlet is connected to hello world controller. Here as an example, invoke handle is passed from dispatcher Portlet to hello world controller as an example. Dispatcher Portlet is connected to view resolver. Resolve view name is passed from dispatcher Portlet to view resolver. Dispatcher Portlet is connected to view renderer servlet. Render view is passed from dispatcher Portlet to view renderer servlet. Here you can see the role played by handler mapping in fulfilling the Portlet request. Dispatcher Portlet obtains a handler execution chain from the handler mapping bean and invokes the handler execution chain's handler and interceptor if any. Handler mapping beans in Spring MVC framework are used to map Portlet request to the handler. The mapping can be based on the Portlet mod, the value of the request parameter, the combination or a combination of both or any other custom approach. A handler mapping bean must implement the handler mapping interface either directly or indirectly. A handler mapping maps a portlet request to exactly one handler. You can't have a portlet request mapped to more than one handler. If you want an additional functionality to handler, you can either modify the handler or use handler interceptors. As shown in this figure, the dispatcher portlet requests that the handler mapping bean return an appropriate handler for the incoming portlet request. The handler mapping bean analyzes the portlet request and returns then object type of handler execution chain, which contains a single handler that matches the portlet request, and handler interceptors which are executed before or after the execution of the handler or both. In this figure, the dispatcher portlet invokes the handler and the handler interceptors of the handler execution chain returned by the handler mapping. Here you can see portlet request is passed to the dispatcher portlet. Dispatcher portlet interacts with handler mapping. Get handler is passed from dispatcher portlet to handler mapping, and it returns handler execution chain for the portlet request. The dispatcher portlet is connected to handler execution chain. Invoke is passed from dispatcher portlet to handler execution chain. Handler execution chain consists of handler and handler interceptors. Here you can see handler interceptors are invoked before and after the execution of the handler. The pre-render handler method is invoked before the handler execution, and the post-render handler method is invoked after the handler execution. The after render completion method is invoked after the post render handler method of all the interceptors are executed. This figure shows the role played by handler interceptors in processing a render request. The sequence diagram in this figure here shows the order in which the handler interceptors methods are executed by dispatcher portlet during the portlet request processing. The interceptors pre-handle method is invoked before the execution of the handler. Post handle is invoked after the execution of the handler. After completion is executed, after completion is invoked at the end to do any cleanup if required. Spring Portlet MVC provides built-in handler interceptor implementation, parameter mapping interceptor, which is useful when using parameter handler mapping and Portlet mod parameter handler mapping implementation, parameter mapping interceptor ensures that the value of the request parameter used for finding appropriate handler in the parameter handler mapping and Portlet mod parameter handler mapping is forwarded from the action request to the following render request. This can help in ensuring that the render in action and action methods are the same handler are invoked. Here you can see dispatcher portlet, handler mapping, execution chain, handler execution chain, handler execution chain, interceptor, handler interceptor, handler handler. Here you can see get handler execution chain from dispatcher portlet to handler mapping, and execution chain is passed from handler mapping to dispatcher portlet. Then get handler interceptors is passed from dispatcher portlet to execution chain, handler execution chain. Then interceptors are passed from execution chain, handler execution chain to dispatcher portlet. Here you can see the loop for each interceptor. Pre-handler is passed from dispatcher portlet to interceptor, handler interceptor. Get handler is passed from dispatcher portlet to execution chain, handler execution chain, and handler is passed from execution chain, handler execution chain to dispatcher portlet. Handler render request is passed from dispatcher portlet to handler. Loop for each interceptor you can see here. Post handler render is passed from dispatcher portlet to interceptor, handler interceptor. Loop for each interceptor here again. In it after render completion is passed from dispatcher portlet to execution chain, handler execution chain. You can see a dispatcher portlet uses handler exception resolver to resolve exceptions that occur during the execution of the handler. Handler exception resolver returns a model view object that is then forwarded to the dispatcher by dispatcher portlet to view render servlet to render the view. In Spring Portlet MVC, the dispatcher portlet catches exceptions thrown during request handling and uses registered handler exception resolvers to find an error view corresponding to the exception thrown. A handler exception resolver is a special bean that implements the handler exception resolver interface and is configured in the web application context XML like any other Spring bean. Handler exception resolver define resolver exception methods that return model and view object, and the return model and view object contain an error view and model information. Dispatcher portlet then uses view resolver to resolve the error view information and dispatches a request to view renderer servlet to render the error view. Let's look at how this request is handled here. Handle when an exception is thrown during request processing. This is showing how handler exception resolver is used in the Spring Portlet MVC framework. Dispatcher Portlet obtains handler execution chain from handler mapping. The dispatcher portlet invokes the handler execution chain, which result in an exception being thrown. Dispatcher portlet then uses handler exception resolver to resolve the exception thrown by handler execution chain. The handler exception resolver returns a model and view object, which contains information about the view to be rendered for the thrown exception along with the corresponding model data. View resolver is used to resolve the view to be rendered. Dispatcher servlet dispatches the request to the view renderer servlet and send the model data as request attributes for rendering the view. View handler exception resolvers are detected by type. Dispatcher's portlet auto detects handler exception resolvers based on the type of the bean defined in the application context of the portlet or in the root web application context and applies them when an exception occurs. You can create your own exception resolver either by directly implementing the handler exception resolver interface or by extending the abstract handler exception resolver subclass, which allow you to control the handlers to which the handler exception resolver applies and to create handler exception resolver chain. Spring provides a concrete implementation of abstract handler exception resolver, the simple mapping exception resolver that allows you to map exception class names to view names. Here you can see a portlet request is passed to dispatcher portlet and get handler is passed to pass from dispatcher portlet to handler mapping. Handler mapping returns handler execution chain for the portlet request to dispatcher portlet. Dispatcher portlet interacts with handler execution chain, consists of handler and handler interceptors. Invoke is passed from dispatcher portlet to handler execution chain. Execution of handler chain result in exception. Exception is passed from handler execution chain to dispatcher portlet. Dispatcher portlet is connected to view resolver. View is passed from dispatcher portlet to view resolver. Dispatcher portlet is before that dispatcher portlet is connected to handler exception resolver. Resolve exception is passed from dispatcher portlet to handler exception resolver. Model and view is passed from handler exception resolver to dispatcher portlet. Dispatcher portlet is connected to view resolver. View is passed from dispatcher portlet to view resolver. Dispatcher portlet is connected to view renderer servlet. Render view is passed from dispatcher portlet to view renderer servlet. This diagram describes the lifecycle methods of servlets and portlets. Following methods represent the portlet phases. These methods are known as lifecycle of portlet. Init. This method will be called when portlet is deployed and instantiated by portlet container. Render. This method will be called to render the content represent render page. Process action. This method will be called when any action performed. Process event. This method will be called when any event is triggered. Server resource. This method will be called when any resource is served with resource URL. And destroy. This method will be called when portlet is undeployed by portlet container. These lifecycle methods, portlet phases, are managed by Portlet container. Portlet container is responsible for following tasks: loading class Portlet, creating and maintaining Portlet instance, initializing Portlet, submitting user request to Portlet instance, destroying Portlet instance when it is undeployed. If you are familiar with Servlet, you can easily understand Portlet by correlate lifecycle methods of Portlet and Servlet. There is no direct correlation between lifecycle method of Portlet and Servlet. This diagram is just to understand lifecycle methods side by side. For both Portlet and Servlet, init and destroy methods are called by respective container, Portlet and Servlet container. In case of Servlet, all requests are served by service method. In case of Portlet, user requests are served by different methods like render, process action, process event, and serve resource based on the Portlet's current pace. Here you can see the Servlet and user request is connected to the Servlet. Here you can see init, service and destroy method. Here you can see Portlet, user request is connected to the Portlet. You can see here init, and here you can see render, process action, process event, serve resource methods, and here you can see destroy method. Now we are, as an example, we can consider this Maven segment. You can see a artifact ID Spring -web MVC Portlet, Spring Web Portlet. It provides the MVC implementation to be used in a Portlet environment and mirrors the functionality of the Servlet based Spring Web MVC. As an example too, we can consider package org.spring framework.web.portlet provide JSR 286 portlets that integrate with the application context infrastructure and the core interfaces and classes for Portlet variant of Spring's Web MVC framework. As an example 3, we can consider interface controller. Base Portlet controller interface representing a component that receives render request, render response, and action request, action response like a Portlet, but is able to participate in a MVC in an MVC workflow. This is in the package org.spring framework.web.portlet.mvc. The default the C in MVC, the default handler is still a very simple controller interface offering just two methods: void handle action request response, model and view handle render request response. The framework also includes most of the same controller implementation hierarchy such as abstract controller, simple form controller, and so on. Data binding, command object usage, model handling, and view resolution are all the same as in the Servlet framework. Now we are, as an example 4, we are focusing on dispatcher portlet. Like ordinary portlets, the dispatcher portlet is declared in the portlet.xml file in your web application. The class dispatcher portlet, central dispatcher for use within the Portlet MVC framework, for example for web UI controllers. This dispatches to registered handlers for processing Portlet request. This is in the package org.spring framework.web.portlet. Portlet MVC is a request-driven web MVC framework designed around Portlet that describe dispatches requests to controllers and offers other functionality facilitating the development of Portlet applications. Spring's dispatcher portlet, however, does more than just that. It's completely integrated with the Spring application context and allowed you to use every other feature Spring has Like ordinary portlets, the dispatcher portlet is declared in the portlet .xml file of your web application. The dispatcher portlet now needs to be configured. In the Portlet MVC framework, each dispatcher portlet has its own application context, which inherits all the beans already defined in the root web application context. These inherited beans can be overridden in the portlet specific scope, and new specific beans can be defined local to given portlet instance. The framework will, on initialization of the dispatcher portlet, look for the file name portlet name portlet-name portlet.xml in the webinf directory of your web application and create beans defined there, overriding the definition of any beans defined in the same name in the global scope. The config location by the location used by the dispatcher portlet can be modified through portlet initialization parameters. Spring dispatcher portlet has a few special beans in uses in order to be able to process requests and render the appropriate views. These beans are included in Spring Framework and can be configured in a web application context just as any other bean would be configured. Each of these beans is described in more when dispatcher portlet is set up for use and request comes for the specific dispatcher portlet, start processing the request. First, the local returned by portlet request.getLocal is bound to the request to let the elements in the process resolve the local to use in the processing request, rendering the view, preparing data, etc. Step 2, if the multipart resolver is specified and this is an action request, the request is inspected for multiparts, and if they are found, it is wrapped in a multipart action request for further processing by other elements in the process. Step 3, an appropriate handler is searched for. If the handler is found, the execution chain associated with the handler, preprocessors, postprocessors, and controllers will be executed in order to prepare the model. Step 4, if the model is returned, the view is rendered using a view resolver that has been configured in a web application context. If no model is returned, which could be due to the pre or post processor intercepting request, for example security reasons, no view is rendered since the request could already have been filled. Exceptions that are thrown during processing of requests get picked up by any of handler exception resolvers that are declared in the web application context. Using these exception resolvers, you can define custom behavior in case such exception get thrown. You can customize Spring dispatcher portlet by adding context parameter in the portlet.xml file or portlet init parameters. As an example 5, we can consider controllers. Here is a short example of example consisting of a class and a declaration of a web application context. The class abstract controller, convenient superclass for controller implementation using the template method design pattern. This is in the package org.springframework.web.portlet.mvc. Of course, you just controller interface isn't enough. To provide basic infrastructure, all of the Spring Portlet MVC's controllers inherit from abstract controller. a class offering access to Spring's application context and control over caching. The require session and cache seconds properties are declared in Portlet content generator class, which is a superclass of abstract controller, but are included here for completeness. When using abstract controller as a base class for your controllers, which is not recommended since there are a lot of other controllers that might already do the job for you, you only have to override either handle action request internal action request action response method, or the handle render request internal render request and render response method, or both. Implement your logic and return model and view object in case of handle render request internal. The default implementation of both handle action request internal and handle render request internal throw a portlet exception. This is consistent with the behavior of generic portlet from the JSR 168 specification API. So you only need to override the method that your controller is intended to handle. Here is a short example consisting of a class and a declaration in the web application context. The class above here and the declaration in the web application context is all you need besides setting up a handler mapping to get the very simple controller working. As an example 6, we are considering Portlet model handler mapping in handler mappings. This is a simple handler mappings that map incoming request based on the current mod of the portlet. For example, view, edit, help, an example. The class portlet model handler mapping implementation of the handler mapping interface to map the current portlet mod to request handler beans. This is in the package org.springframework.web.portlet.handler. As an example 7, we are considering handling a file upload in a form in multipart file upload support. So to be able to upload files using a form, declare the resolver mapping the controller that will process the bean and the controller itself. The class common portlet multipart resolver implementation for Apache Commons file upload 1.2 or above. This is in the package org.springframework.web.portlet.multipart. After the portlet multipart resolver has finished doing its job, the request will be processed like any other. To use portlet multipart resolver, create a form with an upload field. and then let Spring bind the file into a form. To actually let the user upload the file, we have to create JSP HTML form. As you can see, we have created a field name file that matches the property that of the bean that holds the byte array. Furthermore, we have added the encoding attribute enctype equal multipart form data, which is necessary to let the browser know how to encode the multipart fields. Do not forget this. Just as any other property that's not automatically convertible to string or primitive type to be able to put binary data in new objects, you have to register a custom editor with the Portlet request data binder. There are a couple of editors available for handling files and settings. The results of on an object. There is a string multipart file editor capable of converting files to strings using a user-defined character set, and there is a byte array multipart file editor which converts the files to byte arrays. They function analogous to custom data editor. So to be able to upload files using form, declare a resolver, a mapping to a controller, that will process the bean and the control itself. After that, create the controller and the actual class to hold the file property. As you can see, the file upload bean has a property of type byte. That holds the file. The controller registers a custom editor to let Spring know how to actually convert the multipart objects. The resolver has found two properties specified by the bean. In this example, nothing is done with the byte array property of the bean itself, but in practice you can do whatever you want. Save it in the database, mail it to somebody, etc. Cast the bean. Let's see if there's content here. That's strange. The user did not upload anything. Do something with the file here. To be able to convert multipart instance to byte array, we have to register a custom editor. Now Spring knows how to handle multipart object and convert. As an example 8, we are considering setting up a dispatcher for annotation support in annotation based controller configuration. However, if you are defining a custom handler mapping, so handler adapters, then you need to make sure the corresponding custom default annotation handler mapping and or annotation methods handler adapter is defined as well, provided that you are intended to use at request mapping. The class the default annotation handler mapping implementation of a handler mapping interface that map handlers based on the portlet mods expressed through request mapping annotation at the type or method level. The class annotation method handler adapter implementation of the handler adapter interface that maps handler methods based on the portlet mods. Action, render paces, and request parameters expressed through the request mapping annotation. These both classes are in the package org.springframework.web.portlet.muc.annotation. The at request mapping will only be processed if a corresponding handler mapping for type level annotations or handler adapter for method level annotation is present in the dispatcher. This is the case by default both dispatcher servlet and dispatcher portlet. However, if you are defining custom handler mapping, so handler adapters, then you need to make sure that corresponding custom default annotation handler mapping and or annotation method handler adapter is defined as well, provided that you intended to use at request handler mapping. Defining a default annotation handler mapping and or annotation method handler adapter explicitly also makes sense if you would like to customize the mapping strategy. For example, specifying a custom web binding initializer. Controller bean definitions. Here we are considering mapping request with at request mapping in annotation based controller configuration. Following is an example of form controller form from the pet portal sample, for example sample application using this annotation. At request mapping annotation is used to map portlet mods like view, edit into entire class or particular handler method. Typically a type level annotation maps the specific mod or the mod plus the parameter condition onto a form controller with additional mod level annotation narrowing the primary mapping for specific portlet request parameters. At request mapping at the type level may be used for plain implementation of the controller interface as well. In this case, request processing mode would allow follow the additional handle action render request signature, while the controller mapping would be expressed through at request mapping annotation. This works for pre-built controller base class such as simple form controller to as an example. Following is an example of form controller from the pet portal sample application using annotations. Handler methods which are annotated with at string mapping are allowed to have flexible signatures, very flexible signatures. binding request parameters to method parameters with at request param, the at request param here is not with at request param annotation is used to bind request parameters to the method parameter in your controller. Parameters using the annotation are required by default, but you can specify the with that parameter is optional by setting at request params required attribute to false. For example, at request param name equal id and required is equal false. Here at request param, annotated parameters for access specific portlet request parameters. Parameter values will be converted to the declared method argument type. Here any other type using attribute name is specified to at model attribute at the method level or default attribute name based on the return type class name or the class name. The model will be implicitly enriched with the command object and result of at model at annotated reference data accessor methods. Providing a link to data from model with at model attribute. At model attribute has two usage scenarios in controllers. When placed on a method parameter, at model attribute is used to map a model attribute to the specific annotated method parameter. You can see in the populate site method here. This is how the controller gets a reference to the object holding the data entered in the form. In addition, the parameter can be declared as specific type of the form backing object rather than a generic java.land.object, thus increasing type safety. At model attribute is also used at the method level to provide reference data for the model. For this usage, the method signature can contain the same types as documented above for the request mapping annotation. At model annotated methods will be executed before chosen at request annotated handler method. They effectively pre-populate implicit model with specific attribute often loaded from the database. Such an attribute can then already be accessed through at model attribute annotated handler method parameter in a chosen handler method, potentially with binding and validation applied to it. Here you can see the two usages of this annotation here. Specifying attributes to store a session with at session attributes. The type level at session attribute annotation declares a session attribute to be used by a specific handler. This will typically list the names of model attributes or types of model attributes which should be transparently stored in the session or some conversational storage, serving as a form backing beans between subsequent requests. The following code is snippet. Here you can see the usage of this annotation. The default is action equal list here. Render pace used for the initial form as well as for redisplaying with errors. Action pace. As an example 9, we are considering Portlet application deployment. In order to Portlet contain a web app to make calls to your project web app, it must make cross context calls to well-known servlet that provide access to the Portlet services defined in your portlet.xml file. The process of deploying a Spring Portlet MVC application is no different than deploying any JSR 286 Portlet application. However, this area is confusing enough in general that is worth taking about here briefly. Generally, the Portlet container runs on a web app in your servlet container, and your portlets run in another web app in your servlet container. In order to Portlet contain a web app to make calls to your Portlet web app, it must make cross-content calls to a well-known servlet that provide access to the Portlet services defined in your portlet.xml file. The JSR 286 specification does not specify exactly how this should happen, so each Portlet container has its own mechanism for this, which usually involves some kind of deployment process that makes changes to the Portlet web app itself and then register the portlets within the Portlet container. At a minimum, the web.xml file in your Portlet web app is modified to inject the well-known servlet that Portlet container will call. In some cases, a single servlet will service all portlet in the web app. In other cases, there will be instance of the servlet for each portlet. Some Portlet containers will also inject libraries or configuration files into web app as well. The Portlet container must also make its implementation of the Portlet JSP tag library available to your web app. The bottom line is that it is important to understand the deployment needs of your target portal and make sure they are met, usually by following the automated deployment process it provides. Be sure to carefully review the documentation from your portal for this process. Once you have deployed your portlet, review the resulting web.xml file for sanity. Some older portals have been known to corrupt the definition of view renderer servlet, thus breaking the rendering of your portlets. As an example, as an exception example, we are considering here class simple mapping exception resolver. Portlet MVC also provides the portlet specific concrete simple mapping exception resolver that enables you to take the class name of any exception that might be thrown and map it to a view name. The class simple mapping exception resolver handler exception resolver implementation that allow for mapping exception class names to view names, either for a set of given handlers or for all handlers in the dispatcher portlet. This is in the package org.springframework.web.portlet.handler. Just like servlet MVC, the Portlet MVC provide handler exception resolvers to ease the pain of unexpected exceptions that occur while your request is being processed by a handler that matched the request. The Portlet MVC also provide a Portlet specific concrete simple mapping exception resolver that enable you to take the class name of any exception that might be thrown and map it to a view name. As an exception example 2, we can consider class no handler found exception. Exception to be thrown if the dispatcher portlet is unable to determine a corresponding handler for an incoming portlet request. This is in the package org.springframework.web.portlet. As an example, we can consider this occurred in Spring and Hibernate. Here you can see could not complete the request, no matching handler method found in the portlet request mode view paste render face parameter map. Here you can see the at org.springframework.web.portlet.mvc.annotation.annotation method handler adapter portlet handler method resolver handler method annotation method handler adapter, etc. Now we are focusing on AOP. The Spring AOP module provides an AOP Alliance compliant object oriented programming implementation, allowing you to define, for example, method interceptors and point cuts to clarify, decouple code that implements functionality that should be separated. Using source level metadata functionality, you can also incorporate behavioral information into your code in a manner similar to that of .NET attributes. Here you can see a Spring Framework aspect-oriented programming terminology. Before starting the work with Spring aspect-oriented programming, you should become familiar with the concepts of aspect-oriented programming and its terminologies. Some of the terms are not Spring specific, but they are related to AOP. Aspect. This module has a set of APIs providing cross-cutting requirements. Like, for example, a logging module would be calling AOP aspect for logging. The application can have any number of aspects depending on the requirements. Joint point. This represents the point, the application where Spring AOP aspect can be plugged in. In another way, you can say that it is the actual place in your application where the action will be taken using Spring AOP framework. Advice. This is the action taken either before or after execution of the method. This is an actual piece of code that gets invoked during the execution of the program by the Spring framework. Point cut. It can be understood as an expression language of a Spring AOP that join points. Introduction. It means an introduction of additional methods and fields for a type. Also, it allows you to introduce new interface to any advice object. Target object. The object advises by one or more aspects, and it is also known as the proxied object in the Spring framework as Spring AOP implement using the runtime proxies. Or weaving. Weaving is considered as the process of linking the aspect with other application types or objects to create an advice object. Weaving done at runtime, done at the time of compilation or during the load time or runtime. Spring AOP performs weaving during runtime. Interceptor. It is an aspect which contains advice, join point, etc. These terms are not Spring specific. Unfortunately, AOP terminology is not particularly intuitive. However, it would be even more confusing if Spring used its own terminology. Aspect. Modularization of a concern that cuts across multiple classes. Transaction management is a good example of cross-cutting concern in enterprise Java applications. In Spring AOP, aspects are implemented by using regular classes, the schema-based approach or regular classes annotated with the @aspect annotation, the @aspect style. Join point. A point during the execution of a program, such as execution of a method or the handling of an exception. In Spring AOP, a join point always represents a method execution. Advice. Action taken by an aspect at a particular join point. Different types of advice include around, before, and after advice. Many AOP frameworks, including Spring model, an advice as an interceptor and maintain a chain of interceptors around a join point. Point cut, a predicate that matches join points. Advice is associated with the point cut expression and runs at any point cut, any join point matched by the point cut. For example, the execution of a method with a certain name. The concept of a join points as matched by point cut expression is central to the AOP, and Spring uses aspect-J point cut expression language by default. Introduction: declaring additional methods or fields on behalf of a type. Spring AOP lets you to introduce new interfaces and a corresponding implementation to any advised object. For example, you could use an introduction to make a bean implement and is modified interface to simply caching. An introduction is known as an inner type declaration in aspect-J community. Target object, an object being advised by one or more aspects, also referred to as advised object. Since Spring AOP is implemented by using runtime proxies, this object is always a proxied object. AOP proxy, an object created by AOP framework in order to implement the aspect contracts, advice method, execution, so on. In the Spring framework, an AOP proxy is a JDK dynamic proxy or CG lib proxy. Weaving, linking aspects with other application types or objects to create an advice object. This can be done at compile time using aspect-J compiler, for example, load time, or at runtime. Spring AOP, like other pure Java AOP frameworks, performs weaving at runtime. AOP concepts and terminology. Let's briefly go over the concept and terminology specific to AOP. I'm going to discuss some concepts and terminology here. Here, join point. A join point is a point during the execution of a program, such as the execution of a method or the handling of an exception. In Spring AOP, join point always represent a method execution. Point cut. A point cut is a predicate that helps match an advice to be applied by an aspect at a particular join point. We often associate an advice with the point cut expression, and it runs at any join point matched by the point cut. An advice is an action taken by a aspect of a particular join point. Different types of advice include around, before, and after. In Spring, an advice is modeled as an interceptor, maintaining a chain of interceptors around a join point. Here you can see point cuts, and here you can see join points. And this is execution of a program, and this is advice. Here now we are focusing on Spring AOP process. Here you can see JDK proxy interface based and CG-lib proxy class based. Spring AOP is proxy based AOP framework. This means that to implement aspect to the target object, it will create proxies of that object. This is achieved using either of two ways: JDK proxy, JDK dynamic proxy. The preferred way of Spring AOP, whenever the target object is implements even one interface, then JDK dynamic proxy will be used. CG-lib proxy, if the target object doesn't implement an interface, then CG-lib proxy can be used. AspectJ, on the other hand, doesn't do anything at runtime, as the classes are compiled directly with aspects. And so, unlike Spring AOP, it doesn't require any design patterns to view the aspects of to the code. It introduces its compiler known as AspectJ compiler (AJC), through which we compile our program and then runs it by supplying a small, less than 100K runtime library. Here you can see JDK proxy interface based. Here you can see aspect interacts with target object implement. In Spring proxy you can see aspect and target object implement, and target object is connected to target object IMPL is connected to target object, and it's target object IMPL implements target object Java interface, and Spring proxy implements target object here. And here Spring proxy under Spring proxy aspect is aspect interacts with target object, and Spring proxy extend target object here is a Java class. In CG-lib proxy, this is class based. As an example, we are considering the Maven segment here. Here you can see artifact ID, Spring-AOP, Spring AOP. Spring AOP provides an Alliance compliant aspect oriented programming implementation, allowing you to define method interceptors and point cars to cleanly decouple code that implements functionality that should be separated. As an example too, we can consider package org.aop alliance.aop, the core AOP alliance advice marker. As an example 3, we can consider package AOP org.aop alliance.intercept, the AOP alliance in the reflective interception abstraction. As an example 4, we can consider package org.springframework.aop, core Spring AOP interfaces built on AOP alliance AOP interoperability interfaces. Here we are considering enabling at AspectJ support with Java configuration. In enabling at AspectJ support, to enable AspectJ support with Java at configuration, at enable AspectJ auto proxy annotation, as the following example shows. Annotation type at enable AspectJ auto proxy enables support for handling components marked with AspectJ's at aspect annotation, similar to the functionality found in the Spring's AOP AspectJ auto proxy XML element to be used with at configuration classes as follows here. This is in the package org.springframework.context.annotation. To to enable aspect-J at aspect-J support with XML-based configuration, use the AOP colon aspect-J auto proxy element as the following example shows. This assumes that you use schema support now we are considering declaring an aspect as an example 6 in at aspect-J support. Not very useful aspect class definition, which is annotated with the org.aspect-j.lang.annotation.aspect annotation. The annotation type aspect declaration. This is in org.aspect-j.lang.annotation here. This is with this is related to aspect-J. With aspect-J support enabled, any bean defined in your application context with the class that is an at aspect that has aspect at aspect annotation is automatically detected by Spring and used to configure Spring AOP. The next two examples show the minimal definition required for a not very useful aspect. The first of the two example here shows a regular bean definition in the application context that point to a bean class that has at aspect annotation. The second of the two examples here, this one, shows the not very useful aspect class definition, which is annotated with the org.aspect.aspect-j.lang.annotation.aspect annotation. Aspects class annotated with the at aspect can have methods and fields the same as any other class. They can also contain point cut, advice, and introduction, intertype declarations. Auto-detecting aspect through component scanning. You can register aspect classes as regular beans in your XML configuration via at bean methods at configuration classes, or have Spring auto-detect them through class path scanning the same as any other Spring managed bin. However, note that at aspect annotation is very sufficient for auto detection in the class path. For that purpose, you need to add a separate component annotation, or alternatively a custom stereotype annotation that qualified as per the rules of Spring's component scanner. Advising aspect with other aspects. In Spring AOP, aspects themselves cannot be the targets of advice from other aspects. The at aspect annotation on a class marks it as an aspect and hence excludes it from auto proxying. At aspect public cast, here you can see the code here and configure properties of the aspect here. As an example 7, we can see we can consider this an AOP example here. We can put some now that you have seen all the constituent parts work, we can put them in together to do something useful. The execution of business services sometimes fail due to concurrency. Concurrency issues, for example, a deadlock loser. If the operation is retried, it is likely to succeed on the next try. For business services where it is appropriate to retry such conditions, idempotent operators that do not need to go back to the user for conflict resolution, we want to transparently retry the operation to avoid the client seeing pessimistic locking failure exception. This is a requirement that clearly cut across multiple services in the service layer, and hence it is ideal for implementing through an aspect. Because we want to retry the operation, we need to use round advice so that we can call proceed multiple times. The following listing shows the basic aspect implementation. Note that the aspect implements the ordered interface so that we can set the precedence of the aspect higher than the transaction advice. We want a fresh transaction each time we retry. The max retries and order properties are both configured by Spring. The max retries, the main action happens in the do concurrent operation around advice. Note that for the moment we apply the retry logic for each business service. We try to proceed, and if we fail the pessimistic locking failure, we try to proceed, and if we fail with the pessimistic locking failure exception, we try again unless we have exhausted all of our retry attempts. The corresponding Spring configuration follows. Now we are, as an example 8, we are considering an AOP schema example in schema based AOP support. Here this shows how the concurrent locking feature locking failure retry example looks when rewritten with schema support. Here the execution of business services sometimes fail due to concurrency issues, for example a deadlock loser. If the operation is retried, it is likely to succeed on the next try. For business services where it is appropriate to retry in such conditions, idempotent operations that do not need to go back to the user for conflict resolution. We want to transparently retry the operations to avoid the client seeing a pessimistic locking failure exception. This is a requirement that cuts across multiple services in the service layer, hence is ideal for implementing through an aspect. Because we want to retry the operation, we need to use around around advice, so that we can call proceed multiple times. The following listing shows the basic aspect implementation, which is a regular Java class that uses schema support. Note that the aspect implements the ordered interface so that we can set the precedence of the aspect higher than the transaction advice. We want a fresh transaction each time we retry. The max retries and order properties are both configured by Spring. The main action happens in the do concurrent operation around advice method. We try to proceed. If we fail with the pessimistic locking failure exception, we try again unless we have exhausted all of our retry attempt. This class is identical with the aspect J example previously, but with the annotations removed. Corresponding Spring configuration is as follows. Note that for the time being, we assume that all business services are idempotent. If this is not the case, we can refine the aspect so that it retries only genuinely idempotent operations by introducing idempotent annotation and using annotation to annotate the implementation of service operations. As an example 9, we are considering at aspect J or XML for string AOP in choosing which AOP declaration style to use. For example, in the aspect J style, you can write something like following. If you have chosen to use Spring AOP, you have choice of at aspect J or XML style. There are various trade-offs to consider. With the XML style, you may be the XML style may be most familiar to existing Spring users, and it is backed by genuine POJOs. When using AOP as a tool to configure enterprise services, XML can be a good choice. A good test is whether you consider point cut expression to be a part of your configuration that you might want to change independently. With the XML style, it's arguably clearer from your configuration which aspects are present in the system. With XML, the XML style has two disadvantages. First, it does not fully encapsulate the implementation of the requirement it addresses in a single place. The dry principle says that there should be a single, unambiguous, authoritative representation of any piece of knowledge within the system. When using XML style, the knowledge of how a requirement is implemented is split across the declaration of the backing bean class and XML in the configuration file. When you use at aspect J style, this information is encapsulated in a single module, the aspect. Secondly, the XML style is slightly more limited in what it can express than the aspect J style. Only the singleton aspect installation, only the singleton aspect instantiation model is supported, and it is not possible to combine named, point cut, declared in XML. For example, in aspect J style, you can write something like following. In XML style, you can declare first two point cuts. The downside of XML approach is that you cannot define account proper access point cut by combining these definitions. The at aspect J style supports additional instantiation models and richer point cut composition. It has advantage of keeping the aspect as a modular unit. It also has advantage that the at aspect J aspects can be understood and thus consumed both by Spring AOP and by aspect J. So if you later decide you need the capabilities of aspect J to implement additional requirements, so you can easily migrate to a classic aspect J setup. On balance, the Spring team prefers the at aspect J style for custom aspects beyond simple configuration for enterprise services. It is as an example 10, we are considering mixing aspect types. It is perfectly possible to mix at aspect J style aspects by using auto proxy support, schema defined, AOP colon aspects, AOP colon advisor, declared advisor, and even proxies and interceptors in other styles in the same configuration. All of these are implemented by using same underlying support mechanism and can coexist without any difficulty. Now we are considering proxying mechanisms. To force the use of cglib proxies, set the value of the proxy target class attribute of the AOP colon config element to true as follows here. To force cglib proxying, when you use the aspect J auto proxy support, set the proxy target class attribute of the AOP colon aspect J auto proxy element to true as follows. Spring AOP uses either JDK dynamic proxies or cglib cglib proxies to create the proxy for a given target object. JDK dynamic proxies are built into the JDK, whereas cglib is a common open source class definition library repackaged into Spring Core. If you want to force the use of cglib proxying, for example, to proxy every method defined for the target object, not only those implemented by its interfaces, you can do so. However, you should consider the following issues. With cglib, final methods cannot be advised, as they cannot be overridden in runtime generator subclasses. As of Spring 4.0, the constructor of your proxied object is not called twice anymore. Once the cglib proxy instance is created through Obgenesis, only if your JVM does not allow you for constructor bypassing, you might see double invocations and corresponding debug log entries from Spring's AOP support. Multiple AOP semicolon config sections are collapsed into single unified auto proxy creator at runtime, which applies the strongest proxy settings of any of the AOP config sections, typically from different XML bean definitions files specified. This is also applied to the TX colon annotation driven and AOP colon aspect J auto proxy. To be clear, using proxy target class equal true on TX colon annotation driven AOP colon aspect J auto proxy or AOP colon config elements forces the use of cglib proxies for all three of them. Here we are considering understanding AOP proxies in proxying mechanisms. Consider the first scenario here where you have a plain vanilla unproxied, nothing special about it, straight object reference. As following code snippet shows. Spring AOP is proxy based. It is vitally important that you grasp the semantics of what the last statement actually means before you write your own aspect aspects or use any of the Spring's AOP based aspects applied with the Spring framework. Consider the first the scenario here where you have a plain vanilla unproxies, nothing special about it, straight object reference as following code snippet shows. This next method invocation is the direct call on this reference. Some logic here. This is the direct method call on the POJO reference. Here calling code interacts with plain object. Things change slightly when the reference that client code has a proxy. Consider the following diagram and the code snippet. The class proxy factory for AOP proxies for programmatic use rather than via declarative setup in a bean factory. This class provides a simple way of obtaining and configuring AOP proxy instances. In a custom user code. This is in the package org.springframework.aop.framework. The key thing to understand here is that the client code inside the main method of the main class has a reference to the proxy. This means that method calls on that object reference are calls on the proxy. As a result, the proxy can delegate to all the interceptors advice that are relevant to that particular method call. However, once the call has finally reached the target object of the simple POJO reference in this case, any method calls that it may make itself, such as this dot bar or this dot foo, are going to be invoked against this reference and not the proxy. This has important implications. It means that self invocation is not going to result in advice associated with the method invocation getting a chance to run. This next method invocation is a direct call to this reference. Some logic here. This is a method call on the proxy. Foo on the proxy, then foo on the object, pojo.foo. In example 12, we are focusing on programmatic creation of at aspect-j proxies. The basic usage aspect-j proxy factory is very simple, as the following example shows. The class aspect-j proxy factory, aspect-j based proxy factory, allowing for programmatic building of proxies, which include aspect-j aspect, code style as well as annotation style. This is in package org.springframework.aop.aspect-j.annotation. In addition to declaring aspects in your configuration by using either AOP config or AOP aspect-j autoproxy, it is also possible to programmatically create proxies that advise target objects. Here we want to focus on the ability to automatically create proxies by using at aspect-j aspects. You can use org.springframework.aop.aspect-j.annotation.aspect-j proxy factory class to create proxy for a target object that is advised by one or more aspect-j aspects. Basic usage for this class is very simple, as following example shows. Create a factory that generate a proxy for a given target object. Add an aspect. The class must be an at aspect-j aspect. You can call this as many times as you need with the different aspects. You can also add existing aspect instances. The type of the object supplied must be at aspect-j aspect. Now get the proxy object. As an example 13, we are considering load time weaving with aspect-j in Spring Framework in using aspect-j with Spring applications. The following example shows the aop.xml file. Assume that you are an application developer who has been tasked with diagnosing a cause of some performance problems. In a system. Rather than breaking out the proofing tool, we are going to switch to a simple proofing and proofing aspects that let us quickly get some performance matrices. We can then apply a finer grain proofing tool to that specific area immediately afterwards. Example presented here uses XML configuration. You can also configure and use at aspect-j with Java configuration, especially when you use the at enable load time weaving annotation as an alternative to context load time weaver. The following example shows the profiling aspect, which is not fancy. It is a time-based profiler that uses the at aspect-j style of aspect declaration. We also need to create an meta inf /aop.xml to inform the aspect-j viewer that we want to view our profiling aspect into our classes. This file convention namely the presence of a file or files in Java class path called meta -inf /aop.xml is standard aspect-j. Following example shows the aop.xml here. only view classes in our application specific packages. View in just in this aspect. Now we can move on to the Spring specific portion of the configuration. We need to configure the load time viewer. This load time viewer is essential component responsible for viewing the aspect configuration in one or more meta-inf/aop.xml files in the classes in your application. The good thing is that it does not require a lot of configuration. There are more options that you can specify, but these are they are specified as can be seen in this example. Now that all the required artifacts, the aspect meta-inf /aop.xml file and Spring configuration are in place, we can create the following driver class with main method to demonstrate the LTV. A service object, we will be profiling its methods. This switches on the load time viewing. The profiling aspect is woven around this method execution. We have one last thing to do. Introduction of this did say that one could switch the LTV selectively on on per class loader basis with Spring, and this is true. However, for this example, we use the Java agent supplied with string to switch the LTV, switch on LTW. We use the following command to run the main class shown previously. The -java agent is a flag for specifying and enabling agents to instrument program that run on the JVM. Spring Framework ships with such an agent, the instrumentation saving agent, which is packaged in the Spring instrument.jar. That was supplied as a value of the -java agent argument in this example. The output from the execution of the main program looks something like here. I have introduced a thread.sleep method statement into the calculate entitlement method implementation, show that the profiler can actually capture something other than 0 millisecond. The 0, 1, 2, 3, 4 millisecond is not an overhead introduced by the AOP. The following listing shows the output we got when we run our profiler. The following example specifies reflective load time weaver. The annotation type enable load time weaving activates a Spring load time weaver for this application context, available as a bean with the name load time weaver, similar to the context colon load time weaver element in Spring XML. This is in the package org.springframework.context.annotation. To specify a specific load time weaver with Java configuration, implement load time weaver configurer interface and override the get load time weaver method. Following example specify a reflective load time weaver. If you use XML based configuration, you can specify a fully qualified class name as the value of the weaver class attributes on the context colon load time weaver element. Again, the following example is specify a reflective load time weaver. The load time weaver that is defined and registered by the configuration can later be retrieved by the Spring container by using well-known name load time weaver. Remember that load time weaver exists only as a mechanism for Spring's LTW infrastructure to add one or more class file transformers. The actual class file transformer does not that does the LTW is the class preprocessor agent adapter from the org.aspectj.weaver.loadTime package class. As an example 15, we can consider regular expressions point cuts in convenience point cut implementations. Point cut API in Spring. The following example shows how to use JDK reg expect method point cut. The class JDK reg expect method point cut regular expression point cut based on the java.util.regress package supports the following Java Bean properties: pattern regular expression for the fully qualified method names to match, and patterns alternative property taking a string array of patterns. The result will be the union of these patterns. This is in the package org.springframework.aop.support. One obvious way to specify static point cut is regular expressions. Several AOP frameworks beside the Spring make this possible. org.springframework.aop.support.jdk reg expect method point cut is a generic regular expression point cut that uses the regular expression support in JDK. With the reg expect method point cut, you can provide a list of pattern strings. Any of this is a match. Point cut evaluates to true. As a consequence, the resulting point cut is effectively a union of the specified patterns. Following example shows how to use JDK reg expect method point cut. As an example 16, we are considering interception around advice in advice types in Spring in advice API in Spring. Following example shows a simple method interceptor implementation. Interface method interceptor intercepts calls on an interface on its way to the target. These are nested on top of the target. This is in the package org.aop-alliance.intercept. Interception around advice, the most fundamental advice type in Springs is the interception around advice. Spring is compliant with AOP Alliance interface for around advice that uses method interception. Classes that implement method interceptor and that implement around advice should also implement the this interface. The method invocation argument to invoke method exposes the method being invoked, the target join point, the AOP proxy, and the argument to be to the method. The invoke method should return the invocation's result, the return value of the join point. The following example shows simple method interceptor implementation. Note the call to the proceed method of method invocation. This proceeds down to the interceptor chain towards the join point. Most interceptors invoke this method and returns its return value. However, a method interceptor, like any around advice, can return a different value or throw an exception rather than invoke the proceed method. However, you do not want to do this without good reason. Method interceptor implementations offer interoperability with other AOP Alliance compliant AOP implementations. While there are an advantage in using the most specific advice type, stick with method interceptor around advice if you want to run the aspect of another AOP framework. Note that point cuts are not currently interoperable between frameworks, and AOP Alliance does not currently define point cut interfaces. Now we are considering proxying interfaces in using the proxy factory bean to create AOP proxies. Class proxy factory bean, the factory bean implementation that builds an AOP proxy based on beans in a Spring Bean factory. Consider a simple example of proxy factory bean in action. This example involves a target bean that is proxied. This is the person target. person target bean definition in the example, and an advisor and an interceptor used to provide advice, an AOP proxy bean definition to specify the target object, person target bean the interfaces to proxy and advisors to apply. The following listing shows the example here. Note that the interceptor names property takes a list of string which holds the bean names of the interceptors and or advisors in the current factory. You can use advisors interceptors before, after returning, and throws advice objects. The ordering of advisors is significant. You might be wondering why the list does not hold bean references. The reason for this is that if the singleton property of the proxy factory bean is set to false, it must be able to return independent proxy instances. If any of the advisors is itself a prototype, an independent instance would need to be returned. So it is necessary to be able to obtain an instance of a prototype of the prototype of the factory. Holding a reference is not sufficient. The person bean definitions shown earlier can be used in place of a person implementation as follows. Creating AOP proxies programmatically with the proxy factory. The following listing shows the creation of a proxy for a target object with one interceptor and one advisor. The class proxy factory for AOP proxies for programmatic use rather than via declarative setup in a bean factory. This class provides a simple way to obtaining and configuring AOP proxy instances in a custom user code. This is in the package org.springframework.aop.framework. It is easy to create AOP proxies programmatically with Spring. This lets you use Spring AOP without dependency on Spring IOC. The interfaces implemented by target objects are automatically proxied. The following listing shows creation of a proxy for a target object with one interceptor and one advisor. The first step is to construct an object of type org.springframework.aop.framework.proxyFactory. You can create this with the target object as in this example, or specify the interfaces to be proxied in an alternate constructor. You can add advisors with interceptors as a specialized kind of advice, or advisor or both, and manipulate them for the life of the proxy factory. If you add introduction, interception around advisor, you can cause the proxy to implement additional interfaces. There are also convenient methods on proxy factory inherited from advised support that let you to add other advice types, such as before and throws advice. Advice support is the superclass of both proxy factory and proxy factory bean. Integrating AOP proxy creation with IOC framework is best practice in most applications. We recommend that you externalize configuration from Java code with AOP, as you should in general. Now in this example we are focusing on manipulating advice objects. The following example shows casting an AOP proxy to a advice interface and examining and manipulating its advice. Interface to be implemented by classes that hold the configuration of a factory of AOP proxies. This configuration includes the interceptors and other advisor and proxy interfaces. This is in the package org.springframework.aop.framework. However, you can create AOP proxies. You can manipulate them by using org.springframework.aop.framework.advice interface. Any AOP proxy can be cast to this interface, no matter which other interfaces it implements. The get advisors method returns an advisor for every advisor, interceptor, and other advice type that it has been added to the factory. If you added an advisor, the returned advisor at this index is the object that you added. If you added an interceptor or any other type, Spring wrapped this in an advisor with a point cut that always returns true. Thus, if you added method interceptor, the advisor returns for this index is default point cut advisor that returns a method interceptor and a point cut that matches all classes and methods. The add advisor methods can be used to add any advisor. Usually the advisor holding point cut and an advice in generic default point cut advisor, which you can use with any advice or point cut, but not for introductions. By default, it is possible to add or remove advisors or interceptors once a proxy has been created, the only restriction is that it is impossible to add or remove an introduction advisor, as existing proxies from the factory do not show the interface change. You can obtain a new proxy from the factory to avoid this problem. Following example shows casting AOP proxy to the advice interface and examining and manipulating its advice. It is questionable whether it is advisable, no pun intended, to modify advice on a business object in production, although there are no dubbed legitimate use cases. However, it can be very useful in development, for example in tests. We have sometimes found it very useful to be able to add test code in the form of an interceptor or other advice getting inside a method invocation that we want to test. For example, an advice can get inside the transaction created for that method, perhaps to run SQL to check that database was correctly updated before making the transaction for rollback. Depending on how you created the proxy, you can usually set a frozen flag. In that case, the advised is frozen method returns true, and any attempts to modify advice through addition or removal result in an AOP config exception. The ability to freeze the state of an advice object is useful in some cases, for example, to prevent calling code removing security interceptor. Add an advice like interceptor without a point cut, which match all proxied methods, can use for interceptors before after returning or throws advice. Add selective advice using a point cut. As an example 20, we are considering bean name autoproxy creator in autoproxy bean definitions in using the autoproxy facility. The following example shows how to create bean name autoproxy creator bean. Class bean name autoproxy creator that identifies beans to proxy via a list of names, checks for direct XXX asterisk and asterisk XXX matches. This is in the package Spring framework.aop.framework.autoproxy. The bean name autoproxy creator class is a bean post processor that automatically creates AOP proxies for beans with names that match the literal values or wildcards. The following example shows how to create a bean name autoproxy creator bean. As with proxy factory bean, there is an interceptor names property rather than a list of interceptors to allow correct behavior for prototype advisors. Named interceptors can be advisors or any advice types. As with autoproxy in general, the main point using bean name autoproxy creator is to apply the same configuration consistently to multiple objects with minimal volume of configuration. It is a popular choice for applying declarative transaction to multiple objects. Bean definition whose names match, such as JDK my bean and only JDK in the in this example are plain old bean definitions with target class. An AOP proxy is automatically created by the bean name auto proxy creator. Say the same advice is applied to all matching beans. Note that if advices are used rather than the interceptor in this example, the point cuts may apply differently to different beans. Here we are considering hot swappable target sources in using target source implementation. You can change the target by using the swap method on hot swappable target source, as following example shows. The class hot swappable target source implementation that catches a local target object but allows the target to be swapped while application is running. This is in the package org.springframework.aop.target. The org.springframework.aop.target.hotswappable target source exists to let the target of the AOP proxy to be switched while callers keep their references to it. Changing target sources target takes effect immediately. The hot swappable target source is thread safe. You can change the target by using swap method on hot swappable target source, as this example shows. The following example shows the required XML definitions. This example swap call changes the target of the swappable bean. Client that hold the reference to that bean are unaware of the change but immediately start hitting a new target. Although this example does not add any advice, it is not necessary to add advice to use a target source. Any target source can be used in conjunction with arbitrary advice. Here we are considering defining new advice type as example 22. Defining new advice types, the org.springframework.aop.framework.adapter package is an SPI package that lets support for new custom advice types be added without changing the core framework. The package org.springframework.aop.framework.adapter SPI, a package allowing Spring AOP framework to handle arbitrary advice types. Spring AOP is designed to be extensible, while the interception implementation strategy is presently used internally. It is possible to support arbitrary advice type in addition to the interception around advice before throws advice and after returning advice. The org.springframework.aop.framework.adapter package is an SPI package that lets support for new custom advice types to be added without changing the core framework. Only constraint on a custom advice type is that it must implement org.springframework.aop AOP marker interface. As an exception example, we can consider class AOP invocation exception that gets thrown when an AOP invocation failed because of misconfiguration or unexpected runtime issues. This is in the package org.springframework.aop. As an error example, we can consider this occurred in the environment with org.springframework.boot and Spring Boot Maven plugin. Error creating bean with the name projecting argument resolver bean post processor. Initialization of bean fail. Nested exception is com.oracle.svm.co.jdk.unsupported feature exception, etc. And here you can see at org.springframework.aop aspect.j expression point cut get target shadow match, etc. Now we are focusing on aspects. The separate Spring aspects module provides integration with aspect.j. As an example, we can consider this Maven segment. Here you can see artifact ID, Spring aspects integrates Spring with aspect.j. As an example 2, we can consider package org.springframework.beans.factory.aspect.j. As an example 3, we are considering package org.springframework.cache.aspect.j. As an example 4, we are considering package org.springframework.context.annotation.aspect.j. Here's another package, package org.springframework.scheduling.aspect.j. Package org.springframework.transaction.aspect.j. As an example 7, we can consider interface configurable object, marker interface for domain objects that need DI through aspects. This is in the package org.springframework.beans.factory.aspect.j. As an example 8, we can consider class aspect.j caching configuration. At configuration class that registers the Spring infrastructure beans necessary to enable aspect-based annotation-driven cache management. This is in the package org.springframework.cache.aspect.j. As an example 9, we can consider class Spring configured configuration. At configuration class that registers an annotation bean configure aspect capable of performing dependency injection services for non-Spring managed objects annotated with at configurable. This is in the package org.springframework.context.annotation.aspect.j. As an example 10, we are considering using aspect.j to dependency inject domain object with string in using aspect.j with Spring applications. Here, if you use Java-based configuration, you can add at enabled Spring configured to any at configuration class as follows. The annotation type enable Spring configured signals the current application context to apply dependency injection to non-managed classes that are instantiated outside the Spring Bean factory, typically class annotated with the at configurable annotation. This is in the package org.springframework.context.annotation.aspect.j. If you prefer XML based configuration, Spring context namespace defines a convenient context colon Spring configured element, which you can use as follows. Instances of at configurable objects created before the aspect have been configured result in a message being issued to the debug log and no configuration object taking place. So at configurable objects are not shown here. This is an example. As an example 11, we can consider class aspect.j async configuration. At configuration class that registers the Spring infrastructure be necessary to enable aspect-based asynchronous method execution. This is in the package org.springframework.scheduling.aspectj. As an example 12, we can consider class aspectj transaction management configuration. At configuration class that registers the Spring infrastructure beans necessary to enable aspectj based annotation driven transaction management for Spring own transaction annotation. Org.spring this is in the package org.springframework.transaction.aspectj.